Now, son, you've got to be brave.
But Daddy, I'm scared of the injection.
You are fat. You're not even wearing a shirt, and you've got a tattoo that says, I am Big Dave.
Get it? Yeah!
What is it? What is it? Of course! Minus. Stop pooing. Cheeky crisps.
It's all breaking down! What am I supposed to do?
Shrek, are you feeling hungry? I sure hope so. Found you this box of Belvita. Why though?
And obviously it goes without saying, watch the Paper One video before this one. Oh my goodness, what is wrong with
How do you Paper 2 for Paper 1?
Babe, I didn't mean to hurt you.
RAM, which stands for Random Access
Memory!
Good donkey. A new challenger enters the scene. 1 3 4 4 6 7. Hello. Ow. Now I want to tell you a story about my daddy.
Oh, delicious.
We're going to bake a pie today. Are you ready to bake a pie with me? Infinite beans! Infinite beans! The beans are never ending! No! Daddy Singer.
Do it.
Welcome to my surgery. Dirty person! Come here, let's have a chat. Paper 2 is absolutely brutal. It will burn your crops and eat your cows. It will set fire to your barn and steal your chickens. It will steal your sheep and eat your piggies. No amount of farmyard analogies are going to get this across to you, but Paper 1 is a walk in the park compared to Paper 2. There are a lot of pitfalls and a lot of serious stuff that you've got to know. Most importantly though, there is a lot of programming. You need to make sure that you, yes, you, have completed the Mr. Singer programming course before starting this. If you don't, you're going to be in for a world of absolute misery. Remember, as we go through this, that Paper 1 is all memory work. Paper 2, I'd say, is maybe 60% doing, 40% memory. There's a lot of programming, a lot of algorithms, a lot of deep stuff, and as long as you do this course in full, you're going to be fine. But what I want to get across is, when I teach you stuff like variables, like data types and all that jazz, please take the time to use Python to actually make these things. Take the time to use them. The analogy I give is a simple one. Most computer scientists aren't known for their love of football. Football bores us because we're generally quite unfit and we don't enjoy going outside and speaking to people. But this analogy will come across for you anyway, I'm sure.
Hey, football!
Paper 1 is knowing the names of all the players on a team. It's knowing where they scored their goals. It's knowing which clubs are in the Premiership, which are in the Championship. It's the facts. It's memorising. It's top trumps. It's trivia, right? As long as you memorise it, you're going to crush it. Paper 2 is where we get out on the pitch and actually start kicking the ball. You must practice. With those formalities out of the way, let us begin Paper 2! Paper 2. To allow parents to book appointments for
Parents' evenings, we just talked about that!
misery. Shrek, are you feeling hungry? I sure hope so. Found you this box of Belvita.
Trust the process!
Why though? Mr. Singer, why are you making so many mistakes? You mean with life or with the gun?
Obviously, it goes without saying, watch the Paper One video before this one. Oh my goodness, what is wrong with
How do you Paper 2 for Paper 1?
I am dead.
Alrighty then!
Babe, I didn't mean to hurt you. Here's some ancient Greek for you. And the giga is a billion. Giga Chad. You must. But I will find you. And I will eat you.
That's a big word. My nan does not know what that means, Mr. Singer. Why are you trying to?
Debatably.
RAM, which stands for Random Access.
Be a guest. Be a guest. You're going to be absolutely fine. Good donkey. Fortnite.
So, the first is what comes out of you after you eat food.
I can't help you!
A new challenger enters the scene.
Do it.
Isn't it, Shrek? He says yes.
1, 3, 4, 4, 6, 7.
My name is Al. Algorithm. In this section, we are going to do everything that it takes to think about what you are doing in your program. Algorithmic thinking, algorithms, thinking how these things work and how to make them work. But a stern warning first. Before you do this section of the course, you must do the Mr. Singer Python programming course. If you don't, you are going to be in for a world of misery. And I don't want you to be sad. No. Make sure you complete that first. It's only 6 hours and 55 minutes. Before we start with anything new, however, let's do something that you did a long time ago. On your whiteboards or on your piece of paper, just like on the Paper 1 video. And obviously it goes without saying, watch the Paper 1 video before this one. Oh my goodness, what is wrong with
How do you need paper 2 for paper 1?
Clock speed is the number of watt per watt. And clock speed is measured in watt. Cache stores it's faster than which stands for and discuss 2 network security risks and preventions that the developers of Shrek Forever After for the PS3 had to face. Give me 2 network security risks and 2 preventions. Give yourself 3 minutes, pause the video, go.
Alrighty then!
Clock speed is the number of FDE cycles per second. And clock speed is measured in hertz, usually gigahertz, and a giga is a billion. Giga Chad. Revision is boring, hard and lonely, but I've made it fun, addictive, and social. Welcome to Metagogy. Every topic that you need for your entire computer science course is here. Oh my goodness. Daily quizzes customized for you. Earn coins for every correct answer you get and boost multipliers that increase with your streak. Wow. Earn daily rewards for keeping your streaks. Metagogy will send you twice daily notifications straight through to your phone. Super convenient. Building you up on the topics that normally break you down. Mr. Singer's Metagogy has fully customized flashcards for the entire course, made by me. Beautiful, saves you lots of time. Oh, what a relief! Spend your coins on all sorts of goodies and show off to your friends in the student plaza.
Look at me!
See your friends who are online glow green in the student plaza. Maybe challenge them to a game in the play hard zone.
We work hard, we play hard.
Mass destruction, where correct answers destroy your opponent's pieces.
That's so violent.
Or Singer speed chess, where only the person who gets the answer correct first gets to move their piece. Many friendships have been lost.
Oh no, Travis, why did you do this to me?
If you have no friends or like being alone, you can play against my AI, or you can play Singer Blast. Singer Blast. Every 4 pieces you answer a question. If you get it right, you get to choose the next piece. But if you get it wrong, the speed of the game doubles.
Anxiety!
Bounty hunters.
Oh, scary!
Hunt down coin bounties for your toughest quizzes and earn bonus coins and crush the quizzes that have crushed You collect your own aquatic creatures in the Singer Snap micro game. Will you be the first in your class to collect all the ichthyoi, even the shiny and the arcane ones too?
Oh, so rare!
Show off your tank to your classmates and maybe you'll be chosen for Tank of the Day. Not to mention Knockout Mode, the programming gauntlet, and so much more that I don't have time to discuss in this short video. Not to mention, I'm adding new updates and features all the time. All this and more await you in Mr. Singer's Metagogy. Note, only Mr. Singer's students can access Mr. Singer's Metagogy. Click the link in the description or check out metagogy.co.uk to see how to become one of Mr. Singer's students. Limited slots are available
Because server costs are expensive!
Cache stores frequently used instructions, and it is faster than RAM, which stands for Random Access and it stores currently running programs, as you know. Any two network risks for this could have been data interception, which would have had a prevention method of encryption, brute force attacks, which could have had a prevention method of firewall or better passwords or more frequently changed passwords, DDoS attacks, which could have been like firewall prevention, firewall pretty much for a DDoS, or any other suitable network threat. Before we start our delicious new unit, you're going to get in these beautiful titles into your note. Give yourself 3.5 minutes, get them in just like last time. H1 is heading 1, H2 is heading 2. Make your document beautiful. It will be much easier to revise from if it is. Give yourself 3 minutes. Go. Pause the video and go. You don't want to watch me dancing. I have become an artist. This is a beautiful screenshot from one of the best movies of all time, and I am now going to create you an abstract of it on the left-hand side. There's Shrek. There's Donkey. There's the buildings in the background, and there's the trees. I have removed all unnecessary detail. Removed all unnecessary detail. I have removed all unnecessary detail. Mr. Singer, why have you done this? This was supposed to be paper 2, and this was supposed to be a difficult unit. Algorithms, that's a big word. My nan does not know what that means, Mr. Singer. Why are you trying to? I'll tell you why. Because the first topic on paper 2 is abstraction. Abstraction. And I just created a piece of abstract art. Abstract art. I removed the unnecessary detail. I focused on the important detail. It simplified the problem, reduced the complexity, and made it easier to understand. Debatably. What I want from you is that definition in your abstraction section. You need to know that off the back of your hand and then screenshot my beautiful example here. I've got 2 examples there for you. On the left, you've got the not abstract tree, which is like a full photograph of it, showing all the details. And then the abstract is like an abstract. Lots of detail removed, hiding unnecessary detail. Over here on the other side, we've got an abstract of the Very Hungry Caterpillar. Not sure if this is breaking copyright law or not. That's the entire book. The entire Very Hungry Caterpillar there, summarized down as an abstract, is caterpillar eats, grows, and becomes a big butterfly. Get in that definition and screenshot my examples below. You've give yourself 2.5 minutes. 3, 2, 1, go. Pause the video. Do it.
Classic!
A classic example of an abstraction question from the exam. Elliot plays football for OCR Football Club. He wants to create a program to store the results of each football match they play and the names of the goal scorers. Elliot wants individual players from the team to be able to submit this information. So again, look, we've got stored the results and the names of the goal scorers. That's all he wants. That's the necessary detail. Define what is meant by abstraction. So nice, easy definition. But this is where context comes into it. Give one example of how abstraction could be used when developing this program. So you've got to apply it to this football program that Elliot is making. 3 marks, screenshot that in, and just like in the last paper, screenshot it in and answer underneath. Wait for me. and we will mark it. This will get you so ready for the exam because you are doing literal exam questions. We'll go through it together in a minute. Answer it as best you can. Screenshot it in. Give yourself 3 minutes. Go. Do it. Okay, we were looking for removing or hiding unnecessary detail, focus on the important detail and simplify the problem. We got that. Any suitable example for the football thing would have been maybe get rid of the player names, maybe the ground that they played at. Obviously, we'd have to keep the names of the goal scorers, but the other players don't need. Maybe the size of the crowd at the venue. That's something we could have got rid of. We don't need to know the size of the crowd. And you'll see here on the mark scheme, it says suitable example of simplification made. Basically, as long as you said something that wasn't goal scorers or the results of the game, and you said get rid of it, you're golden.
Bish, bash, bosh. I am dead. What happens after I die? What happens to my body? It begins to decompose. In the same way that your body will break down after you perish, our problems can be decomposed into smaller pieces, and this is called decomposition. Follow me. So let's say you wanted to decompose Minecraft, biggest game in human history, over 200 million copies sold. Crazy! Let's say you wanted to decompose it, break it down into smaller sub-problems. This is what you would need to do. Minecraft. Can't spell. Here we go. What could you break Minecraft down into? Well, the first thing I would break it down into is maybe one section could be the graphics. Maybe another could be the physics. Maybe another could be audio, like sound effects and music, because it's got a banger of a soundtrack, doesn't it? And the last one could be maybe online functionality, online stuff. So that's like the big problem of Minecraft being broken down into 4 smaller subproblems. And you can even decompose beyond that. So for example, audio is a nice easy one. What could audio be broken down into? That's right, Dora the Explorer style. Sound effects, SFX, and music, of course. Physics, that could be broken down into player and mob physics, maybe. Graphics, you could do models, like the models themselves, and the textures. I'm sure you've all heard of Minecraft texture packs. The point is, no matter how crazy big the problem seems, it can always be broken down. This is decomposition. As I say, it splits the problem down into sub-problems. It makes it simpler to understand and to maintain. And we can tackle each sub-problem independently. Like with that Minecraft example from earlier, we could have different teams dealing with different things at the same time, letting us get our game out faster and create a better product overall because we've got that focus from each department. This is only possible with decomposition, isn't it, Shrek? He says yes. Get those in your notes, give yourself 2 minutes and 18 seconds, pause the video, go. Do it. Feel free to then screenshot my beautiful Minecraft example there. Yeah, really, really nice. That helps me to remember it all the time. Graphics, audio, sorry, the one on here I did there was inventory, not physics. Inventory, maybe the hunger system. Honestly, in the exam, it's always going to be quite free-flowing. Don't stress about it. As long as you can break a big problem down into sub-problems, you're going to be absolutely fine. Yeah, screenshot that in under decomposition as a nice little example that you can use. Think about it. Just think about it for a minute. Don't stress. Just think about it. Think about it algorithmically. This next one is algorithmic thinking, and I don't understand why this is on the spec because it's kind of like in English having a section called
reading or writing. It's just part of what the course is. This is what you do as a computer scientist. It's the idea of finding out the steps you need to solve a problem and the sequence that the steps are completed. Now, I take this for granted as a computer scientist, and you probably do too. But an example just a basic one that I could come up with was here. So we've got a little flow chart here. I'll teach you about these in about 8 slides time. But we input what a rogue is like, and we say if the answer is onion, we say true.
Good donkey.
But if the answer is not onion, i.e., if that's false, we'll do output bad donkey and end. It's just the idea of breaking a problem down into its smaller steps. Again, it's kind of similar to decomposition in a way. They kind of go hand in hand, but it's the steps needed to solve a problem. That's algorithmic thinking. Get that definition in, please. Don't forget your highlighting and screenshot my little example below. Give yourself 2 minutes. Do it. Cheeky exam question to cover what we've just done with abstraction and decomposition. You've got your fill in the blanks there. I want you to screenshot it in. You can use draw in Word, the draw tool. It's like on the top bar where it says draw, or you can just write in the answers underneath, whichever suits you best. 4 marks. I'll give you 3 minutes because it's a fill in the blanks. Go. Pause the video. Do it. Do it. Computational thinking is the process of analysing problems so they can be solved in a logical way. The process of, and this one is breaking down problems into small problems, so of course the answer is decomposition. Which one removes unnecessary detail? I think you will find it is abstraction. Of course. The next one is, of course, algorithmic thinking. Identifies the main steps needed to solve the problem and the sequence that the steps are completed. Give yourself a mark out of 4. Give yourself a mark out of 4. There's your mark scheme. Beautiful! We have just finished abstraction, decomposition, and algorithmic thinking very, very quickly. Oh my goodness. 14 minutes, what the heck? Yeah, that's really quick. Next, we are going to move on to 2.1.2, designing, creating, and refining algorithms. This is going to get deep. We're going to do all sorts like flowcharts, reference language, types of errors, trace tables, structure diagrams. There's a lot in here. Those are your titles. Get those in. Give yourself, I think it'll take at least 3 minutes to write them down. Pop them in with your appropriate headings, and I'll see you in 3 minutes. Pause the video. Get them in. Let's go. Shrek, are you feeling hungry? I sure hope so. Found you this box of Belvita. Come here, lad. Tuck in. Why won't it input? Input process output! Input, process, output. These are the 3 steps of any algorithm, any computational thing you'll ever see. The input is what is going in to the computer. In Python, we use the input keyword for this. For example, typing words into the computer on Google would be an input. You pressing the trigger button when you're playing Fortnite would be an input. A process is when the computer processes, and when it does something, right? This can be anything. This can be adding numbers together, applying a filter on Instagram, changing the volume in your music. Whenever anything is being done, it's a process. And an output is when something is coming out from the computer. In Python, to do an output, as you'll know if you've done the Python programming course, we use the word print, pops it on the screen. But an output, like for example in a video game like Minecraft, would be what you see on the screen. Maybe the sounds that you hear that come out of the speakers, maybe the text that comes up on the screen, maybe the graphics. Also, anything that comes out of the computer is an output. Input, process, and output. Get those in your notes. Give yourself 4 minutes. There's quite a bit of text there. Don't forget the examples and all your highlights. Make it beautiful, because beautiful notes are so much easier to revise from. Don't let me down. 4 minutes. Go. Do it. Allow me to test your skills, young Padawan. What would be the input, process, and output for the following scenarios. Person typing on a computer using Word, using a stoplight with a button outside of school, and recording yourself using a microphone and using voice modification software to make you sound higher than the rest. Give yourself 1 minute. I just want you to think about that. In fact, I'll stay here while you think.
That's enough thinking now.
So, of course, the input for Microsoft Word would be the person tippity-tappity tapping on the keys, inputting the words, commas, full stops, whatever it might be. The process would be Word adding it to the document, you know, putting that data in so it's actually in the document, and the output would be you seeing it on the screen. For the stoplight, obviously the button is the input. You press it because you want to go across the road. The process is it sends it up to the light, says, right, in about 30 seconds, you're going to go red, and it goes red. And the output would be, obviously, you seeing the lights and the little green man appearing on the box. Recording yourself using a microphone and using voice modification software to sound higher than you are. Of course, the input's going to be the microphone! The process is going to be modifying that digital sound to make you sound higher than the rest. And the output's going to be out of your speakers or your headphones, hearing that new sound. I'd like you to screenshot in this example, and I'll show you the answers in a sec. So screenshot this, please. Give you 8 seconds. I'll count down. Go on. Screenshot this. 1, 2, 3, 4. Quickly. 5, 6, 7, 8. And those are your answers, just so you've got a little reference in case you forget this in about 8 months' time. Screenshot that in. 7, 6, 5, 4, 3, 2, and 1.
Let's put you to the test. Put the service to the test. The lyrics wrong! Be a guest. Be a guest.
The Mr. Singer Paper 1 and Paper 2 revision guides. Lovely.
Oh, it's gorgeous.
Everything you need for a grade 9, equivalent to an A star at GCSE for Paper 1 and Paper 2.
It truly is a thing of beauty.
Filled to the brim with exam-specific notes, highlighted, colour-coordinated, gorgeous.
What an absolutely gorgeous piece of equipment.
Every section has accompanying exam questions and mark schemes, so you can test yourself.
It truly is a thing of beauty. Where can I get one of them?
If you're one of my students, ask me about the revision guides. If you are external and just watching this on YouTube, be sure to check the description. Check the description for your own revision guide for Paper 1 and Paper 2. Delicious.
A teacher researches the length of time students playing computer games each day.
Fortnite.
The teacher asks students how long they spend completing homework. Students answer in minutes and hours. For example, 2 hours and 15 minutes. The teacher would like to create an algorithm that will display student inputs in minutes only. So we don't want the hours, sir. We just want the minutes. Identify the input and output required for this algorithm. Screenshot that into your notes and give me your best shot. It should only take a couple of minutes. Give yourself 2 minutes. Pause the video. Go. Pause the video. Do it. Pause the video. Do it. So, the input for this one would have been the number of hours and minutes, of course, and the output would have just been the number of minutes, because that's what we
Asked for. I'm dead again. Now, decomposition can be a bit of a tricky process for people who aren't computer scientists to understand. That's where they invented the next thing we're going to look at. These are called structure diagrams, and we're going to make one together now, so pay attention. Let's say we're making a school system, so a school system. That could be computer system, to be specific. This would be level 1. So this is the top level of the diagram. This is like the most abstract, highest level part of the diagram we could possibly get, right?
Below that, we may have some other things on lower levels, like, for example, register. So like for registering students. We might have staff, like a staff section. And then we might have maybe parents' evenings, something like that. Parents' evenings. And that could be level 2. And below that, for a register, there might be different parts to it. So maybe there's attendance, but in the register, there's also detentions. I'm sorry for my handwriting, this board's very small. There might be detentions as part of that. For staff, there might be allocation, so what classes they've got, but there might also be the pay, the way that we pay staff. Do you see what I mean? So it's breaking it down so that different parts belong to different other parts, if that makes sense. And then on this one, for parents' evenings, maybe we'd have the access for students and the access for staff. And that would be level 3. The idea is basically the higher level we are, the more simple it is. But the lower level we get, the more detailed and deep we get. Let me show you an even easier example. Again, structure diagrams are simply a way of visually doing decomposition so that we can see it. So it's nice and easy to see. Now, down here, we've got a company wage program where the top level is the wage program itself. Below that, we've got like the employee details. We've got calculations for pay to calculate the gross and deductions. For example, I don't know, like national insurance, pension contribution, that sort of stuff. You don't have to worry about all this stuff yet.
You're not as old as me.
Maybe we have another section on the side there for producing pay slips, whatever it might be. Again, the idea is doing visual decomposition. Please write down that definition with appropriate highlighting, screenshot my example, and we're going to do a fat exam question on this next just to make sure that you understand it. Pause the video, 1 minute for that definition and the screenshot, please. Go.
Do it.
Okay. A school uses a mobile phone app to allow parents to book appointments for parents' evenings. We just talked about that! Parents must log in before they can use the system. They can choose to book a new appointment, view all appointments already made, or update their personal details. If a parent chooses to view their appointments, they can either view them on screen or print them off. A structured diagram has been used to design the mobile phone app. Write one letter from the following table in each space to complete the diagram. So I've started you off with a nice one where they give you a fill in the blank, just to kind of help you ease into it. So if we look down here, at level 1, we've got the mobile phone app. On level 2, we've got the login, managing appointments, and something else that you've got to fill in. Below that, we've got something inside manage appointments. And below that, inside view appointments, all the way down at level 4, we've got 2 other things. Take a look at the options. Take your time. Read it slowly. Okay, this is 4 marks. I know it's a fill in the blank, but it's a tough fill in the blank. Read it slowly. Give yourself 4 solid minutes. Okay, take your time. Screenshot it in. Answer it to the best of your ability. Pause the video. Go.
Do it.
So for this first one over here, I don't know if you can see my mouse, I hope you can. For this first one over here, we are of course looking for updating the personal details. See why? Because if we read up here, they can choose to book an appointment, view all appointments already made, or update their personal details. So we can see that right there. For the next one, under manage appointments, we can either view them, or as it says up here, we can book a new appointment. So A for this one down here on level 3. And then for the very bottom on either one, it doesn't matter which side because it's on the same level, you can either have view appointments on screen or, of course, print a paper copy of the appointment. So either viewing them on screen or printing a paper copy, of course. Give yourself a mark out of 4 and screenshot the mark scheme if you did not get full marks. Do it, do it, do it!
Here's some ancient Greek for you.
Psi, sigma, epsilon, upsilon, delta, omicron, sigma. And I believe the accent goes there. This word is
pseudos or pseudos, which is ancient Greek for false. The pseudo-Delphoi are the false brethren. False. Why am I telling you about ancient Greek? Because you're about to become very well acquainted with it. You may not need to know about the false brethren, but you definitely need to know about the false code. Pseudo code. Mr. Singer, what the flip? Why would we learn it if it's a lie? Well, because my gran struggles with Python. Yours might not, but mine does. Pseudocode is false code. It's code that it's kind of just a vibe, really. There's no strict rules. There's no strict syntax. Basically, it's just Python, but with loose syntax and a couple of extra keywords, to be honest. I find it easier to just do Python, but I have to teach it to you because in the exam you may see it and you need to get ready for it. Now, on the bottom here, we've got an example of some real code. So we've got num1 equals input, enter your number. The only difference in pseudocode is it'd be num1 equals enter your number, because we don't have to specify it's an integer for pseudocode, because my nan does not know what an integer is. For the multiplication on line 2, it's just the same, so that's nice and easy. And for the print, it's just the same. So you can see, for the most part, it's just the same. It's when we get into like selection and iteration and stuff that you're going to want to die getting that definition. If you can't write ancient Greek, so I haven't got an ancient Greek keyboard, I don't mind you screenshotting the pseudos. That's fine. I do want you to get in that definition with full highlighting, and I want you to screenshot my little example below, please. You've got 4 minutes. Go. So, what we have here is a comparison of Python syntax and pseudocode syntax. So we're going to go through this together, and this is why I said you've got to do the Python course before this, or you're going to want to die. So basically, equals is equals. This assigns a value, as you know from Python. For example, num1 equals 10, fills num1 with the value 10. Print is print, which is nice because, to be honest, they used to, I think back in the day, they used to say display, and it confused a few people, so they've gone for print, which is very, very nice. Input is input. Whee! This inputs a value into the program. For example, age equals input, enter age. This is basic Python. If you struggle with, I can't help you! Equals equals is the same as Python. Yeah, it's the same. It compares two values. This is the same. If is if. This is for selection. If my number is greater than 100, etc. This is the same. If is if. Plus is plus. Nice and easy. In strings, it'd concatenate them. So if you wanted to show two strings next to each other in the same print, you could use plus. And an array is an array. You just do it in the exact same way. So this is all the same. This is nice and easy. Screenshot this in, please. Do it. 8 seconds. 7, 6, 5, 4, 3, 2, 1.
But Mr. Singer, if it's all the same, why are you telling this to us?
Because it's not all the same. These are different. So while and while may look the same at the start of here, but allow me to show you. So sometimes they will use a while, just like you would use a while loop, like while my num is less than 10, print my num equals my num plus 1, etc. But they also occasionally use what's called a do until. So don't stress out about this. It's literally do until. Like do until. Like do until. Do until. Do until. So do something until something is true or false, whatever the condition is. So if you look at the example here, we got num3 equals, num equals 3. Do, print num, so we print that number, and num equals num plus 1. So until num equals 10. So that's like a do until the number gets to 10. I really hate it when they do that, to be honest, but I just thought I'd show you in case you see it. And the last one is for. Now, they will still use for loops, which is great, but they're going to be a bit weird. So obviously, when you learned for loops, you learned that there is a start, an end, and an increment, which is how to do for loops properly. OCR don't do it properly. They do it like, so they assume that the increment is going to be 1, if that makes sense. Take a look at this with me. So on the example here, we've got 4x equals 0 to 10. It doesn't say how much it's going up by. You'll notice it just says from 0 to, is that going up in 2s, 3s? You've got to assume, if it's pseudocode, that it's going up in 1s. Okay. Total equals 0, scores it's It's the same. The only difference is that it's going to not have an increment, and sometimes they will use the word next, like you can see down here, just near to the bottom. Can you see that there? Next scorecard. That's the way that they're incrementing in an array. So like go to the next value. I think it's really unintuitive, but that's how they do it. Please screenshot this bad boy in as well. Those are your differences. In fact, no, for this one, because it's different, I would like you to actually write this. Make me a table, 3 across by 4 down, and I want you to put in all this, because in the exam, if you get this and it's different, you're going to be in for a world of absolute misery. Get it in, give yourself 6 minutes. 3, 2, 1, go.
Time for an exam question!
Write the pseudocode to increment a value held in a variable by 1, and the variable is called score. So that's basically make the value go up by 1. If you've done the Python course, you'll be absolutely fine with this. Write an algorithm in pseudocode to store
Hello, this is me you're looking for.
in the variable word 1. Store everyone in the variable word 2, and concatenate word 1 and 2 to store hello everyone in the variable message. Okay, so remember concatenation, that's going to be your plus symbol for a string. It's just putting 2 strings together in a print statement or inside a variable. Go for it, 4 marks, 4 minutes, pause the video, do your best. Go. Do it.
It's going up, up, up.
It's going up by 1. Score equals score plus 1. Score plus or equals 1, or score plus plus. All of those do the same thing. My personal favourite is score equals score plus 1, because that makes the most sense to every human being ever. And down here, we've got some concatenation examples. If we look, storing both strings correctly in word 1 and word 2. Correct concatenation, word 1, then word 2. So for example here, word 1 plus word 2. Word 1 is hello, word 2 is everyone, message equals word 1 plus word 2. Beautiful.
It's time to go with the flow.
Flowcharts.
So if we want to show the process of how a program is flowing to a normie, doing that with code ain't going to be so great, but doing that with diagrams with pretty pictures is going to be best. This is where flowcharts come in very, very handy. Hello, we're over by the board. I'll fix the camera angle now so the light's not in the way. Sorry about that for earlier.
Let us begin.
So before we start making our flowchart, I'd like to introduce you to the main symbols that you're going to need. The first is what comes out of you after you eat food. Terminal. This bad boy is like a rectangle with 2 big ends like this, and it looks like a turd. It's called the terminal. The terminal at the airport is where you start and end your holiday. The terminal in a flowchart is the start and end of the program. This needs to be at the start and end of any flowchart that you make. Terminal. The next one is a parallelogram or a rhombus. This bad boy has 2 functions. This can either be the input or the output. And if you want to show it as an input, put the word input inside. If you want to show it as an output, put the word output inside or print. As long as you've used this shape, you're going to be golden. This is for showing stuff on screen or getting the user to type something in. This bad boy, this rectangle here, is a process. A process is literally anything that is done. So answer equals num1, add num2. Changing the value of anything. Honestly, like anytime a decision's not being made and an input and output isn't being done, it's probably a process. Whenever anything's being done, you're looking at a rectangle for a process. This one is one of my favorites. If you like it, then you should have put a ring on it. And what's on the ring? A big, fat diamond. This is the diamond of decision. Whenever we need to make a choice, in our program, this is what we're looking for. If this, then this. While this, do this. That kind of thing. Whenever we're making a choice, we're going to use this. Now let's do an example flowchart together. Now I've just Googled the words Draw.io. Draw.io is an amazing program for drawing flowcharts. It's really, really good. Let's click on this. Start now maybe. Let's give that a shot. There we go. Going to load up our flowchart creator. Wonder if I've got one from before. No? All good. Right. We can go down over here to the section that says flowchart. There we are. Beautiful. You can see there. Flowchart. And we can see all those symbols that we had before. Let's create a flowchart together. Now, what does our flowchart need to start with, children? It needs to start with turds. The terminal! In Draw.io, they call it the Terminator. Hello, I'll be back. I can't do a good Arnie impression. Pop that. There we go. And we're going to use the word start to start. Beautiful. Maybe a capital S to be a bit more professional. Start. Okay. So we've got our start there. That's our start. In fact, let's say this is a program that takes in two numbers, adds them together, and if the answer is bigger than 10, we output it. So we've got our start there. Now, what symbol do I need to take an input? We just did it. We need a rhombus or a parallelogram. Now, they've called it data on here. This is your input output. So we pop that here. Now, I'm going to take in an input. So I'm going to put input num1. Beautiful. Got that. Delicious. All is well. I don't know why I've made it so massive there. Let's zoom in a little bit so you can all see. So we've got input num1. I'm going to copy and paste that, and I'll do input for num2. Now, this is a flowchart, remember? So let's show them flowing. Tap the arrows here to connect them together. Boosh, boosh, delicious. There we go. So we've got our two inputs there. Now we need to add them together. Which symbol are we going to use to process that information? Which symbol are we going to use to process that information? It's going to be the process or the rectangle. Let's see if we can find it over here. There we are. There's our process. And I'll do answer equals num1. Sorry, I've used capital there and not been very consistent. Num1 add num2. Beautiful. So we've calculated answer. Now we'll join those up. And what symbol do we need to use to make a decision, to decide whether answer is bigger than 10? How do we do that? Well, we're going to use our friend the diamond for decision. The diamond for decision, they both begin with the letter D. We grab our diamond and then we say something nice and simple like, if answer is bigger than, we said, didn't we, than 10, we will output it. Now, to output it, all we have to do is grab again. These are inputs, aren't they? These ones up here. These are inputs, but the same symbol can be used for output. So if we pop down here and we grab ourselves another rhombus, we can pop that down here, and instead of the word input at the start, we can just say output. Beautiful. Output, there we go. And we can say output answer. So we can output the answer if it is bigger than 10. Now this is important. We need to say what's happening here. So this one in this case is true. So if you double click on the arrow, it lets you type on it, and you can type the word true right there. So we're saying if it's true. Now we need something to happen if it's false as well. So what we'll do is we will end our program with a terminator, terminal in this case. Pop it over here. So after it's answered, we will end it. And remember, every program starts with start and end. But what happens if it's not 10? Well, we want it to just end the program. So what we can do is we can, crumdiddles, pop that over there. We can make an arrow. If we pop back up to our basic shapes over here, we can make a little custom arrow that goes from here, and we can bend it there like this. Bend it and pop it down there. And there we go. We can see we must have, with all of our flowcharts, a start and an end, and there must be a flow all the way through. I couldn't end this without popping a false here, because otherwise we don't know what's going to happen when the answer is not 10. We have just made our first flowchart in Draw.io. Absolutely beautiful. Before you make your first flowchart, I would like you to get in the definition of a flowchart for me, please. Right there with your beautiful highlights. Get it in 4 minutes and go. Pause the video. Do it now. I would then like you to get in these shapes, please. I would like you to make this table. This is so important. Don't screenshot it. I want you to make it because I want you to memorize these symbols into your brain. And writing it, making the table will make it move into your from your short term to your long term memory. Trust me, I understand the science of this. Now, you're going to make a table 2 across by 5 down. For each of the symbols, you can obviously go into draw.io and screenshot each of those and pop them in. Or you can steal mine, I don't mind. We're going to use draw.io in a minute anyway, so you might as well get it loaded. Terminal, input and output, decision, and process. Terminal, input and output, decision, and process. Make that. Give yourself 7 minutes. 1, 2, 3, go. Do it. It's worth mentioning that OCR officially in their spec mentioned something called a subprogram, which is like a rectangle with 2 lines. Can you see it there? Just there. I've never seen it come up in an exam question before, but it might in the future because it is on the spec. So I think it's worth screenshotting that in. Please do that now for me. Screenshot that in. 7, 6, quickly. 5, 4, 3, 2, 1. Good. Now I'll be real with you. This TV show sucks. And it does. If you like it, that's okay. We all make mistakes. It's bad. But I think this demonstration, this visualization is really quite funny and really quite good. Maybe this is one of the earlier episodes. This is Big Bang Theory's flowchart section. Take a watch.
You're just in time. I believe I've isolated the algorithm for making friends.
Sheldon, there is no algorithm for making friends.
Hear him out. If he's really onto something, we could open a booth at Comic-Con, make a fortune.
Why does he copy my hairstyle but not the beard?
See, my initial approach to Kripke had the same deficiencies as those that plagued Stu the cockatoo when he was new at the zoo.
Stu the cockatoo?
Yes, he's new at the zoo.
The laugh track hurts me so bad.
It's a terrific book. I've distilled its essence into a simple flowchart that will guide me through the process.
Have you thought about putting him in a crate while you're out of the apartment?
Hello, Kripke. Yeah, Sheldon Cooper here. It occurred to me that you hadn't returned any of my calls because I hadn't offered any concrete suggestions for pursuing our friendship. Yeah, perhaps the two of us might share a meal together. Yeah, I see. Well, then perhaps you'd have time for a hot beverage. Pop.
So we can see here, we can see the decision being made, taking inputs and outputs.
Popular choices include tea, coffee, cocoa. I see. No, wait, don't hang up yet. But what about a recreational activity? I bet we share some common interests. You tell me an interest of yours.
Now we can see here, this is actually a really good demonstration piece, if I can zoom in here. So the decision, the diamond, is great for if statements, that is true, but it's also a while loop. You can see here, do I share the interest with him? And it says no, and it goes back to the input. So it's going to keep asking until that gives us a true. So we've made a loop here. We've done iteration, which is amazing when you think about it, that a diamond can do selection and iteration together. And he's going to get stuck in an infinite loop now. Watch.
Really? On actual horses? Tell me another interest of yours. Oh, no, I'm sorry. I have no desire to get in the water till I absolutely have to. Tell me another interest of yours.
Uh-oh, he's stuck in an infinite loop.
I can fix it.
It's interesting, but isn't ventriloquism by definition a solo activity? Yeah. Wait, tell me another interest of yours. Is there any chance you like monkeys? Yeah, what is wrong with you? Everybody likes monkeys. Hang on, Kripke. A loop counter and an escape to the least objectionable activity. Howard, that's brilliant. I'm surprised you saw that.
He's so mean to Howard. He's so mean. By the way, my graphics card sucks, which is why it might be lagging a little bit. OBS and YouTube cannot coexist. I have to play this at 240p. It's so bad.
Gee, why can't Sheldon make friends?
Kripke, that last interest strikes me as the least objectionable, and I would like to propose that we do that together. Tomorrow. Yes, I'll pay. All right, goodbye. All right. Time to learn rock climbing.
Superb. So, here's my challenges for you. On the left, we've got some Python code. On the right, I have started a flowchart, but I have covered up 2 of the symbols in red. What you are going to do is go over to draw.io, go into the flowchart section, and you are going to make these flowcharts. Treat them as like mini exam questions. It will really, really help you to practice. I want you to go on draw.io, make the flowchart, fill in with what you think is missing for this Python code. You're translating from the Python to the flowchart. We're inputting those numbers. We're getting an answer. We're printing the answer. What is missing? I want you to make it, screenshot it in, treat this like an exam question, please. So screenshot this. This is like your question. Do the flowchart on draw.io and then screenshot it back into there, and then we'll mark it in. I think that'll take you at least 8 minutes with it being your first flowchart. Give yourself 8 minutes, pause the video, do your best, and go. Of course, we were looking for inputting number 2 for the first blanked out space because we've only inputted number 1, and outputting the answer with that little print statement down there. Beautiful, beautiful, beautiful. Give yourself a mark out of 2, please, for the 2 that were missing. This next one's a little bit deeper and a little bit more complicated, but it will stretch your flowchart muscles. So we can see the Python code here. We're inputting 2 numbers again. It says answer is num1 add num2. It's outputting the answer. If the answer is greater than or equal to 0, we're going to output your number as positive. Okay, so we've got a positive and a negative situation here, so pay attention to that. And we're missing the true statement from the decision, and we're missing the final. So there's 4 spaces here. Same again, screenshot it in, go into draw.io, answer it to the best of your ability. Give yourself at least 8 minutes on this. Do your best. Pause the video. Do it. Do it. Do it. Do the raw. Do the raw. Trust the process! The process is what was missing, of course. Trust the process. For that first one, we were of course looking for answer is num1 add num2. That's what was missing because we didn't have that before. Oh, sorry, that's the second one, my bad. For the first one, we're obviously inputting number 1. And for the outputting, if it's positive, your number is positive on the true. And then we need a terminal at the end with a big fat end. Delicious! Give yourself a mark out of 4, please.
It's editing Singer here. I'm not feeling very well. This video is sponsored by nobody! It's just me here. I do all the editing, I do all the scripting, all the filming, obviously, and it's a big job. It's a massive. The amount of 9 PM finishes I've had on this project have been ridiculous. Ridiculous, right? Don't ask about the treadmill. We're not sponsored, so please, for the algorithm, like, leave a comment, subscribe, turn on notifications. I upload like once a year? It's not going to flood your notifications.
Okay, time for something a bit more juicy. This is a real flowchart exam question from a real exam paper. By the way, the equation on there says x equals x minus 2, but the resolution's really small, so some people struggle with that. So this one here says x equals x minus 2, okay? Start, input x, output, okay? X equals x minus 2. If x is less than 0, so if it's a minus, we go back, and we minus it again. But if it's not, then we end. Complete the table by identifying how many times OK will be outputted for when each value is inputted. So if we put 3 in here, how many times are we going to have the word OK? And if we put 10 in here, how many times are we going to get the word OK? 2 marks, 2 minutes, screenshot it in, do your best. Go. The answer was, of course, 2 and 6, because going in for 3, we get 1. minus it, we're back to 1. Do it again, minus it, we're less than 0, so we end it. And then, of course, 6 for 10, because we're going down in 2. So 10, boop, 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 and then we are done. So 2 and 6, 2 and 6. This is going to be our last exam question on flowcharts, and it's a big one, and you're going to need draw.io for it. And this is the last thing we're doing on flowcharts, so give me your all, okay? And then you will have it solidified forever. A fast food restaurant offers half-price meals if the customer is a student or has a discount card. The offer is not valid on Saturdays, so this doesn't work on Saturdays. The restaurant needs an algorithm designing to help employees work out if a customer can have a half-price meal or not. It should input the data that we need. So, maybe in this case that's going to be the date, because we're looking at if it's a Saturday or not. Inputting the required data, maybe if they're a student or they've got a discount card. Decide if the customer is entitled to a discount and output the result of the calculation. So you've got to draw that algorithm using a flowchart. It's a 5-mark question. I want you to do this in draw.io. Do your best and we will mark it. Give yourself at least 8 minutes for that. That's a really tough one. Pause the video. Last one on flowcharts. Let's finish strong. Go. Do it. So we're going to go through the mark scheme together. Now note, your flowchart doesn't have to look just like this. This is an example that the exam board have given. What you need to look for are these 5 bullet points up here. We're looking for a start and end, so a terminal at the start and end. If you got a terminal at the start and the end, give yourself a mark. Next one, we're looking for inputting 3 variables using a parallelogram shape. We're looking for the student, whether a student or not, the discount card, whether they have a discount card, and the input for the day of the week or the date. Check all 3 criteria, so 2 marks so far. Check all 3 criteria using diamonds. If it's not Saturday, for example, or you could have said if it is Saturday, we halve it, whichever way you prefer. So we're looking for all of those diamonds. We're looking for if it is a Saturday, if they have a discount card, or if they are a student. This one, they've done if student or discount card in a single diamond. That's fine. If you wanted to do it in 3 separate diamonds, that's absolutely fine too. Finally, we're looking for outputs full price with the correct conditions using the parallel shape. So full price. You didn't have to give an actual price because they never gave you one. And down here, half price if any of the other conditions were met. 5 marks. Screenshot the mark scheme and give yourself a mark out of 5. Pretty please. Do it. Pause the video, do it. Why? Why though? So pseudocode is false code, right? We get that. It's just kind of a bit of a vibe. OCR decided to make their own proprietary pseudocode called OCR reference language. Now, I'm going to show you this. Done. You say, Mr. Singer, why aren't you teaching us that? Well, the truth is you don't need to know it. You don't need to write it. You don't have to do it. You can choose to do pseudocode. You can choose to do Python or reference language. And in my mind, learning a language that doesn't work versus learning a language that does, it's a pretty obvious choice, isn't it? What I am going to do, though, is show you all of these very, very quick. We're not going to write any of them because it'd be pointless. But we are going to screenshot them for the reference language. And that's because you may see reference language in an exam. And I just don't want you to get scared by it or anything like that. In 6 years of teaching this, I've never, ever seen a kid get stumped by reference language on a paper. As long as you know Python, it's easy to understand. But if you want to do a quick barrage of screenshots here, I'll just do 6 seconds on each. You can pause and screenshot if you like. 3, 2, 1. 1, 2, 3, 4, 5, 6, 7. Grab that one. And then 1, 2, 3, 4, 5, 6, 7. Again, all of this looks just like Python, maybe with the exception of const and global for scope and for making a constant. We'll do that in a bit of a later unit so you'll understand what constants are. Next one. A for loop looks like this, for next, and they've done like to and step and stuff, so they've got weird ways of doing it, but honestly you can intuit. Step is just the increment in this case, and it's kind of very similar to pseudocode in that way. Your while loop, you got while and end while. Again, do until, we saw that in pseudocode, so you've seen this before. Screenshot it in just so that you've got it as a reference. If then else, It's just else if, end if. The only difference there is the end if, to be quite honest, and we don't have end ifs in real programming languages unless you're doing Visual Basic, but we don't do that anymore. Case, select, and switch. We'll do these. Well, you should have done these in the programming video, actually, but here you go. Switch, case, and then they've got default, which is the equivalent of an else, really. And yeah, that's that. And then here you've got stuff for substrings. So upper, lowercase, getting the ASCII from something, ASC. That might be something that you haven't seen before. CHR, returning the character, so giving the ASCII value and giving the character. It's probably worth taking a look at that. For file handling, this has come up a few times, but again, it's very, very similar to Python. We've got opening, closing, reading a line, writing a line, end of file, new file. If you did the programming video, you will have seen all this already, so all is well, and it's pretty much the same. Arrays is the same. Look at it. It's the same. Procedures, they actually use the word procedure, which is interesting. In Python, you just return something for a function. You don't for a procedure. Defining it, calling it, it's all very, very similar. You can say function and procedure just definitively there. So that's the same. Random numbers is just random, and you pass in. So, for example, if you wanted a random number between 1 and 6, i.e. to mimic a dice, you could pop in 1 and 6 there, and all would be well with the world. Why though? Why though? Why?
Babe, I didn't mean to hurt you. It was a mistake. I'm really sorry. It was an error. We all make mistakes sometimes, but it's how we deal with them that defines us. Insert cringy Facebook quote from your mum's profile right here. Errors come up in programming more than successes, I'll tell you that much. But how we deal with them matters, and how we categorize them matters even more. The three main types of errors are syntax, logic, and runtime. We're going to look at all of these together now. Now, I've written some code here. I would like you to tell me what the error is. Look at it for 10 seconds. Go. That's right. num3 is not defined. If we run it, let's go over here, run. I think it'll say that. num3 is not defined. That's right. What about now? I've fixed the num3 issue. It's going to print num2, but there's still an error. What's wrong? Look at it. 7 seconds. Good. There are 2 equals instead of 1, so that's not going to assign. That's going to check for a comparison. This isn't good. Okay, what about this code? What's the error? Boom! Missing a quotation mark after Bob. We've got the first one here, but we're missing it at the end there. Bob Bean Transporter isn't going to output because I forgot my quotation mark. Look at that. Naughty. This one is the hardest error by far. I'll give you 15 seconds, see if you can spot it. Did you get it? Second name has a capital N down here, which means it's not going to work. So it's going to say second name is undefined. Look at that. Second name is not defined. Mr. Singer, why are you making so many mistakes? You mean with life or with the code? It's because I want to introduce you to our first error type. Every single one of those that I just showed you is what's known as a syntax error. Syntax means grammar. 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 The grammar of the code was wrong. Anytime that you do a capital letter in the wrong place, you spell something wrong, you miss a quotation mark, you use the wrong symbol somewhere, this is a syntax error. It doesn't meet the rules of a programming language. It doesn't meet the rules of a programming language, the grammar of the language. Getting that definition, screenshot this example, and I'll give you some more in just a sec. 4 minutes, go. Pause the video, do it. Pause the video, do it. Pause the video, do it.
Here is a beautiful list of syntax errors, and I would like you to open up your Python IDE and recreate them. I want you to make me these in your IDE. So go into like online Python IDE or whatever sort of whatever IDE you use. It might be Trinket, it might be whatever. Pop over, and I want you to recreate these errors and screenshot them in to your notes. So I want to see an incorrect assignment, so with the equals on the wrong side. I want to see missing punctuation, like missing a speech mark. I want to see not enough arguments for a function, like putting 2, 4, and 10 into something that has only 2. Missing an identifier or variable after it's already been declared. So like down here, like number 1. And a type mismatch. So for example, you typing in a... actually, don't do that last one. That's an error on my part. That is a runtime error. I'm very, very sorry. I'll change that. Just do the first 4, please. Do me those. Give yourself about 12 minutes. 3, 2, 1. Make me some errors. Syntax errors. Go. I've fixed the PowerPoint now, so it doesn't have that bad one in. Yeah, sorry about that, Kiddie Winkles. Okay, here's another one for you. Tell me what the error is here, and it is not a syntax error. See if you can spot it. Give you 15 seconds. Did you get it? Well, if we run this together, you'll be able to see the error straight away because it's not going to be big and red. It's going to output 3. But ladies and gentlemen, boys and girls, is 5 add 2, 3? No, the error was in the logic. I've accidentally minused instead of plussed. This is a classic logic error. Logic error. When the code runs but doesn't do what it's supposed to do. Let me show you. When the code translates and runs, but the program produces an unexpected result. It runs, but it produces an unexpected result. And again, I've done the little example down here for you. I've had 2 numbers minusing instead. Please get in the definition, get in an example. You can even make your own in your Python IDE. That would be great. Actually get it and run it and screenshot it in, please. Go for it. 3, 2, 1. Give yourself 6 minutes. Pause the video. Go. Now, this example isn't going to be shown in the code because it is a runtime error. That means it's only going to happen when the code runs. So what I'm going to do is I'm going to press run, and I'm going to put in maybe an expected value for the first one. So I'll put in the number 5. But for the second one, what if I entered the word banana? I can never spell banana, you got to forgive me. Banana, and I'm going to press enter. It's dead. Why? Because at runtime, we entered a string where it expected an integer or a float. We killed it at runtime, so this is a runtime error. This is another common runtime error that might get brought up in the exam. Have a look at that. Mathematicians, I'm sure you can figure out what's wrong with it. 8 seconds. Okay. If you're not a mathematician like me, because I suck at maths, you might not figure out what it is, but I can. If I press run on this... Oh, no! We can see that we are trying to divide by 0, and you cannot divide by 0. A runtime error is an error that takes place during the running of the program at runtime, hence the name runtime error, you silly goose. Get that definition in, and you're highlighting. 40 seconds, go. These are all the examples that the exam board expect you to know for runtime errors. Now, I want you to write these down, but I don't want you to do any of them other than the 0 one at the start in Python, because doing them is not going to be easy. I mean, you could try and make a variable really, really big to do an overflow. That could be quite funny. And you could do a Stack Overflow, I guess, if you did a while loop that never ends. That could be fun, but it's going to break your IDE. I'm not going to make you do that. You can if you want. And a library error may occur if you, for example, try and use a random number. We learned about random numbers in the programming course, but you haven't imported random. So that could be a runtime error that happens there. Write those down and get me an example for the divide by 0, 1, and any others that you can. But I'm just happy with the divide by 0, 1 for now. 8 minutes, go. Do it. This bad boy is a beautiful cheat sheet for the kinds of errors. I would like you to make me a table, 3 across by 2 down. This is all 3 of the errors, and if you know them, you're going to do so well in the exam. My kids literally just came out of paper 2 exam. All this was on it, and they were so buzzing that they'd got this in. So get it in 3 across by 2 down, and make your cheat sheet, please. 6 minutes. Go. Pause the video. Do it.
Oh, where is he? Where's he got? I can't see him anywhere.
The killer appears to have disappeared without a trace. Trace tables. So what we have here is a piece of Python code that talks about Jeremy Clarkson, a swiper from Dora the Explorer, and Bob and Jill. Now, don't worry too much about the code for now. What we're going to look at down here is the trace table for that code. You can see we have a line number, we have the names of each variable, and maybe the output as well. And all we're doing is saying what each one is going to be on each line. Now, I'll give you the first line for free, and then we'll go through together and see if you can figure it out. So, line number 1, A is going to have the value Bob. So it's Bob, right? B is going to have the value null. Null. Because it does not yet exist. Null in computer science, by the way, just means it does not exist. Because a 0 is something. A 0 represents a 0, like a numeric value, an integer or a float. Null means nothing. The output, also nothing's been output on this line, so that's going to be null as well. If we go down a little bit, what do you think line 2 will be for A? What do you think A will be on line 2? And what do you think B will be? And what do you think the output will be? If you said Bob still, because Bob hasn't changed, you'd be right. Jill, Big Jill for line 2, of course, and nothing's been output. For line C, are A and B going to have changed? No. They're still going to be Bob and Jill, Big Jill. But will the output have changed? Oh, yes. Bob and Jill went up the hill and then got mugged, of course. On line 4, the only thing that's going to change is the output. Swiper, no wiping. And then what's A going to be on line 5? Jeremy Clarkson, the rest is the same, and obviously we haven't outputted anything, so that's null. And then on line 6, Richard Hammock for B. That's the basics of what a trace table is. Let me pop that up for you. What I want from you is the definition of a trace table and my beautiful little example. Do it, pause the video, about 3 minutes, go. Do it. This is going to be, and I know it sounds difficult to believe, but this is the easy example of a trace table exam question. Trace table exam questions are brutal. Okay, you've got to know this. So take your time with me. Don't stress. The code here is quite simple. We've got surname is input. We enter the surname. Oh, by the way, context. Each member of staff that works in a restaurant is given a staff ID. This is calculated using the following algorithm. Year is input and surname is input. The ID is the surname plus a string version of the year. So it obviously converts it to a string because it's going on to a string. While casts it. While staff ID dot length is less than 10, so while it's not bigger than 10, we're going to keep going. Staff ID equals staff ID plus X, so we're adding an X to the end of it. There's your concatenation. We end the while again if we get to 10. And then the output at the very end, because obviously not during this while, there's no print during this while, is going to be the ID plus staff ID with a little space there. You can use the draw tool on Word, you can use Paint, you can use whatever you want, or you can, I would seriously do it. You can recreate the table if you're an absolute psychopath! But for most of you, just screenshotting it in and drawing on it would be great. 4 marks. Give yourself at least 5 minutes for that. Take your time. Do it. So on line 3, it's obviously going to combine coffee and 2021, and it's going to be coffee 2021. Now, when we go into the while loop that you saw before, it's going to add an X. So we can see on the first line, we get an X on line 5 there, which is very, very nice. We're looking for line 5. And then it's going to go around again on line 5 because it's a while loop, and it's coffee 2021 XX. And finally, the length of that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 now. So we've hit 10, so we're going to come out of it, and we are going to output ID space coffee X, coffee 2021 XX. Screenshot the mark scheme and give yourself a mark at 4. Do it. This bad boy here is a harder example of a trace table. A teacher researches the length of time students spend playing computer games every fortnight. The following program uses a condition-controlled loop. X is 15, Y is 0. While X is greater than 0, Y gets incremented by 1, and X goes down by the value of Y. Not by 1, but by the value of Y. Okay. So X starts at 15, Y is 0, while X is greater than 0, so while it's positive, Y goes up by 1, X goes down by whatever Y is, and we end the while as soon as X is no longer positive or it equals 0 or below. This is a tough one. Take your time. This is much more mathsy than the other one. Give yourself at least 5 minutes. It's 4 marks, by the way. So yeah, 5 minutes. Do your best. Go. Do it. So looking at the mark scheme, we can see we start on 15 and 0, and we're going down like this. So Y is going up, and we can see X is decreasing by how Y is increasing. We go boosh, 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 boosh. We hit 0, and then we output the number 5. You can see in this, and I think a few of you will have noticed this, the more astute amongst you, that they're a bit cheeky. Sometimes they expect you to do line numbers, and sometimes when there's lots of loops involved, they don't, because it's kind of pointless when there's loops involved. So feel free to vibe it. The focus is going to be the output and the value of the variables. That's where your marks are pretty much going to come from for the most part.
Blinking at Daryl, I've been looking everywhere for my baseball bat and I can't find it in this mess. Look at it, it needs a good sort because I am sick of searching
For my bat, we're going to do searching and sorting algorithms. Those are your titles, go, yes. Get them in. Titles for searching algorithms, sorting algorithms, and the subsections for each. This is big, this is difficult, and we're going to get out the props for this one. Just to give you a little bit of a preview, one of the props is this bad boy, and you'll see why very, very shortly. I'm going to bury the lead on that. 3, 2, 1, get it in. Give yourself about 5 minutes. Go.
he.
I don't know who you are, but I will find you, and I will eat you.
We're on the floor now.
So here we have an array of data. We have 5 singers. You can see we have inflatable singer, we have chair singer, we have screaming singer, toothy singer, and over on the end we've got cardboard singer. Now the first search I'm going to teach you about is called a linear search. And a linear search is really, really great for a couple of reasons. One, we don't have to have the data sorted for it to work. It can be unsorted. In this example here, you can see that we've got I, then C, let's say this alphabetical order. We've got I, then C, then S, then T, then C. There's no order here, alphabetically speaking. It doesn't need to be ordered. That's the benefit. However, the big disadvantage is how long this takes. Let me show you, because linear searches are slow. I'm going to demonstrate this with the use of my hand. I'm sure you can see it right here. A linear search literally goes through every element in the list or the array, and it just says, are you X? So for example, if we were looking for
toothy singer, big one over there, what it would do is it would go, start at index 0, because arrays start at 0, and we'd say, is index 0 equal to toothy singer? And in this case, the answer would be no. We would increment the value by 1. So we'll go from index 0 to index 1. We'd say, are you, chair singer, are you equal to toothy singer? No, 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 no. It's not going to work. Screaming singer, are you equal to toothy singer? No, 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 no. Toothy singer, are you equal? Yes! Yes, he is. That is how we find it with a linear search. So the benefit is the data doesn't have to be sorted, but the disadvantage is that it's a bit slow. That took 4 operations. The next search I'm going to show you will do it in half the time. Hi, I'm over here. I'm giving the camera over there for the use when I'm showing you how to do these algorithms. So just pay attention to the screen. I hope the CRT TV doesn't give you a severe seizure. In fact, let me turn that off. So take a look at this with me. The definition is that we look in the list one item after the other until the item we have found, until we find the item that we're looking for, just like we did there with Toothy Singer. Items don't have to be sorted. That's your big advantage. And there's an example down here trying to find D. In fact, get in that definition at the top over there, write that down, and then we will screenshot this in. Please get in the definition, pause the video, get it in, go. And screenshot everything from the word example below, please. It's a nice little example of how to do a linear search. Get it in, go. 3 minutes. Look at that. Oh, just trees, cows, the landscape, outstanding. Makes you feel good. You know what'll make your grades feel good? If you're not one of my students already, becoming one of my students. My students get personal mentoring from me. They get access to the revision guides for paper 1 and paper 2 and the accompanying weekly homeworks that go with the Spotify. That'll do you for the entire 2-year course. Based on the Spotify, revision recall, oh, it's beautiful. Camera angle made me want to die. That really hurt my neck, so I've come back over here. Here is an example in Python of a linear search. You are going to go and code this in an IDE of your choosing. This is going to be your task. I've given you this as an example so that you can make your own. You can fill the list with whatever you want. You can do my favorite people, my favorite Pokemon, my favorite teacher. It can be anything that you want to do. We've got here a Boolean, little flag for if it's been found or not. We start at position 0. This is going to be like our counter that we use to go through the list. Search term, we're looking for D in this case, but you will substitute that with whatever you are looking for. I've done loads of comments so you can see everything and get inspired. While found is false, we're going to keep going. So basically, until it's found, we're going to keep going. If my list position, so the 0, equals search term, so in the first case it's 0, but position's going to go up in a bit, so don't stress about that. We're going to print, we found it at position, so we found it. So say D in this case, that would be index 0, 1, 2, 3, so that'd be it, found it at 3. And found is set to true. Why do we set found to true? Because then we escape the loop and we found it and all as well. If we haven't found it, we're going to go down to else down here and we're going to make position go up by... That's going to increment it for us and all will be well. Okay, I want you to open up your Python IDE of your choosing. Type in online Python IDE. Trinket, whatever you use, and I want you to make me a linear search for a list of items that you choose. Pokemon, cricket players, football players, your favourite Netflix series, your favourite friends. It could be whatever you like. Do your best. I'm going to give you 12 minutes. Go. Pause the video. Go. Do it. This will really help your revision. So for each of these, I would like you to get in a GIF that shows it working. Like you can literally see it working. If we're looking for 33 here, it's going to go no, 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 no. Yes, beautiful. I know linear searches are easy, but when this gets harder, the GIFs will really help. If you want to get this GIF, Google the words linear search GIF, find it and copy it in. If you're doing this in Word, it'll keep the animation and you'll be able to see it animating on your document. It'll look really cool and it'll help you to revise. GIFs are your best friend. Here is our first linear search exam question. Follow along with me. The following names of students are stored in an array with the identifier surname. So we can see there we've got surnames Rob, Anna, Hugh, Emma, Patrice, Iqbal. Describe the steps that a linear search would take to find Anna. So you've got to tell me how a linear search would find Anna. What would it do to find her? 4 marks, screenshot it in, answer it to the best of your ability. Go! Do it. Pause the video, 4 minutes, screenshot it in, answer it to the best of your ability. Go! So we're looking at Rob or student names 0, checking that does not equal Anna. We haven't found her. So we increment or we increase it to 1 and we access student names 1. We access Anna. That does equal Anna. We found her and we are done. 4 marks. 4 marks. Delicious.
We're going into battle, lads. It's time to divide and
Conquer. This bad boy is the binary search. This is the divide and conquer search, and it's so fast and so cool, but I'm going to show you why it's not always the best. Check this out. Now, our list from earlier, our array from earlier down here is not going to work with the binary search. It's not going to work with the binary search. Why? Because the data is not ordered. It's not in order. It's not sorted. We've got to get it alphabetical first. Through the power of OBS magic, it now is. Look at that. It's in order. All is well. We've got toothy at the end and we've got cardboard at the start. Now, a binary search is a divide and conquer algorithm. Let's say, in this case, we were looking to find Screaming Singer over there. What we do for a binary search is very simple. We divide and we conquer. We split it down the middle. So always half, half, half. That's what we're going to do. So we're going to go for the middle value. Boosh. Is inflatable singer equal to what I'm looking for? No, he's not. I'm looking for... Sorry, it was toothy singer actually, wasn't it, from the previous? Let's do toothy. So I'm looking for toothy. Not inflatable. So what we do is we get rid of everything on the side that the one we're looking for isn't on. So if it was on the left, it'd be the right. If it was on the right, it'd be the left. So basically, we know Toothy's over there, so we can just get rid of everything on this side, and obviously inflatable, because he doesn't equal it. Beautiful. Gone. We're going to halve it again. We go in the middle. What happens when it goes in the middle? We round up, just like normal maths, because we divide that, and we end up on 0.5, and we round up. So we're on there. Boom, we found it. 2 goes. 2 goes. Toothy, 2, Toothy goes. Instead of 4, it took 4 operations to find him with the linear search. That took 2. That is twice as fast. So why not use a binary search all the time would be your question. And the answer is, of course, that the data has to be sorted. That's the disadvantage. Divide and conquer. Binary search, split it down the middle, get rid of the half that you think you're not looking for isn't in, split it again. Is it there? Split it again. It's so fast, so fast. But the disadvantage is data has to be in order. Big definition for this one. Going to give you 6 minutes for this. Steal my pretty pictures as well. Don't forget your highlights. Do your best. Go. Order! We need to divide and conquer. I can't do a Gordon Ramsay accent. We need to divide and conquer. Oh, I can't do it. You are an idiot sandwich. That's what you are. The lamb is blinking raw. Raw. Sorry for distracting you. Crack on. Now, what this is an example of a binary search happening in real time. What you're going to do is screenshot along with me so that you've got a nice visual example of it in your notes. So we can see here with the upper and lower bounds are at the top and the bottom. And we're going to look at the middle item. So we divide it by it and we look at the midpoint as 5. So is F equal to G? Because we're looking for G in this case. It's not. So which side are we going to get rid of? Left or right? Left, that's correct. So we get rid of that half. Boom, that's deleted. Split down the middle, and I believe we're going to look at I next, if I'm not wrong. Yeah, midpoint is 8. So we go to the midpoint I. Is I equal to what we're looking for again? G? What we're looking for? G? Yep, so it's higher than G. So which side are we going to get rid of? the right-hand side. That's right. We divide it again, and there we go. We don't have an index 6.5, but it rounds up to 7 because it rounds up. So is h equal to g? Nope. So we get rid of it and everything to the right, which is just h. And we divide in the middle again, and we find g. Beautiful. Everybody, make sure you screenshot those. I'll just pop those back up one more time because I was a little bit quick there. Wait there. Pop these up for you. And screenshot that one. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Wait there, let me get all these up. And that one. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And that one. 7, 6, 5, 4, 3, 2, 1. Got it. And the last one, grab that one, please. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. This GIF is one of my favorite things in the whole world. This is a binary and a linear search GIF. They call it a sequential search on Google. You can see the Comic Sans there. I've put over linear search because that's what our example calls it. Sequential and linear search are essentially the same thing. But you can see the comparison here. Linear going through one by one, binary halving and halving. It's beautiful. Google binary search versus linear search GIF. And this one is trying to find the number 37. Copy that into your notes. It will really help your revision. Now, if I told you you had to know this code off by heart for the exam, every single letter, what would you say? You'd call me a liar because it's not true. You don't have to know this code. It's just to illustrate how it works. Fortunately, until A level, you don't have to know how a binary search actually works. This is just to give you an idea of how it works under the hood. If you want to, you can screenshot it, but look, you've got your upper, you've got your lower bound. It's going to go looking for it. It's going to find the midpoint, does that double slash, boosh. That I don't know if we've learned about it yet in this course. I think it comes up a bit like maybe you've done it in the Python course. We're doing the double slash division, and we're getting that midpoint again because we can't have that decimal value. Indexes aren't decimals. Midpoint is currently mid. If my list mid is the search term, we do found. Otherwise, that's our binary. So you don't have to know how this works, fortunately. You can screenshot it in if you're a coding buff and you want to get ready for A level, that's fine. But for now, I just wanted to show you what it looks like. Now, this is the sort of problem you're going to be dealing with. Willow has created a Hangman program that uses a file to store the words the program can select from. A sample of data is shown in figure 4. There it is. Amber, house, kick, moose, orange, range, tent, wind, zebra. Is that in order? Yes, it is. So we can do a binary search. Show the stages of a binary search to find the word zebra when applied to the data shown in figure 4. 4 steps, 4 marks, 4 minutes. Pause the video. Do your best for me. Don't let me down. So first, we compare zebra to orange. If we loop back there, that's the middle value. Then we greater, split and take the right side. Or again, you can have discard the other side, which is, honestly, they change their mind on every question, but split, take the right side, or split and get rid of the left side. Further comparison, 1 or 2 depending on the choices made. Correct identification of zebra using the methodology above. It compares zebra to orange, greater split right compared to wind, greater split right compared to zebra. And again, you don't have to say split right, you can say discard left if you want to. They accept the opposites. Multiple ways through, multiple marks awarded for appropriate comparison and creation of subgroups. Okay? So the curious among you will naturally ask, if a binary search can only be done on sorted data, do I have to do that manually? Do I have to go through thousands and thousands of records and manually sort them myself? That sounds pretty insane. No. We have 3, at GCSE anyway, we have 3 algorithms that we can use to sort data. And I'm going to teach you each of them, starting at the slowest, going up to the fastest.
A new challenger enters the scene.
Booger Cinder.
In this example, we're not going to sort by name. Let me say that again. In this example, we're not going to sort by name. We're going to sort instead by height, because I think that'll be a little bit easier to demonstrate. The first sort we're going to do is called the bubble sort. And the bubble sort does exactly what it says on the tin. It pairs up, it pairs. If you want to take away one key word from the bubble sort, it's pairs. It pairs up data, and if they need to be swapped, they get swapped. I've just moved this into an order that's more appropriate for this sort, so you can see this is not in height order at all, but this is how a bubble sort works. Pay the closest of attention. We compare a pair, so we start on index 0, and we say, does index 0 plus 1, so index 1, does this need to be swapped? Is this bigger than this? Do these need to be swapped? You tell me, do these need to be swapped? Of course they do. This one is bigger because we want the smallest on the left and the biggest over there. So we're going to swap inflatable singer with cardboard singer. Beautiful. Then we move on to index 1. Is screaming singer taller than cardboard singer? Yes, ever so slightly. So they don't need to swap. Moving on. Screaming singer and bug-eye singer. So index 2 and index 3. I'm pretty sure they need to swap because this one is bigger than this. So we swap that. What about screaming singer and toothy singer? Is toothy singer bigger? I think he is, so no need for a swap. What about chair singer? He definitely needs a swap because toothy is by far the biggest. So we swap it and we pop him right there. Beautiful. This is called a pass. A pass, 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 a pass. This is a pass, right? When we've gone through the list once, that's a pass. Is it sorted, though? No. No, it's not. We need to do another pass, so let's do it together. Inflatable and cardboard. Are they okay? I think so, but what about cardboard and bug-eye? Cardboard's defo bigger. Swap bug-eye over. Beautiful. Screaming is bigger than cardboard. No need for a swap. Chair and screaming. I think screaming's slightly bigger. So we'll do a little swap there. And then screaming and toothy. No need. We had to do a swap though. So we know it can't be sorted yet. So we go back again for another one. What's that one? Another pass. So we're on pass 3 now. What about inflatable and bug-eye? Do they need to swap? Yes, they do. Swap just like that. Beautiful. Inflatable and cardboard, no need. Cardboard and chair, no need. Cardboard and screamy, no need. Toothy, no need. So we did a swap then with bug-eye, so we know we don't know that it's sorted yet because we had to do a swap, so we go back again for pass 4, and then we're like, okay, no need for a swap. No need for a swap, no need for a swap, no need for a swap, no need for a swap. If we don't have to do a swap, that's how we know it's sorted. If we get through a whole pass with no swaps, we know that it's sorted. A whole pass with no swaps, we know that it's sorted. Before I get up off the floor as well, it's worth mentioning, when a swap happens, so let's say, we'll pop bug-eye back over here. Let's say we were doing a swap between cardboard and bug-eye here, right? The way that it works in code, and they might ask you about this, is with something called a a temporary variable. So, bug-eye will get put into a temporary variable over here, because otherwise you'll just get deleted when cardboard moves. Cardboard gets moved, and then from the temporary variable, he comes back and he gets put back in cardboard's place. That's what the temporary value, temporary variable is used for in this case. Is your definition for a bubble sort. A bubble sort repeatedly steps through a list of data, comparing each pair of data that it comes across, and it swaps them if their order is wrong. Winner. It uses a temporary variable whenever a swap is made to store one of the values temporarily. Every time it goes through the list is called a pass. Get that definition in. Go for it. Give yourself 3 minutes. Pause the video. Do it.
Get yourself a GIF of a bubble sort. If you Google bubble sort GIF, this is a good one. It's very, very slow, but it does show the process pretty darn well. And here, oh, sorry, I better show you that GIF, actually. I was on the wrong angle. Here we go. Here's a bubble sort GIF. This is the one that you need. Grab that for your notes, pretty please. Thank you very much. Just Google bubble sort GIF. There's loads to choose from, but this is a nice slow one. There might be better ones now when you're looking. Next one is a little example of a bubble sort. So we'll do this together and we'll screenshot it in after every slide. So I'll tell you to screenshot when the time is right. Don't do it yet or you'll miss crucial information. So here, 5 and 7, do they need to be swapped? Nope. What about 7 and 2? For certain, right? They get swapped. Boom. 7 and 2 are swapped. What about 7 and 3? Do they need to be swapped? Absolutely. So then we've got 7 and 7. Do they need to be swapped? No. What about 7 and 9? Nope. Boosh. That is one pass. One pass. Please screenshot that in. This is for our bubble sort example. For pass 2, do 5 and 2 need to be swapped? Of course. 5 and 2 get swapped. What about 5 and 3? Do they need to be swapped? Indeed. Swap 5 and 3. What about 5 and 7? Nope. What about 7 and 7? Absolutely not. And what about 7 and 9? Absolutely not. That is pass 2. Screenshot that, please. This is Hungarian dancing. Hopefully you can hear this, and hopefully it's not lagging too bad. I know YouTube and OBS hate each other so much. So this is a Hungarian dancing group, and you're going to see what they do very, very soon. I'm going to speed this up because it's a long video. Love you, OBS. So you can see here, they are dancing, and we're not just watching Hungarian dancing for the fun of it. No. Take a watch. Eight and 7 swap. Or 8 and 2 going to swap? Absolutely. Look at that. What about 8 and 5? They're going to swap? Absolutely. What about 8 and 4? Absolutely. 6 and 9? Sorry, 8 and 6 first. What about 8 and 9? Absolutely not. Hungarian dancing. Outstanding. This is a pseudocode example of a bubble sort for you. If you would like it, you don't need to know it, but it does demonstrate how that temp variable works. When you look down here and you can see with the nested for loop, very, very nice. Screenshot it for reference, but again, you don't have to code this in the exam. There may be a fill in the blank, but you'll never have to code it from scratch. Okay, cheeky exam question. Show the stages of a bubble sort when applied to the data that you can see there in figure 3. Go for it. Do your best. Show me how the bubble sort would work on this data. Give yourself 5 minutes. Screenshot it in. Do your best. Go. So we're looking for a swap on bait and crime, a swap on nymph and victory on pass 3, or pass 2, pass 2, sorry. A swap on loose and victory on pass 3. Actually, are these showing passes or are these just showing swaps? I think they've been a bit inconsistent here. I think these are just showing swaps. Yeah, these are just swaps. These aren't showing passes. So you could visualize it like that. You could also say it. You could just say bait swaps with crime, nymph swaps with victory, loose swaps with victory, loose swaps with it. And you can even specify the passes. I think this one's a bit of a weak mark scheme, to be honest. The next one we're going to do is insertion. Insertion sort. Sorting of insertion sorts. Now, this one works a little bit. This is like the middle one. So merge is really, really fast. Bubble's really, really slow. Insertion's kind of in the middle. Let me show you how it works. It's kind of similar to a bubble in a few ways. So the way an insertion sort works is rather than lots and lots of passes like a bubble sort would have to do, it's just one pass. It's just one pass, one massive pass. Let me show you what I mean. So we check this against this and we say, does this need to be swapped? No. Awesome. We're done. Okay, so that's in the right place. Oh, one sec, somebody's knocking at my door. Sorry about that. The joys of working in an active school. So basically, we've got our list here, and a bubble sort, you saw that it kind of bubbled to the top, right? An insertion sort, you can think of it inserting to the bottom. We're not going to go right, we're going to be going left instead. So invariably, with our first element, it's always... there's nothing to compare it against. There's nothing to the left. So we can mark this one as sorted. And to mark it as sorted, I will turn it over like this, just so that you can see I've marked that as sorted. We move on to the next one. And we look to the left. And we look, does it need to be moved to the left? Is there anything to the left that, would it fit better in the left? Is its correct place further to the left? And we can see that it just isn't. Okay, so Toothy can stay there. And we can mark him as sorted, right? Chair, though, we can see that the items to the left, especially Toothy, is bigger than him. So we're going to swap him and Toothy, pop it there, and these are basically the same size, so we'll stay, that's done. Popped him there, we'll mark him as sorted. Remember, we're going to the left. We're marking as sorted when we have put them to the left. Bug Eye needs a lot of swapping. So boosh, temporary variable, pop it down there. Boosh, swap. Boosh, swap. Make sure I keep Bug Eye in frame. And there we go. Mark him as sorted. Boosh. Again, this is a single pass. Screaming Singer, we can see he needs to be swapped. There we go. Boosh. And we'll say that's the same. So I shouldn't have done so many of a similar size. What about Inflatable? We can look to the left and we can see that he needs to be swapped. Swap. Oh my goodness, I'm wrecking this. Pop these back in place. And there we go. We can see that, mark him as sorted. Boosh. We're in a correct order of height from lowest to biggest. We can see that. That's how an insertion sort works. While not the best sort, while not the fastest, it is definitely faster than a bubble sort, an insertion sort. It's more efficient than a bubble sort, and the steps that it has to take are below. Getting that definition, write down the steps. Don't forget your highlighting and make it beautiful. Give yourself 6 minutes. Pause the video. Go. By the way, if you Google Lavivian post insertion sort GIF, you'll get this one, and it's my absolute favourite. In fact, for all of the GIFs for the sorts, Lavivian's the best. Google Lavivian, whatever the name of your sort is, GIF. I don't know who she is, but she makes some sick GIFs. Yeah, get that in. This is the pseudocode for a insertion sort, and you have to know that off by... No, you don't! You don't have to know that off by heart. Thank the Lord for that, because, in fact, the exam board got in trouble for that once because they put some in an exam despite it saying on the spec that you do not have to know it, so they don't do that anymore, which is great. Just like before with the bubble sort example, I'll go through it, I'll explain it, and you can screenshot at the end of each screen. But follow along with me first. Don't start screenshotting until I tell you to. So, 572379, so we can see it's not sorted. We're going to start sorting it. 5 doesn't need to do anything, but 7 also doesn't need to do anything. Mark that as sorted. 2, though, that's going to move 2 spaces all the way back to there. 3, that's going to move all the way back to 5. You can see it there. There's your insertion. There's only one pass, so there's only one screen for this. There's your insertion example. Screenshot it in. Go! This is a nice exam question for an insertion sort. It's visual. You can see it. I want you to screenshot that in, use the draw tool in Word or Paint or whatever you're using, and answer it to the best of your ability. You've just got to do an insertion sort on this data. Alphabetical, of course. By the way, if it doesn't say what sort of order, it's either going to be numerical or alphabetical, numbers or letters, of course. 6 minutes, go.
Go. Do it.
So the visual mark scheme is at the bottom here. We can see Rob popping, Anna popping there before Rob, Hugh popping before Rob, Emma popping before Hugh, Patrice popping before Rob, and Iqbal popping before Patrice. We can see the insertion sort as it goes. You could have described it, but when you've got a visual option, that's usually the better one. Give yourself a mark at 5. 5. Last set of headings for 2.1. This is for a merge sort. 2 minutes getting those headings. Go! Do it.
Divide and conquer. Divide and conquer. Divide and conquer. Divide and conquer.
This is a merge sort. Now, this is going to be the only example where I don't actually use these silly singer cards. And the reason for that is because, honestly, I think it makes it much easier when you look at it with just numbers. So you can see here, if the lighting's bad, I do apologise. But you can see here, we've got 8, 4, 7, 6, 3, 4, 8, and 1. I think you can see that. So that should be 8 numbers in total. Now, I said it was divide and conquer. So this is what we do. First, we halve it, just like binary search halves. We're going to halve it. So we're going to break this up into 2 lists of 4. Literally just split them up. We're not doing any ordering yet. We're just going to split them up. Then we're going to split them up again into individual lists of 2. As you can see, they're now in individual pairs. Then we're going to split them up again. We're going to divide and conquer again into individual elements. I've run out of space for this, unfortunately, and the wire for the camera is even covering it. But you can see they've been broken down into individual elements. So we divide them, and then we're going to put them back together, all nice and sorted. Watch this. So first things first, we're going to pair them up into 2s. So we halved them before. Now we're going to pair them up. Check this out. So 8 and 4 first, we're going to put back together as 4 and 8. Then 7 and 6 aren't going to be 7 and 6. They're going to be 6, 7! They're going to be 6, 7, of course. 3 and 4 are going to be 3 and 4. And 8 and 1 are going to be 1 and 8. So we've put them into 2s. Then, you guessed it, we're going to pop them into 4s. So we've got our 2s here. Now we're going to pop our pairs into 4s. So check this out. We've got 4, 8, and 6, 7 there. We're going to pop those into order. Watch this. 4, 6, 7, and 8. So they're a 4 now. Then those 2 pairs need putting into a 4. 1, 3, 4, and 8. Nice and easy. So now we've got 2 sets of 4s. Now we're going to pop these together into a big list of 8. Watch this. And we end up with 1, 3, 4, 4, 6, 7... 8, 8, a fully sorted list. This is the fastest sorting algorithm. And honestly, I find it really easy to understand. I don't know about you. So your definition for a merge sort is as follows. Sorting a set of data by splitting the data set up into its individual items and then pairing the items from the data set until the entire data set has been ordered. It is the most efficient sorting algorithm. It's not even close. It's so fast. It's so fast. Get in the definition and then we'll get in some examples. Give yourself 5 minutes. Pause the video. Go. Again, Levivian. Type in Levivian merge sort GIF and you'll get this beautiful merge sort GIF from her amazing website. Great GIFs. Grab a Levivian post GIF. Big up Levivian. I don't even know what the website's about, but I find some great merge sort and insertion sort and bubble sort GIFs on there. So good on you, Vivian. It is a beautiful example with an array of size 8. And we can use this. So you can see we got the 8, we get the 4, we get the 2, we get the 1. So we break it all down. Screenshot that. 7, 6, 5, 4, 3, 2, 1, and boosh. Then we pop them into temporary sorted arrays of 2, so we can see that. So we've gone and boosh, pair them up, bish, bash, boosh. Screenshot that. 7, 6, 5, 4, 3, 2, 1. Then we put those pairs into fours. So again, we're going from ones to twos to fours. We see that doubling every time. And we're going to put that in order, 1, 4, 7, 9, 2, 3, 5, 8 in this case. And then finally, we put them all together. Oh yeah, screenshot that, by the way, sorry. 1, 7, 6, 5, 4, 3, 2, 1. Screenshot that in and boosh. Then grab this final screenshot. That's why we put those two lists back together and we end up with a beautiful merged list. That's why it's called a merge sort. That's why it's called a merge sort. Screenshot that, of course. 7, 6, 6, 7. 5, 4, 3, 2, 1. And if you haven't already, steal the divide and conquer meme right there. Okay, merge sort exam question for you. A program stores the following list of positive and negative numbers. The numbers need sorting into ascending order using a merge sort. The first step is to divide the list into individual lists of one number each. This has been done for you. So bear in mind on this one, this isn't worth as many marks because they've already broke it down. So the first step where we break it down into individuals, you don't have to do that here. It's already broken down. We're just doing the putting back together in this case. I would like you to do it. 3 marks. Draw it, by the way. Screenshot it in. Use the draw tool. However you want to do it. 3 minutes. Do your best. Go.
So that's why they call it a merge sort.
So we're looking for it to be sorted into lists of size 2 to begin with. So 12 and 45, minus 99 and 100, minus 13 and 0, minus 27 and 17. Then into lists of size 4, minus 99, 12, 45, 100, and minus 27, minus 13, 0, and 17. Then minus 99, minus 27, minus 13, 0, 12, 17, 45, and 100. Is one last cheeky exam question on merge sorts. So a library gives each book a code made from the first 3 letters of the book title in uppercase. It really doesn't matter. There's whatever. In this context, the context doesn't actually matter. All they're asking you to do is show the steps of a merge sort on this. So show how you do a merge sort. Now this is a full merge. This is a full list. So this hasn't been broken down for you. It's worth 4 marks. You got to show it getting broken down and then built back up again in the correct order. When you're doing this, I don't mind if you just use the first letter of each. Obviously in the exam, I'd do the whole thing, but because we're just practicing and I don't want you to have to write AND 18 like 5 times, I don't mind you just using the first letter. So show me how a merge sort would work and then give me an advantage of a merge sort compared to a bubble sort. Do your best. Don't let me down. Go for it. So we were looking for merging splitting it down into individual elements, merging those elements into lists of size 2, then size 4, and then into the final sorted list. And the benefit is it's faster and it's better for larger lists that are more unordered, and it is consistent. It doesn't depend on how ordered the original list is, unlike a bubble sort. So it's very, very fast and it's very, very consistent. So this last thing I want to show you is a little cheat sheet for the sorting algorithms. Take a look at this. So this is all 3 algorithms compared. I want you to make me a table 1, 2, 3, 4 across by 1, 2, 3, 4 down, and I want you to get in those definitions, color code it, because you can see that merge is the fastest, insertions medium, bubbles the slowest, and then the GIFs you got from the Vivian post, I want you to paste them in the bottom. That'll give you a beautiful cheat sheet for the 3 sorting algorithms, and that'll help you so much in the exam. Give yourself 8 minutes for that. Do your best and go. So, you're about to revise for your test. Now, you could spend an hour or 2 making your flashcards, and that's absolutely fine. Or you could get on Metagogy, Mr. Singer's Metagogy. That's my learning platform. That's got all the flashcards you'd ever need made by me, so it's exactly what you need. It's got tests that you can do. It's got questions. It's got space retrieval. It's got games that are based on those questions. It's so deep. In fact, if I remember, I'll pop a little video explaining metagogy in this video so that you can see how incredible it is. I spent months on it, like absolute months. It's everything that I want in a lesson and in a class digitally. It's so honestly, every kid that uses it absolutely loves it. It makes revision fun and it works. Like, it actually works. So get on Metagogy. You can filter your quizzes and go on section 2.1. Do all of it. I'd get at least over 80% on each of those. Get your trees producing lots of fruit. You'll know what that means, Metagogy kids. Get on Metagogy. That will really, really help you. If you haven't got Metagogy, you should. But I'd expect a minimum of 32 flashcards for this, maybe more, just to get yourself ready for it. And time to do the end of unit exam. My students, get the exam off me. Come and speak to me again. Read this. If you want to become a Mr. Singer student, take a look in the description. I do offer virtual tutoring. If you're somewhere else in the country and you want to do some tutoring, take a look in the description. But for my students, crack on with your exam, and we'll mark it. And you can mark it with the attached mark scheme. All done. 2.1 is finished. You've been amazing. That's the first big section done, and that's probably the hardest section in the entire paper too. So well done. I will see you very soon for 2.2. And well done. I'll see you soon. Bye! The man went green and you went, oh, I'm safe. I can go across now. Why, Delilah? My name's not Delilah. Now I want to tell you a story about my daddy. Before we get into it, though. Oh, delicious. Metagogy! Outputs. Oh, it's not very difficult to understand, is it? Hello. Ow. Ooh, casting. Hello. We're going to bake a pie today. Are you ready to bake a pie with me? No. I feel like I've been manipulated. Infinite beans! Infinite beans! The beans are never ending! No! Time to consume some alcohol. Time to chop off its head! Do it. Daddy Singer. I forgot my quotes around welcome honey! I'm very small. I'm over here. Welcome to my surgery. Honestly, I have never seen a turnip so massive in all my life, and it started speaking to me. Dirty. Come here, let's have a chat. Every single app you've ever used, every game you've ever played, every plane you've ever flown on, every car you've ever driven in, every street walk that you've crossed where the man went green and you went, oh, I'm safe, I can go across now. Every computer-based system that you've ever used uses what I'm teaching you in this unit. This is the fundamentals of programming. Before we get into it though, cheeky little starter recap on some stuff from paper 1. I want that in your notes, just like we normally do, on a piece of paper, whatever you prefer. Answer it, and I'll mark it with you in about 50 seconds. Go for it. So the first question, you've got the 3 types of secondary storage, of course, optical, magnetic, solid state. FDE stands for fetch, decode, and execute. That's right. 6 properties are portability, durability, cost, reliability,
Speed!
And the last one's a tricky one. It's cost per gigabyte. You could have just had cost, but I like cost per gigabyte. A router sends... We have crisps in these. Oh, delicious. Crisp packets, just packets, and receives packets and connects a LAN to a WAN. URL gets sent to the DNS. The DNS looks up the IP address. If it can't find it, it goes to a higher level DNS. Yeah, that's it for that one. Just a quick reminder, you can see it down here just below me. Metagogy, Mr. Singer's Metagogos. Yeah, check out the description. If you're one of my students, you'll already have a Metagogy account. Get on Metagogy. It is the best way to revise objectively. I've taken every single thing that I've learned in all my years of teaching and I've translated it into a learning platform that's fun, engaging, social, and it really helps kids to remember. Everybody who uses it absolutely loves it. So check the description if you want to learn more about Mr. Singer's Metagogy and becoming one of my students.
Metagogy!
Before we start programming fundamentals, we better get in our tiles. There they are. Get them in and go. Give yourself 3 minutes.
Quick note before we start.
Obviously, you will have already done the Python beginner course, which is a great thing, and I'm so glad that you have. Well done. Well done. So the focus here will be on exam-specific notes and definitions. We'll do some examples together, of course, as we should. But yeah, this is more, there's lots and lots of specific exam definitions that you need to know that weren't really covered in the practical Python course. That's more about the doing. This is more about let's get as many marks as we can. Outputs. Something's going into program, it's input. If something's coming out, it's an output. It's not very difficult to understand, is it? An output is something that the program produces, something coming out. And to do this in Python, we use print. We use print in Python, obviously. That shows it on the screen. It doesn't send it to a piece of paper. You know this. There's your definition. What I want you to do for each of these is get me a Cody example of your own. And yeah, very, very simple. I'll do a little example now. As a reminder, by the way, you don't have to use Trinket. You can if you want to, but I always just Google online Python IDE. That's what I Google, and there's loads that are on there. So I just usually click this first one. It's this online Python. It's really, really good. So when we're doing an output in Python, to output a string, we always use quotes. Don't forget that from the previous video. Do a print and run it just like that. Boosh. I love big beans. One other thing I would like to show you is something called concatenation. Concatenation. Concatenation is where we combine a couple of strings together. So when you're doing an output like this, you can use a plus to combine two strings together. I love beans, could do a comma there. And then after it, we could say Heinz are overrated. I hope that's spelt correctly. Run it. Boosh. We can combine them with a plus. That's called concatenation as well. We'll do that a little bit more later. Get in the definition of an output and do me your own code example and screenshot it in. Go, go, go. It's worth saying as well, for all the code examples that you do, make sure you run it and screenshot the code and the output itself. So if we look back at what we were doing earlier, here we go. So if I was screenshotting this, I would want to screenshot the code over here on the left and the output over here, because then you know if the code doesn't work, you're just going to see loads of errors there, so you know you've done something wrong. Go, go, go. Input. If something's going into the system, it's an input. That's something coming from the user into the computer. It's data that user enters now. Take a look at my example here. Again, you've already done the basic Python course, so I'm not too afraid about scaring you. So let's take a look at this. We've got name and action here getting inputted, and notice right there, you've got casting. You got casting there. What data type are we saying that's going to be? We're saying it's going to be a string. We're expecting a string to be inputted. Always state the data type before you do an input, whether it's str, int, etc. What's your name? Action. What should happen? Etc. So we're doing a little story here, and then we're combining what we just did with the output. And we're saying story is name walked into the woods alone. Oh no. Story equals story. So we're building on the story from before. So it's whatever was there before plus. Then they were action, whatever happened up here. Story equals story plus. So we're building on whatever happened here. A giant hippo covered in Nutella. And then print story. I want you to get me in that definition and do me your own input example as well, please. Do your best. See you in a minute. Go.
Do it.
Hello. Ow. Think of a variable like a box. It's a container that stores information, but that's the baby definition. For GCSE, you need to know the big adult definition, and this is so important, do not miss it. It is a name or identifier for a memory location. Name or identifier for a memory location. It temporarily holds and stores data, and it can be changed while the program is running. Can be changed while the program is. We're going to meet its brother in a minute that cannot. But a variable, if you get confused about if it can change, just think about the name. Oh, does it vary? If it varies, then it can change, can't it? You silly goose. A name or identifier for a memory location used to hold or store data that can be changed while the program is running. Now down here, you can see I've got a couple of examples. I've got ammo count for a gun, and you'll notice that the amount of ammo doesn't have any quotes around it. That's because with variables that are numeric, like floats and ints, anything that isn't a string or a char really, you don't use quotes. You only use quotes for strings and chars. Speaking of strings and chars, the gun name down here, M4A42, has quotes because it is a string. Ammo count equals ammo count minus 25, whatever that might be. It's just a little bit of maths. And we're going to print the name of the gun and the ammo count. Also notice on that print down there, we don't use the quotes. You know this. When we're outputting a variable name, we say its name. Name or identifier for a memory location. Used to temporarily hold and store data. Can be changed while the program is running! Get these in your notes. Go. Very important definition. Don't forget your highlights too, your little crumpets. Crumpets. Down with the crumpets. Right, you lot, I want to talk to you about your assignment. Assignment means saying something is something. If I assign to you a number, I am making you that thing. I'm making you hold that thing, become that thing. If I assign to you a name, that is your name. Okay. In variable assignment, what we're talking about is what fills that cardboard box. Now, if you look at this very basic bit of code here, we've got num1 on the side, which is the name of my variable, and it equals 5. Are we saying is num1 5? I don't think we are. We're saying Num1 is being filled with. Num1 is becoming the number 5. If I print that, print num1, let's give that a shot. It's going to print out the number 5, right? Makes sense. But what if I got those the wrong way round? Five equals num1. Let's try that. See if it works. No! No, we got a big error, didn't we? We cannot see the keyword there coming up. We cannot assign. Maybe you meant, yeah, that's right. So make sure when you do assignment, you do it the right way round. It's the operation of placing data into a variable. And you use single equals for assignment. 2 equals will come later when we do selection, of course. But a single equals is for assignment. Get in an example for me and those notes and your highlights. Give yourself 4.5 minutes. Go. Just a little note on outputting those variables. When you're outputting a variable, like I mentioned earlier, you don't use quotes around it. If you do, it will just output the name of it. Like with our example from earlier, num1 is 5, print num1, it gives us 5. But if I put this bad boy in quotes, watch what happens. I'm just telling the program to output the word num1, and we end up with the word num1. That is very, very bad. Get in that, please, just under your variables for outputting variables. You've got the good and the bad there. Get it in. Let's go. Sorry. Right screen. Get it in and go.
I cannot change.
While the program is running. I ain't a variable. I am a constant.
Name or identifier for a memory location. Location.
So that, same as variable.
Used to temporarily hold and store data. Data.
Is the difference though. It can't be changed while the program is running. It can't be changed while the program is Get that in your notes. I want you to write it in full. You need to memorize these definitions. Do not copy and paste it from the variable. I know it's tempting. Don't do it. These are so important. You memorize these, that's like 6 marks if both of these come up in an exam. Easy 6. That's like nearly a whole grade boundary. Do it.
The 5 data types.
Ooh. The 5 data types you'll have learned about in the previous video, but just in case you don't know, there are 5 big data types. You got ints, floats, strings, bools, and chars. Integers are whole numbers, floats are decimal, strings are a collection of characters, Boolean is true or false, and a character is a single character. Okay, as I say, you'll have done the video, so you'll know this. But what I would like you to do is really solidify this knowledge. So 1, 2, 3, 4 across by 1, 2, 3, 4, 5, 6 down. By the way, floats are sometimes called reals, not like Instagram, but real like not imaginary, because it's the real number, it's not an approximation. Over here, we've got some example code with comments next to it, with that little hashtag. I'll teach you about comments a bit more later. They're very, very important, but I want you to comment that as well. Tell me, in fact, get into this habit. Whenever you're doing any code, always comment the data type next to it. It'll show the examiner that you know what you're talking about. Make me this table. I want you to get in all of that, all the definition, all the explanation, all the examples, but for the code, I want you to do your own examples. Don't screenshot mine. I want your own examples. Don't screenshot mine. I want your own examples. Go.
do it.
You know, you would be perfect for my job, my acting role as a crazy man in the new film I'm making. I'd like to cast you for the role. Casting. In the same way that an actor is one thing but pretending to be another, casting is where we essentially take a variable and we let it pretend to be a different type of variable. For example, turning a string into an integer, or turning a string into a float, or turning a string into a Boolean, and vice versa. We can make one data type convert into another, just like an actor, when they're cast for a role, becomes something that they aren't. It's converting one data type to another. For example, converting an integer to a string. That is full marks if you put that definition in your exam. An example would be str5 would turn the integer 5 into a string. You can see down here that whenever we do an input, we should always cast it in the data type that we expect. This is a really, really, really helpful thing to do. Getting that definition for casting, do your best, and I'll see you in a sec. Go. Don't forget your highlights, don't forget your highlights, don't forget your highlights. Highlights. Sergeant! Filming. Oh my goodness me. Oh my goodness me. Hello. Welcome to Casa del Singer, the kitchen of Singer, or I assume that's what it means. I'm not very good at any language other than English and Greek. Now, this is my oven. We're going to bake a pie today. Are you ready to bake a pie with me? So what we're going to do is first, I'm going to turn on the oven. Beep, boop, beep, boop. Then I'm going to eat the pie. Then I'm going to put my ingredients together and make the pie. Got a bit of salt. A little bit of Singer sauce. Put that in there. Singer sauce. Singer sauce. Put that in there. And some honey and nut Belvita. That's what we need. So I'll put that in. I've made my pie. And now I'm going to put the pie in the oven. Gonna be okay. What was wrong with that? It was out of order. I ate the pie before it was even made. It was out of sequence. I'm going to introduce you now to the 3 programming constructs: sequence, selection, iteration. We're going to start with sequencing now. Sequencing is quite literally when the code needs to be in order to work properly. Let me show you an example. I've written some code here and I'd like you to tell me what's wrong with it. Give yourself 10 seconds. The code is right! But the order is wrong. So we've got num1 is 5. Oh, in fact, let me run it and just show you what happens. Run. We get to answer, and it says it's num1 add num2. Has num2 been defined yet? No. It's not been defined yet, has it? Look at the error message that we get. Num2, if ever you get stuck, by the way, and your code doesn't work, just read the error message. 90% of the time, I'll tell you what's wrong. The name num2 is not defined because at this point on line 2, do we know what number 2 is? We don't. It's been defined down here. It's out of sequence. It's out of sequence, right? So, Sequence is where it has to be in the correct order to work properly. All I've got... In fact, how would I fix this? That's right. I would move this to here. And I'll change that to answer just for a bit of continuity. And run that. All is well.
Beautiful.
Sequencing is when the code needs to be in order to work properly. Whenever you see these hardcore OCR definitions, you don't have to write them. I put them in a while ago because a very long time ago they used to expect you to know it. They haven't asked it for an extremely long time. I wouldn't even bother with the hardcore definition. Get in the basic definition when the code needs to be in order to work properly. In fact, I've just deleted the hardcore definition because, we don't need it anymore. When the code needs to be in order to work properly, and here is an example. I want you to do your own example, please, of code that has to be in order to work properly, and next to it, some code that has broken because it's in the wrong order. This could be like maybe doing somebody's first name and printing the first name and last name before the last name was defined, or like the mathsy example that we just did. Get it in your notes. Oh. This here is a video I show in class by Matthew C. Applegate from 5 to Code. Lovely guy. We're just going to watch a small excerpt from his. Have a quick listen to this. In fact, I'll put it on 1.25 because he speaks a little bit slowly.
It's super important in life, not just in computer programming. Take this example. It's a bit extreme, but you'll get the point. 1. Make a pie. 2. Turn on the oven. 3. Eat the pie. 4. Take the pie out of the oven. 5. Put the pie in the oven. Depending on the type of pie you were making, this could be really bad for you. So, it's super important sometimes. Let's look at this example once again. Now, tasks 1 and 2 are possibly interchangeable. It might be a bit wasteful energy-wise, but at least you won't be ill from eating an undercooked pie. So in this case, sequence isn't really that important. However, tasks 3, 4, and 5 are not interchangeable and could result in a culinary disaster.
A culinary disaster.
Here's another example, this time in Python. A equals 10, B equals 20, D equals C divided by 2, and C equals A plus B. This program won't actually run. Why? Well, it has no idea of the value of C is. A is 10 and B is 20, but D is C divided by 2. But wait, what is C? The program will get to line 3 and get a bit upset. It will give an error, something like name C is not defined. Let's fix it. Now it will give us the average of A and B.
Beautiful.
Sequencing, making sure the code is in the correct order to work properly. A little bit of a recap now. Get your paper out, pretty please. We're going to do a little bit of recap. Remember, the more you recap stuff, the deeper it goes into your long-term memory, and the more likely you are to remember it
In the exam.
Get it in. Let's go. On your piece of paper, on your notes, wherever you like, and then we'll answer it in about 50 seconds. Go.
Do it, do it, do it, do it, do it, do it.
5 data types: bool, int, float, string, char. Define the term variable. Name or identifier for a memory location that can be changed while the program is running. What's the difference between a variable and a constant? A constant cannot be changed while the program is running, and there are at least 3 errors in this code below. First one, num2 is defined as a string, not an integer, because it's got quotes around it. Next one, on line 5, we can see right here, we are using num5 without actually saying what it is, so that's not going to work, so we've got an issue right there. And then finally, there is no number 10. There is no number 10. It was never defined. Those are your errors. There may actually be more. I'd made this a while ago, but those are the errors that I can see. Yeah! Hello. selection then.
Oh, I'm blinking hungry, me. Oh, I could just go for the pasty. Or I could go for the baguette. Or I could go for the Big Mac. I need to make
A decision. Selection. It's when the code makes a decision on what to do next. In Python, there are two ways of doing this. We can do it with ifs, or we can do it with case match statements. I'm going to show you ifs first. Time to consume some alcohol. Welcome to the Singer Pub. So, at the Singer Pub, we only allow people to drink if they are 18 or over. This is not the United States. This is Britain. So, 18 or over. What we're going to do is I'm going to make an age variable. Let's say the age of this person, they're about to be 18, but they're not quite 18. They're 17. If I wanted to check their age, I would use a basic if statement just like this. Now, let me show you how we do it. It's very simple. First, we start with the keyword if. Okay? If age is... Now, how would we check that that was correct? How would we know that it was legal? Well, if it's 18 or over, right? So we write that down. Do you remember the crocodiles that you used to use as a child? Yeah, okay. If age is greater than or equal to 18... Oh, I've given the game away a little bit there, haven't I? If I just put if age is greater than 18, what would be the problem? That's right. 18-year-olds wouldn't be able to get drinks because it's only over. It's got to be greater than or equal to 18. If age is greater than or equal to 18, we can print is your drinky booze. Very good. Now, just pay attention to what happened here, because a lot of things just happened, and if you don't understand this, you will die. Colon at the end of every if statement. This says, listen, this is what's coming next. So everything that comes after the colon is what happens, okay? And just in the same way, after a colon, we have to have an indent. We have to have an indent. We have to have an indent. When I'm teaching this to my students, I always show them this image. This is the indent. This is so important. Never forget your indent. If you do, it will break your code. Don't forget it. Even one space out of place, it breaks it. If ever you need to do this, it's just tab on the keyboard. So let's say your code look like this. Tap tab on the keyboard. It's usually just next to the Q key. And it does it just like that for you. Don't try and space it manually, or you could get your spacing wrong and it won't work. You'll be very sad. So we do our indent. Now, if they're not 18, we need something else to happen. So we're going to use the keyword else. Else. Print. Yeah, bad. Mate. Let me get the correct. You are bad, mate. Get out of my pub.
Let's give this a shot. So what are we expecting to be outputted here? What are we expecting? Let's run it. You bad, mate. That's correct. If I change this to 99, what are we expecting to happen? Is your drinky boots. And what about 18? Does our edge case work in this case? Here's your drinky poos as well. Fantastic. We're going to do an example not with numbers now, but with strings, because it's a little bit different. Let me show you. So, let's say I'm making the singer home, and I want to make sure that only Mr. Singer can enter. I could do something like if name equals. Oh, why did you use 2 equals there, Mr. Singer? Because 1 equals is for assignment, remember, from about 20 minutes ago. And if name equals is comparison. 2 equals is comparison. 1 equals is assignment. Don't forget that. And don't forget your quotes as well. If the name is Mr. Singer, then we can do a little colon and print a welcome home, honey. Welcome, honey. Never mind, I'm keeping it. Else. print you are not my husband. You are not my husband. Let's see if it works. Give it a go. Invalid syntax. I forgot my quotes around welcome honey. Silly singer. Forgot my quotes. Even the best of us makes mistakes sometimes. Forgot me blinking quotes, didn't I? Let's run it. Welcome honey. Yay. But if I change the name to something... Oh, notice that I did a little comment saying what data type my variable was. It is a data type string. Look at that. Very nice. If I change this to Mr. Songer, the classic Mr. Singer imposter, and we run it. You are not my husband! No, no, no. Selection makes a decision on what to do next. We can do this using if or else statements and case switch statements. For the example today, when doing a case match, I'm going to do a shape checker. So we'll have an integer to represent the number of sides, and we'll make the case match tell us, what sort of shape it is. Or, we could make it more interesting and do bicycles. Cycle checker. So what we'll do, we'll have an integer to represent the number of wheels. Wheels equals, and we'll start with 1, for our example. Don't forget to say your data type. Data type is integer. And then we'll do match. So this is where we say what variable we want to match. And in this case, of course, it's going to be wheels. We want to match those wheels. Do a little colon, just like with the if. Under that, we're going to say what happens in each case. This is why it's called case match, match case. In the case that this is the case, what do we do? So, case 1, so case where wheels is 1, we would print unicycle like a clown. Woo. In the case that it's 2, we would print... I'm sure you've all ridden one of these before. I can never spell bicycle. Bicycle, yes. In the case where it's 3, I would want to print tricycle, tricycle. Okay, let's see if this works. If I run this with 1, best case scenario, it's going to give us unicycle. Yeah! Yay. What if we do 2? Sorry, 2. Run it. We get bicycle. And what if we do 3? We get tricycle. Very, very nice and very good if you want to do lots and lots of if statements in a row. A case can make it like nice and pretty. When you're playing a video game and it's checking for what button you're pressing, it's usually a case match, like the case that you're pressing up, case that you're pressing back, etc. It's usually a case match. Now, the one thing I haven't shown you how to do with this is what happens when a case doesn't go to plan. What happens when something that isn't there appears, and I'll show you. So we know what these 3 are, but what if somebody entered like the word banana or the number 0? We need an else equivalent. You know, like when we did else with ifs, we need an equivalent. So what we'll do is we'll do case underscore colon. This is the equivalent of an else for a case. So we could put unknown or we could put error or something like that. If I run it, boom, 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 boom. 5 big booms. So unknown, this is the equivalent of an else. Literally, with both of those, you have got everything for the basics of selection. There's 2 more things I want to do with you afterwards, but these are the 2 basic things. I want you to get all that in your notes, and I want you to do me an example on your own in your Python IDE of your choosing for an if and for a case. Sometimes it's called switch, a match case statement. Just like that. You could do wheels on a unicycle. You could do like a shape checker if you wanted to do, again, numbers. You can do whatever you want. It's just a different way of doing selection, selection, selection. Get it in, go. Don't forget your highlights. just want to quickly introduce you to my good friend Boolean operators. So when we want to do an if, but we want to check more than one thing, or this, or not this, we can use the Boolean logic gates that you may have learned about in Key Stage 3 and you will learn about later on in this unit. They are and, or, and not. And, or, not. Okay, take a look here. With an and, both have to be true. This and this have to be true. For an or, it can be this or this can be true. And for a not, it's simply just not. Okay. So down here, I've got a little code example for you that I've started. So you've got name is George. If name equals George, or name equals Amy, or name equals Dr. Ivo, Sonic fans, I hope you get that reference. Cool name, bro. Otherwise, your name is not cool, bro. We can use ors to combine these together. So here I've started off some code to enter a username and password. To check it, I could do two separate really complicated if statements, or I could use the and Boolean operator. I'll show you what I mean by that. Let's say the username and password for real is Mr. Singer and Big Bean. Let's do if username, how many equals? 2, that's right. 2 equals. If username equals Mr. Singer, here's where the Boolean operator comes in. And, notice how it went blue because it's a keyword, and password equals Big Bean. Then we can print something like logged in. Whereas otherwise, else, we would say something nice and simple like,
well, sweater fart.
Maybe something like that. See how we can use it. Not is very, very similar. We could even modify this to be like that. Yeah, we could even switch this round. Yeah, you can see I've switched it around. This is the not equal to operator. So we could even do the opposite and say if username is not equal to Mr. Singer and password is not equal to Big Bean, go away sweaty, otherwise logged in. So it doesn't really matter which way you do it. It's whichever way you prefer. Get in those notes for Boolean operators. Do me that table, 2 across by 4 down, and get me in your own example that uses ors and ands, please, at the very least. Give yourself about 8 minutes. Go. This last one I'd like to go over is called comparison operators. Now, you can see here, you did the crocodiles when you were in primary school, but don't forget them. They're very, very important in computer science. So you can see here, we've got equals, which is equal to. We've got exclamation mark equals, which is not equal to. Very, very important to remember. Less than is your crocodile, of course. Less than or equal to, greater than, and greater than or equal to. Now, I've got a challenge for you for this one. I want you to write down these comparison operators, of course. That's all I need you to write down. But for this, you are going to copy my code, but it's not finished. You are going to finish it for me. So here, we've got a grading system for somebody's exam. You're going to sit an exam. So here we've got if mark is greater than or equal to 90. Print, you got an A star, because it makes sense if you got a 90% or above, right? If mark is less than 90 and mark is greater than or equal to 80, so it's between 80 and 90, we give them an A. If it's less than 80 and bigger than or equal to 70, we give them a B. I want you to finish that for me all the way down to grade F. I want you to put it in your notes. I want you to finish it. Do your best. That'll really test your comparison operators and your Boolean operators. Don't let me down. Do your best. Give yourself about 10 minutes. Go.
I don't know, Lyndon. It just feels like every day we're doing the same thing over and over and over again. It just keeps repeating. Do I really have to reiterate? Iterate. Oh!
Iteration. Iteration is loops for and while. You've got sequence, selection, iteration, sequence, selection, iteration, sequence, selection, and iteration. Those are your three programming constructs: sequence, selection, and iteration. It's loops in Python. This is for and while. So there are two types. There is for and while. Count control. Oh, ha, ha, I want to suck your blood. Not that kind of count. Count as in counting. It does it a certain amount of times. While is condition controlled. While you are being naughty, you are grounded. It is a condition for while the thing is being repeated. Down here I've got a couple of examples, but I'd rather make some with you. We're going to do for first. So, for a for loop, all we have to do is quite simple in Python. We use the keyword for. Who would have guessed? We use the keyword for, and then we can call this whatever we want. We can call it banana, we can call it Graham, call it whatever you want. It's just a counter, so I call it x. For x in range, do your brackets, and in these brackets, three numbers are going to appear, and these are the most important numbers in all of iteration. This is your start, your end, and your increment. And always, always comment it at the end so you don't forget start, end, increment. If you remember that, you will be in a very good position. It is in that order as well. Let me show you what I mean. So let's say we print bean. Don't forget your quote, silly. Print bean. With that, let's see what we get. If we run it, bean, 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 bean. Let me change it down to 5. So there we get 5 beans, you can see, because it's running 5 times. We start at 0 and we go to 5 and we go up by 1 every time. What if we print bean plus, and remember str, because x is an integer, plus the counter plus x. Let's do that. Bean 0, bean 1, bean 2, bean 3, bean 4. What if I just print x? Do you want me to just print x? String x? 0, 1, 2, 3, 4. So it's going up all the way and stopping at 5. Do you see that? So it's 0, 1, 2, 3, 4. So it's 5 in total, but it starts at 0, you see, which is why it's not going all the way up to that. Change it to 10. Run it. It's going to go all the way up to 9 because, again, there's 10 values there, but it stops when it gets to 10. Do you see? If I change the increment to maybe 2, it's going to go up in 2s instead. 0, 2, 4, 6, 8. 2, 4, 6, 8. You suck. I'm great. That's how we do it, right? 0, 2, 4, 6, 8. So that would be the increment. I usually leave that at 1. Alternatively, if you wanted to go like top to bottom, you could even start at 10, go down to 0, and go in -1s. That would also work. Could do it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's the start, the end, and the increment. The start, the end, and the increment. This is for loops. Like, if you get this, you are in a very, very, very good position. Remember, for loops are count controlled. For loops are count controlled because they do it a certain number of times. It only did it 10 times with our example down there. It only did it 10 times, and it will never do any more. We are saying do it this many times. It's counting. It's saying do it this many times. Okay? A while loop, on the other hand, Stewie Griffin, a while, cool whip. A while loop, on the other hand, needs an external variable. It needs what's called a counter. I like to call this counter, and I usually start it at 0. Well, it doesn't need a counter, but in a lot of cases it will. I'll show you what I mean. So a while is condition controlled, right? So we'll say, for example, while counter is less than 10, we'll print beans. Now, here's the problem. If I run this, it's actually going to kill my IDE, and I'm going to kill it just for you. Let's run it.
Infinite beans! Infinite beans! The beans are never ending! No!
I just killed my program because I didn't tell it to increase counter. It said while counter is less than 10. Well, counter never changed, so it always stayed at 0, so it was always less than 10. So we got infinite beans. That's the infinite bean glitch. This isn't good. What I need to do is counter. I need to make it go up by 1. And to do that, I would do something like counter equals counter plus 1. Let's give that a shot. Beans, 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 and it hit 10 and it stopped. We've got 10 lots of beans, all as well. If I wanted to print counter as well, just to show it going up, print counter just like that. Give that a run. Beans 0, 1, 2, da, 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 da. So you can see how that works, which is really, really beautiful. Now, while loops are incredibly useful for situations where you don't know when a loop is going to end. And I want to give you a really practical example here. So we're going to make a username and password system, like a username password checker. Now, normally, all we could do would be something nice and simple like, I don't know, username equals string, input, what's your username? I have to do this one-handed because I'm holding the mic, so apologies for the slow typing. And password equals string input. What's your password, mate? Okay. Now, normally, I could do this, and I could do like a little if, and be like, if username equals, and we'll do Mr. Singer again. Mr. Singer and password equals big beans. We could print logged in, right? Else go away. Okay. If we run this, what's your username? Bob. What's your password? Heinz. Go away. Doesn't work. But the problem is, little children, I only get one go. When you log into something, do you only get one go? I think you get a few, don't you? So we can use a while loop to let us have a few more tries at this. Let me show you what I mean. So if we wrap this inside a while loop rather than keeping it on the outside like this, we can do something really clever. What we'll have is a little value called logged in. I'll set that to false to start with, so that's a Boolean. Boolean. I better set those data types as well. String and string. So we've got a string and a string. Okay, good. So what I can do is I can wrap a while loop around this, like while logged in equals false. So we'll keep asking until they log in correctly. We're going to ask for their username. We're going to ask for their password. And what we'll do is we'll say, if username, Mr. Singer and Big Beans, we can print logged in and set logged in equal to true. So if they do log in correctly, we are in all as well. Notice my indents are getting corrected because now it's all of this is inside this while loop. So don't forget your indents. This is all inside this. Okay. I could even move this message to be even more efficient down here. So once we're outside the while loop, once this is all done, if you ever want to use comments to show that, you can always do that, like with some hashtags like that, just to give yourself an idea of where it ends. That's absolutely fine. I used to do that when I was starting out as well. So we can see here, while logged in equals false, it's going to ask for the username and password. If it's correct, it'll say true, and then we'll get logged in. Otherwise, it'll say go away. So let's see what happens here. Let's give it a shot together. What's your username? We'll do a wrong one. Let's do umbrella and bird. Go away. What's your username? it's going to let me keep trying over and over again until I get it right. So let's try and get it right this time. Mr. Singer, big beans. Boom! 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 5 big booms. We got it. Hooray. That is a classic example of something you might see in the exam for like a login page. So defo worth practicing that. Defo worth practicing that. That is your definition for iteration, getting the definitions for for and for while. And I want you to do a nice fat example of each. I've got those 2 basic ones down there, but obviously you've just seen my amazing example with the logging in system. So let's make it nice and interesting. Do me an example for each, please. Get in your definitions. Give yourself about 12 minutes for that.
Go.
Do it. When you've done that, please screenshot this into your notes. Loads of kids forget that for is count controlled and while is condition controlled. So this is just a graphic to make sure that you don't forget. Get it in. Go.
Revision is boring,
Hard
and lonely, but I've made it fun, addictive, and social. Welcome to Metagogy. Every topic that you need for your entire computer science course is here. Daily quizzes customized for you. Earn coins for every correct answer you get and boost multipliers that increase with your streak. Wow. Earn daily rewards for keeping your streaks. Metagogy will send you twice daily notifications straight through to your phone. Super convenient. Building you up on the topics that normally break you down. Mr. Singer's Metagogy has fully customized flashcards for the entire course, made by me. Beautiful, saves you lots of time.
Oh, what a relief!
Spend your coins on all sorts of goodies and show off to your friends in the student plaza.
Look at me!
See your friends who are online glow green in the student plaza. Maybe challenge them to a game in the play hard zone.
We work hard, we play hard.
Mass destruction, where correct answers destroy your opponent's piece.
That's so violent.
Or Singer speed chess, where only the person who gets the answer correct first gets to move their piece. Many friendships have been lost.
Oh no, Travis, why did you do this to me?
If you have no friends or like being alone, you can play against my AI, or you can play Singer Blast. Singer Blast. Every 4 pieces you answer a question. If you get it right, you get to choose the next piece. But if you get it wrong, the speed of the game doubles.
Anxiety!
Bounty hunters.
Oh, scary!
Hunt down coin bounties for your toughest quizzes and earn bonus coins and crush the quizzes that have crushed you. Collect your own aquatic creatures in the Singer Snap micro game. Will you be the first in your class to collect all the Icthoi, even the shiny and the arcane ones too?
Oh, so rare!
Show off your tank to your classmates and maybe you'll be chosen for Tank of the Day. Not to mention Knockout Mode, the programming gauntlet, and so much more that I don't have time to discuss in this short video. Not to mention, I'm adding new updates and features all the time. All this and more await you in Mr. Singer's Metagogy. Note, only Mr. Singer's students can access Mr. Singer's Metagogy. Click the link in the description or check out metagogy.co.uk to see how to become one of Mr. Singer's students. Limited slots are available
Because server costs are expensive!
There's my logging in example from earlier. If you didn't manage to get it in, there's your opportunity. Something fishy going on round here. Something a bit sus. Something doesn't quite add up.
Arithmetic
Operators. These are your arithmetic operators in Python. That's a posh way of saying symbols. They're symbols that we use to do maths. So you can see here we got addition, that's a plus, big brain. You've got subtraction, that's a minus, big brain. You've got multiplication, that's a star, medium-sized brain. So yeah, to do multiplication, we use a star, so like C equals A times B, just like that. We can't use an X, because obviously that's just a letter. Division is a slash, divide, divide and conquer. That's how I remember that divides a slash. It slashes it down the middle. It splits it into, if you divide a cake into and then eat both halves, you're slashing it, right? The two that I want to go over with you and I want to do an example with are the last two. These are the ones that kids struggle with. These are modulo division and integer division. So this bad boy here is modulo division. This is usually represented with a percentage sign. Who's done maths before? I'm sure you've done maths before. In maths, you have what's called a remainder, and a remainder is what's left over after a division, right? So all a modulo division does is it gives you the remainder from a division. So if we've got, for example, 5 modulo, you can almost think of it as 5 remainder 2. What would that give you? What remainder would that give you? I suck at remainders, by the way. It took me ages to understand this. It would give you 1, because 5 divided by 2 gives you a remainder of 1. Okay, very, very good. Very, very nice. Modulo is remainder. Modulo is remainder.
Time to chop off its head!
Chop off its head. This is integer division. The way that I remember this, I find this far easier to remember than the other one, is it's 2 slashes. Slashy. It's 2 slashes, right? It slashes off everything after the decimal point. It just leaves you with the integer. So if we did that with 5//2, what would we get? That's right. We would get, run it, 2, because the real answer with a single slash would give us 2.5, but with a double slash, it just chops it off. Bajowie, gone. You see, integer division just leaves you with the integer. Pretty easy to remember.
I want that table in your notes. It's 1, 2, 3, 4, 5, and a 1, 2, 4 across by 1, 2, 3, 4, 5, 6, 7 down. 4 across by 7 down. I want all them definitions, all them examples. You got to know every one of them off back of your hand. And for the examples, do it me in Python, please. Do it me in Python. Give me proper examples. None of this nonsense. Give me proper examples, please. Do your best. Go. Whee!
Here's just a couple of practical examples I've seen in previous exams for where modulo and integer division have been used in actual exam questions. So they did one where you could check if a number was odd or even, because obviously if there is a remainder, then it can't be even. If there is a remainder, it can't be even. But otherwise, it's odd, right? So that's a nice, easy example. A really tough one they did a couple of years ago was turning minutes into hours. Again, using your integer division to get the hours and modulo division to get the minutes. And they did it just like that. So I just thought I'd show you those as examples. You're welcome to screenshot them in if you want them as a practical reference. Our next set of titles here for the next part of the course, we're going to do string minute methods, we're going to do some file handling, we're going to do some arrays, subprograms, procedures, functions, we're going to do some variable scope, some parameters, benefits of subprograms, random number generation, and a bit of SQL and databases to finish off. A lot of titles there, give yourself about 6 minutes. Go! Go! Go, 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 go. Go, 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 go. Go! I feel like I've been manipulated. String manipulation methods. So, yeah, this is how we manipulate strings using different methods. I'm going to show you a few, and you're going to do me examples of each. First one on our list is the good old len. Hi, Len. So len gives us the amount of characters in a string. Dead useful. Have you ever tried to make a username on something and your username was too long or your password was too short? Have you ever seen that where the length wasn't quite long enough? That's going to be using len, the string manipulation method len. So let me show you how we do it. What I would do is maybe username equals, let's do a full input. Let's go for it. Input, string input, what's your UN? And we could do if len, in fact, you know what? I'll make it simple. Length equals len username. And that should give us the length of whatever we pop in. So if I put bean, you'd expect it to be 4, right? Oh, sorry, I didn't print it because I'm stupid. I also wasn't sharing my screen because I'm a moron. So here we go. We've got username is string input, what's your username? Length equals len username. So that's the string manipulation method we're using there. And we could do something like print length and see what we get. Now, if I put beans in here, or just bean, we get 4 because that's 4 characters long. If I put Bob, I get 3 because that's 3 characters long. And if I put I get 20 because it's 20 characters long. Okay. We could even bring this into an if statement to check if the username is too big. If length is greater than 15, we could print username too long. Silly. Let's give that a go. So, I forgot my else as well. Else. Very nice. There we go. Stop and run. What's your username? Hello. Very nice. But if I do username too long, silly. So you can see len being used there in a very practical way. Speaking of practical ways, one of the most practical things that we can do with string manipulation methods is making something case insensitive. So if you had an if statement like if username equals Graham, like that, print welcome. We won't do a password for this one. We'll just do username. Welcome. Else password. Sorry. Else print. Go away. If somebody types in Graham with a capital G, all is well. But if somebody types in Graham with a lowercase g, which is fine because usernames aren't actually case sensitive, that should work, but it doesn't. It says, go away! But I am Graham! But I am Graham. So why didn't it work? Because the capital G didn't match. Now what we can do is what we can do here is instead, we can just change this to Graham in all uppercase. My caps lock isn't working right there. Graham in all uppercase. And change this to dot upper to force my username to come through as uppercase. So if we play this now, what's your username? And we do Graham, like that, all in lowercase, even though this says uppercase here. Welcome. It worked a treat. Look at that, upper, and the same as lower is exactly the same, just does the opposite, makes it all lowercase. Really, really handy, upper and lower are. So what you have here is a story that I've written. We've got my story. There was once a chunky dog called Graham. You can see that there. And I've just added to it my story equals my story plus. So remember the concatenation with the pluses. He ate other dogs called Graham. He also loves cheese. And when I print my story, I get the following story. Okay. But what if I wanted my story to not be about dogs at all, but I wanted it to be about cows? Well, what I could do is use the replace string manipulation method. So we could do my story equals my story dot replace, and then we can choose what we want to replace. I could replace all the dogs with cows. Cow, C-O-W. And if I run that now, we can see there was once a chunky cow called Graham, and he ate other cows called Graham. He also loves cheese. I could even change it so that Graham is a different person in the story as well. My story replace Graham with Maggie. Maggie. There we go. There was once a chunky cow called Maggie. Oh, okay. Pronouns broke on that one. I should have done. Let's do a gender neutral name. Let's do Alex. I was once a chunky cow called Alex. He had other cows called Alex. He also loves cheese. You can see the replace function is so handy. This one's a basic one. This one is called substring. So a substring is like if I did print. Remember, what is a string? It's a collection of characters. That's right, a collection of characters. So if I do my food and I use the square bracket, I can output any particular character there. So if I do, remember, arrays start at 0 from the video before. So I could do 2, and that would give me 0, 1, 2, the letter A. A, beautiful. And I could also do 5, and that would give me an index out of bounds, because actually that's there. I meant 4, sorry. Run that. S. See what I'm into? A substring is just an individual character from that string. There are a few more in here that I didn't do, but that's what you're going to do. I want you to make me this beautiful table, 3 across by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 down. And I want you to do examples for each of these except for the red ones. You can't do the red ones in Python. It's annoying. They may come up in the exam, but the context will explain it. For each of them, I want the description and an example that you have made. Give yourself 16 minutes. Do your best. Go.
Do it.
I love you so much, Althea! I love it when exam boards add things. So two technically extra manip methods that they added in 2024 were left and right. And you can see here, this returns the first X number of characters from the left-hand side of the string. So this would give you like the first however many characters from the left-hand side. And this would give you the same, but from the right side. So I just thought I'd show you those to add to your table, or you can screenshot them below. Exam question time! Exam question time. You've got an exam question right here. Yeah, beautiful. Do it. 3 marks, 3 minutes. Screenshot it in. Go. Your answers were A, B, C, D, 1, 2, 3 for the yeah, because it was dot upper 1, 2, so it made it all uppercase. A, B, C, D, 1, 2, 3, all in uppercase. Next one was A, B, C, D, because you got the first 4 from the left coming in, A, B, C, D. And then the last one is int message dot right 4 times 2. This was the hardest one by far. And that gave you 2, 4, 6, 8. This is because it's taking 4 characters from the right side, converting them into integer, and then multiplying by 2. Most people got 2 marks on that, not the third one. But well done if you did. So here's the issue, right? If your computer, your phone, your device turns off, you lose everything that isn't saved, and you are sad. You ever lost a game because your mum turned off your Xbox? Yeah, you have. Have you ever lost your work because there was a power cut? Yeah, you have. We need to save what we do to a file. We're going to do file handling. I'm going to be totally transparent with you now. So when we started this, I said you could use any Python IDE that you wanted to. And for most of the course, this is true. However, for this part, you got to be specific. So if you look at my screen, I'm on Google and I typed in online Python IDE, right? This one, first one, won't work for file handling. Trinket does, but again, it's dying in 2026. Maybe someone will take it over. I don't know. Trinket's great. Program is, that one doesn't work. That's Reddit. The first one I found on Google that works for this is this one, pythononline.net. So I clicked on that, and basically, to make a file, what we have to do, let me delete the one that I made earlier. Don't want you to see that yet. What we have to do is quite simple. Let me just zoom in. Zoomy. Now, what we do is we do the name of our file handler variable. So we need a variable to kind of keep it in the program, if you like. Because obviously the file isn't inside the program. We need something to handle it. So we're going to make our file handler, and we can call it whatever we want. Call it my file or file handler if you want. In fact, call it file handler. Then we need a new command word that we're just about to learn, and that is open. Now we're going to give it a name. I could call it whatever I want. My text file yum.txt. Call it whatever I like. Okay, very, very nice. Let's see if we can stretch that out. And I need to do a comma and tell it whether I'm going to write or read, W or R. Now, we're obviously not going to read it because we haven't written it yet. So I'm going to do a W, and I'm going to run this. Boom! Look at that, right there. My text file yum, it has been created. All is well. File handling can be really tricky, so just please take your time. I want you to get in the definition here of the open. Get it all in with your highlights. Do your own example and screenshot it in, please. Make me a file just like I showed you. Again, make sure you're using the right IDE or this isn't going to work. Go for it. 6 minutes. Ooh. Now, let's actually put something in my text file yum. Let's do file handler. We don't need to change the W because we're still writing. We're not reading at the moment. We can do file handler dot write. We can do dot write, and we can do Graham. So we could just do that as a basic example. If we run this though, and we go to check my text file yum, oh, it shouldn't have had Graham there. That's a glitch. Ignore that. Because normally, unless you save your file, it doesn't save. And the way that we save files in Python is by using the file handler .close command, just like that. And that's how we save it. Normally, that wouldn't have worked. There we go. We've written Graham. If you wanted to do a couple of lines, we could do file handler .write. And then if you want it to appear on the next line, you can use the \n to pop it on the next line. Loves my onion gravy. He does love my onion gravy. Look at that. Graham loves my onion gravy. Yes, he does. Yes, he does. That's what you need for writing and for closing and saving. Get those in your notes and do your own example, please. And pop it into your notes. Go, go, go. Do it! Do it. Yes. Sorry, there's the code for close at the bottom there for you. And there's your full definition for closing the file and saving if you want to steal it. How do we then read? How do we read from a file? Well, all we have to do is change that W into an R. If we go back to our code example from before, I'll delete the right stuff and I'm just going to change that to an R. And if I wanted to bring anything from that file into my work, I could just do this. Let's say, call it message or whatever, it doesn't matter, call it banana, equals file handler dot read, just like that. Message equals file handler dot read, just like that. Oh, I spelled file handler wrong. There we go. And I can print the message just like that. And we'll see what we get. Boom! We've just taken data from an external text file and put it into our Python. That means you can save, you could literally save what somebody inputs. You could do an input, save it to a file, and then you've got it for later. How crazy is that? Get these beautiful notes in for me. Go, 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 go. Do it, do it, do it, do it, do it, do the raw. If you wanted to not read the whole file into a string, but just a certain line, and there may be various reasons. Let's say you've got many usernames and passwords stored in a single file. There might be different people's details on each line, and you might want them separately rather than together. So you could read line by line instead. Reading the file line by line using the .read line statement. If you look down here, I've bought 3 little variables called line 1, line 2, and line 3, and I've read into them using the file handler. It's called new file in this case. I've popped them in line by line and printed. It's very, very simple. Getting those notes for me and getting an example of you reading line by line from your file. Do it. This is hard stuff. If it comes up in the exam and you don't know it, it's going to kick you in the shins and call you names. Do it. Don't forget your highlights and your examples. Exam question! Exam question. Get it in, do your best. Go. By the way, don't get scared about the OCR exam reference language nonsense. It's basically just pseudocode. Just write it kind of like how they have. It's just Python, but with less strict syntax, really. Go for it. It's 5 marks, 5 minutes. Give yourself 5 minutes. Don't let me down. Go, 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 go. Of course, we were looking for the keyword open sesame, and then read line. So we got, let's go through together actually. My file equals open data.txt, while not my file dot end of file. You didn't have to worry about that. Temp, so it's just a temporary variable, equals my file dot read line. If int temp is not equal to 0, print temp. Should have got the print one right. And then at the end, to save it, we're going to do my file dot close. My file dot close, of course. And they would have accepted read line for BP2. And ignoring spelling errors as well, which is nice. Okay, this one is not a fill in the blank. This is just raw. You've got to go for it. This is 4 marks. OCR Drones flies goods around the country using drones. Who would have thought? A text file is used to store pilots' codes and dates of birth. The text file is named pilots.txt. The contents of this file is shown below. You can see it right there. Design an algorithm to ask the user to import a pilot code and a date of birth. Write these inputs to pilots.txt. And that's it. That's it. That's it. That's it. Crazy. 4 marks. Give yourself 4 minutes. Don't let me down. Go. do was take them two inputs, open up pilots.txt with the open command with a W, because it's obviously we're going to write to it, write both inputs to the open text file, and close it. Their example down here, they did it with the right line, but you could have done it just with that if you like, that's fine. So basically, if you got two inputs, you've done your two inputs, you get 1 mark there. If you open pilots.txt with a W for that, and if you write both inputs to the open text file using an outline, and then you close it, you get all 4 marks. Oh, lovely! Give yourself a mark out of 4, Kiddie Winkles. If you didn't get full marks, screenshot the mark scheme as always.
Time for some recap.
A variable is a name or identifier for a... Give me the 2 types of iteration. What are they? They're both ending controlled. And which string manipulation methods would be useful for making a password checker case insensitive, you insensitive man? 2 minutes, go. That woke you up, didn't it? A variable is a name or identifier for a memory location, of course. A variable can change its value while the program is running. 2 types of iteration: count controlled, condition controlled. For loop for count, condition is while. Which string manipulation methods would be useful for making a password checker? We did this earlier, and it is, of course, upper and lower. You didn't think these would be coming back, did you?
No!
So if I want to have lots and lots and lots of variables, like lots of data, like maybe I want to store all the kids in a class. That's quite rare. I mean, you do a register every lesson and all the kids in the class are stored together. Do we make a separate variable for every single kid? No! That would be stupid. What we do instead is we do a string is a collection of characters. Well, an array is a collection of variables. In this example here, I've got an array of 4 elements. 4 elements, you can see. Here's the key though. Just like in Sonic the Hedgehog or any old school video game, when you hit 0, you don't die. 0 lives. You die afterwards, and that's because 0 isn't wasted. 0 is a number, and arrays don't waste 0 either. The first index is always 0. So here, Bug Eye Singer would be index 0, you see, in this array. Index 1 would be Toothy Singer, index 2 would be Inflatable Singer, and index 3 would be Screaming Singer. 0, 1, 2, 3, not 1, 2, 3, 4. 0, 1, 2, 3. 0, 1, 2, 3. Okay. Now I want to tell you a story about my daddy. Daddy Singer is a plasterer and he is 5'3", but has latissimus dorsi. His lats are massive because he's so small but so wide. He looks like a square. Almost like a manta ray. When you think of arrays, I want you to think of Daddy Singer. Square brackets.
An array is a
collection of variables that have the same data type. You can't mix and match strings and numbers. It's all got to be the same data type. The index is the slot number. For example, on the array below, Andreas is at index 0, whereas Will is index 1, Molly 2, Casper 3. The element is the data itself. Let's do an example together. Best hedgehogs, I hope I spelled that right. Best hedgehogs.
we will add to our, remember the square brackets? Square brackets, square brackets, square brackets, square brackets. And first is obviously Sonic. We separate the elements with a comma. That's how we know we're going from index 0 to 1. We'll do shadow and silver. Sonic, Shadow, and Silver are the best hedgehogs. Okay, so that's an array of size 3. If I wanted to print Shadow, what would I put in my print statement? Think about it. I'm waiting. We would print best hedgehogs. I can't spell. Best hedgehogs. Daddy Singer brackets. And is it going to be 1 or 2? Well, remember the array starts at 0, so this is 0, this is 1. Pop it in there. All is well. Delicious. Let's give this a shot. Boom! Shadow the Hedgehog. Live and learn. Yeah, so there you go. Get in your definition for Unity! Get in definitions, don't forget your highlights, and make your own coded example of an array as well, please. Go, 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 go. Now, for traversing the array, this is how we do it. Let me show you. If we want to traverse it, i.e. we want to print everything that's inside it, we either need to use, we need to use iteration, but it either needs to be for or a while. So let's take a look together. We'll do for first. Remember, for x in range, and we got our start, our end, and our increment. So we're probably going to start at 0, because that's the first index. And what we're going to do, we're going to use that len that we learned about very recently to give us the length of the array. Yeah, we're going to use len that we learned about earlier. You know, in the string manip section, it also works for arrays. Len is wonderful. We can do len of best hedgehogs. And we're going to go up by 1 every time. So we'll start at 0 and go to the end of the array. Do you see what I mean? Remember, always comment this. Start, end, increment. Okay? Start, end, and increment. Then, if we pop down, we can print. What are we going to print? We're going to print best hedgehogs. Of course, because we want to see what the best hedgehogs are. Are we going to put 0? Because if we do 0, we're just going to get Sonic over and over and over, because he's in 0. If we just do 1, we get Shadow over and over. What is changing every time it does a loop? What variable here is changing? The answer is, of course, you tell me. Thought I was going to give you the answer then, didn't you? X. Because X is going up every time we go around. So best hedgehogs, X. And we run it. Boom! Fantastic. That's what I'm talking about. So that is how we traverse an array with a for loop using len and popping X where the index goes. Using a while is actually kind of easier. I'll show you what I mean. So if we do a counter, we could do while counter is less than, and we can use the len thing again. Len best hedgehogs. We could do print best hedgehogs and counter, because obviously that's like our replacement for X here. And we've got to make sure that counter goes up by 1 every time. So counter equals counter plus 1. Let's give that a shot. Boom! Fantastic. So we got it. If you want to do it with a while or a for, it's totally up to you. I quite like the way it's done with a for, but yeah, totally up to you. Traversing the array. I'd like you to do me an example with a while and a for loop for the array that you made in the previous slide. Print it out using a for and print it out using a while. Give yourself about 8 minutes for that one. Do your best. Go. Quick bit of recap!
Quick bit of recap. The 5 data types are: explain what each data type is or what it means. State the 3 programming constructs, that should say, or 3 programming constructs. SSI, SSI, SSI! And leave the last one because we've done plenty of coding at the moment. I just want you to do me those first 3. Go. Five data types are string, int, float, bool, and char. String is a collection of characters. Integer is a whole number. Float is a decimal number. B is a bool, is a true or a false. And a char is a character. 3 programming constructs. Selection. Sorry, I should have said it in order. Sequence, selection, and iteration. What keywords do we use for selection? If, else, case, match. And what keywords do we use for iteration? We use for and while. This is your reminder to get Mr. Singer's Metagogy. Get on Metagogy. It's listed 3 times down here. So nice, you'll say it thrice. Best way to learn, best way to revise. You will maximize your grades. You will get top grades using Metagogy. Interactive, it's everything. It's everything I've learned from being a teacher, just poured into the most incredible, engaging revision app ever. It's personalized to you. You can get it on phone, on desktop, send you notifications. It's wonderful, like daily reminders for tasks. Also, like literally, just watch the promotional video for Metagogy. Exam question time. A game on a computer shows 6 players round a table on seats. They're numbered 1 to 6 as shown below. The names of the players are stored in an array with 6 within an array, in an array, in an array with 6 elements called player name. The index position of the array is used to indicate the seat number. For example, player name 1 is Helen, and we can see Helen's there. What is the value of player name 3? I'll give you 30 seconds. Go. Lydia. It's Lydia. Here's a harder one. Elliot plays football for OCR FC. He wants to create a program to store results of each football match they play and names it goal scorers. Elliot wants individual players from the team to be able to submit this information. The number of goals scored in each football match is held in an array called goals. An example of this is shown below. You can see the array of goals there. 0, 1, 2, 3, etc. Elliot wants to count how many matches end with 0 goals. Complete the following pseudocode for an algorithm to count up how many matches with 0 goals are stored in the array and print it out. So basically, this has got to go through this, and it's got to count how many times we get 0. So we're looking, if it's 0, what are we going to do with the count? And then what are we going to print at the end? 3 marks, 3 minutes, go!
Do it. Screenshot it in. Do it. Do it. Do it.
Of course, it's count, no goals, count +1 there, and print no goals, count. Very, very good. If you didn't get it right, screenshot mark scheme into your notes. Do it now. Do it, do it, do it.
The Mr. Singer Paper 1 and Paper 2 revision guides. Lovely.
Oh, it's gorgeous.
Everything you need for a grade 9, equivalent to an A star at GCSE for Paper 1 and Paper 2.
It truly is a thing of beauty.
Filled to the brim with exam-specific notes, highlighted, colour-coordinated, gorgeous.
What an absolutely gorgeous piece of equipment.
Every section has accompanying exam questions and mark schemes, so you can test yourself.
It truly is a thing of beauty. Where can I get one of them?
If you're one of my students, ask me about the revision guides. If you are external and just watching this on YouTube, be sure to check the description. Check the description for your own revision guide for Paper 1 and Paper 2.
Delicious. Do it.
Looking a bit flat there, Mr. Singer. Little bit two-dimensional. Ooh, two-dimensional arrays. 2D arrays. A 2D array, well, an array is a collection of variables, right? And a 2D array is an array of arrays. It's a collection of collections, if you like. Here's an example down below here. Names and ages. So we've got Henry 14, Alfie 15, Ellen 15, and Taslima 14 right there. If we printed names and ages 0, 1, we would get array 0 in here. So you can see you've got your big array with your daddy singer brackets at the side. And then inside here, you've got a smaller array with Henry and 14. Now, this is kind of breaking the rules, really, with mixing data types. I'm sorry about that. I shouldn't have done that. That was naughty. I was so upset about my blunder, I've actually gone in and fixed it. And I've made it more interesting, too. Full names, John Smith, Sonic Hedgehog, and Mr. Singer. So we're storing the first and the last names, which is a great use for a 2D array. If I wanted to print Smith, I would need to print full names, 2 pairs of daddy singer brackets, 0 and 1, which would give us array 0, which is here, first array, and then not 0, but 1. Array 0, 1, that would give us Smith. And you can see there, 0, 1 gives us Smith. If I wanted Hedgehog, I would need 1, 1. And if I wanted Singer, I would need 2, 1. Do you see what I mean? What I want you to do is get in that definition for a 2D array, make me your own 2D array, and steal my lovely little table-based example. I think it's a really great way of visualizing it. Go! Do it. Here's one for you. So if you want to traverse a 2D array, you actually don't just need one for loop, you need 2 for loops. So what we do, birds live in nests, and we have to nest our for loop inside another one. So I've just done a little example down here to show you. So we've got games and scores. Again, that's breaking the rules. It shouldn't be multiple data types. I'm sorry about that. But the point is the for loop down here. So let me show you. You've got 3 little arrays in here. It's a 2D array. It's quite small. So what we do is we use X to go through the whole thing. So this is going to go through the arrays themselves. And that's going to go to the length of that array. So you see, to the length games and scores going up by 1. And then inside there, we have a Y that's going to go for the length of each array, i.e. X, inside games and scores. Do you see what I mean? And it's going to work out. So this one would go to this first array, and then inside there, it's going to go index 0 and index 1, because it's going to go through that, incrementing through. Beautiful. And we're going to print games and scores X and Y, and that's going to give us the correct output. This is how you do traversal through a 2D array using a loop. You can do it with a while loop, but it's nowhere near as nice. Generally, we only do this with a for loop. Get in those notes, and I want you to do me a nested for loop for the 2D array that you just made, and I want you to output it. Do your best. Give yourself about 8 minutes. Go. Basic little exam question for you. We've got a 2D array here, which is like days of the week, whatever, teachers do the amount of time that kids play games, whatever. Write program code to output the number of minutes that Stuart played computer games on Friday. I think it's 1 mark. Do your best. Go. Of course, Stuart is 0. We can see that here. Friday is 4. So we were looking for mins played 0, 4. Print mins played 0, 4. Give yourself 1 mark and screenshot the mark scheme if you didn't get it right. Here is a tougher one. The pseudocode algorithm totals all the numbers in the 0 indexed array scores. So total 0 for score count 1 to scores.length. So that's just going through the array all the way through. Scores score count equals total plus total. next score count. So this is just the OCR pseudo. Don't worry, next doesn't mean anything. It just means it's going to loop. It's going to keep looping. Print total. The function length returns the number of elements in the array. The algorithm contains several errors. The two types of error in the program are syntax and logic. Identify the two logic errors in the pseudocode algorithm. So all that's saying is, I know we haven't quite got to those error sections yet. I don't think we have. But what are the logic errors with this code? Okay, what's it doing? Where's it start? Well, I don't want to give anything away. This isn't a syntax error. It's nothing spelt wrong, nothing like that. There's a logic error with this code. It's not doing what it should be doing. And what should it be doing? Give yourself a minute. Have a think about it. Of course, the array starts at 0, not 1, and they started 4 score count equals 1. So the first error we're looking for is changing that 1 to a 0. And then the second one, of course, is line 3. We're saying scores equals the total plus 2. So we're just going to double it every time, which is not good at all. You could have had any of these 3 options for that. Total is scores, score count plus total. Total is total plus scores, score count. Or you could have done the plus equals posh way of doing it if you want to be posh. Do a clap, do a clap, do a clap. Let's begin.
Bit of a refresher for you.
A constant is a for a A constant changes its value while the program is running. Define the term iteration and give me 2 examples of iteration types and their keywords, please. And write the code to loop through an array of integers at least 3 elements big. Ooh, with a while loop condition controlled. Give yourself 4 minutes. Go! Of course! The answers are: a constant is a name or identifier for a memory location. A constant cannot change its value while the program is running. Define the term iteration, give 2 examples of it. You got can't controlled and you got condition controlled, aren't you? That uses a for and a while loop, doesn't it? Write the code to loop through an array of integers. So you'd have your array of integers. So my array equals daddy's in your brackets, whatever the integers are, no quotes. And underneath, you'd have like a little counter, maybe counter or x. While counter is less than length of the name of your array, print out the name of the array, brackets, counter. Underneath that, you'd increment counter, counter equals counter plus 1, something like that. Easy peasy lemons. Squeezy! I'm very small. Sub-programs. I'm over here, just waiting. If you need anything, let me know. I'm just over here, waiting to be called. A subroutine, a sub-program sits in the background, waiting to be called. The main program can call it and execute it. It is a mini program that waits to be called. There's your definition for a subroutine, a sub-program. Get in that definition, please. Go. 1 minute. Bippity boppity bippity boppity bippity boppity boo. Let's talk about the first main type of subprogram, shall we? It's called a procedure, and a procedure, we're going to have to perform a procedure to save the dog's life, okay? Welcome to my surgery. So to make any kind of subprogram, what we need is the keyword def. Def. Define. Def. Define. It defines that subroutine. Let's do one that does something dead simple. Let's say it prints a couple of things. Or do we make it a bit more interesting than that? You know what? We'll make it more interesting. We'll do add 2 nums. okay? And we'll pass in x and y as parameters. I'll tell you what that means in a little bit. And what we'll do print x plus y, okay? So that is the procedure with 2 parameters. Boom, there we go. If I run this now, we can see the code's there. It says print x plus y. I run it. Nothing happened! Nothing happened, did it? And that's a terrible, terrible shame. Why did nothing happen? Because just like Singer over there, when he was waiting to be called, the program's waiting to be called. Now, how do you call a doggy? You say its name. So we've got to say the name of this procedure. What's the name of the procedure? It's add to nums. Look at that. And we can choose what numbers we pass in now. So for example, 5 and 10. And if we run that now, and I'll put calling it, and give it a run. Boom! We get 15. Fantastic. Isn't that delightful? I could call that again just below. Let's add 2 nums again, and this time we'll do 510 instead. Give that a run. Whoa! Delicious. I can call it again, do whatever I want. 5 trillion and 2.5, whatever it might be. Run it. Boom. I've only had to do that code the once, but I've called it many, many, many times. And it's outputted, it hasn't returned any data, it's just outputted data. I'll show you about returning data when we do functions. So a procedure doesn't return data, it 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 doesn't return data. To the program, it doesn't return anything back, it just does whatever it does. You've got an example down here that multiplies 2 numbers together. You've got the life story example here that says somebody's life story. You can do whatever sort of procedure example you want to do. I want you to make it, and I want you to call it. Get in those definitions, get in your own code. Go! I have returned! Because functions do return data. I'm going to be real with you here. Functions are really, really difficult to understand. We didn't used to do them until like after A-level, like degree level sort of stuff back in the day. It's quite new that it's been added to GCSE in the grand scheme of things. So please go slow with me and just relax. It is hard, but if you slow down, you take your time, you will get it just fine. So to define a function, it is the same as defining a procedure. The top line looks exactly the same. In fact, what we'll do the add 2 nums one again. Or should we mix it up? We'll do multiply. Multiply 2 nums, like that. Pass in x and y, just like we did before. Again, comment. Function to multiply x and y. And under here, I'm going to do return. I'm not going to do print. I'm going to do return. Remember, a function returns data. I'm going to return x. What's the symbol we use to multiply? That's right, times. I'm going to return x times y. Okay. Now, that, when I run it, is that going to output anything? No, because it hasn't been called yet. Good spot. But if I call it down here, multiply 2 nums, and I pass in 5 and 5, so we'd expect 25, right? 5 times 5. Nothing comes up. Are you feeling depressed? 'Cause I am! The solution is very, very simple, though. We have returned that data to where it was called from. You can almost think of an arrow being drawn from here, jibawi, over here. Okay. What we need to do is put the return value, we need to shove it somewhere. Maybe we can put it into a variable, or In fact, yeah, let's put it into a variable. Call it answer equals whatever the return value is. So this is going to shove its return value into answer. And then all we've got to do is print answer. Bishy, bashy, boshy, lemon washy. Boom, boom, boom. We got it. 5 times 5. Easy peasy, lemon squeezy. We've returned a value. So this is a function. Now you will rightfully say, Mr. Singing, Mr. Songing, Mr. Sung. Why? Why are you doing that? So let's say you're playing a video game like Minecraft. And you get hit by a zombie or a pig man from the nether. We don't want to just output, ow, you've been hit. We actually want to return a value from that damage calculation. We could, even with this example here, imagine this wasn't multiplying two numbers. Imagine it was a damage calculator that passed in the item that hit you, the armor you were wearing, and maybe if the person was enchanted or not, something like that. And it calculated the damage. We wouldn't want it to just output, you have had this much damage. We would want to return that value so that we can apply it to our character. Do you know what I mean? So we can actually reduce the amount of health that they have. So you find functions are often a lot more useful than procedures. For basic stuff, procedures are great, but for anything advanced, functions are the way to go. Speaking of the way to go, I want you to go get me this definition for functions, and I want you to make your own function example. I've got a lovely add two nums example down here. You can do whatever you like. Make me a function and go.
Zrit.
Key exam question.
A library gives a book, blah, 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 nobody cares. Describe one difference between a function and a procedure. 2 marks, 2 minutes, screenshot it in, do your best and go. Go.
Zrit.
Of course, a function returns, but a procedure does not. A function returns a value, but a procedure does not.
You know the drill, you know the drill, you know the drill!
Paratroopers are incoming!
So, I'm sure you've heard the term para before. I'm going to try and do this like this. It's really hard to write Greek with a trackpad. Para. Para means beside, along, or alongside of. So next to, so you know like a paramedic next to a medic, paratrooper next to a trooper. Meter, something measured, like a measuring stick. It's beside your function or procedure. It's beside your subroutine, and it gives something extra, something we can measure. That's the way that I like to think about it anyway. We've done 2 examples of it already where we passed X and Y into that addition one before, so you've seen this, and it's very simple. It allows us to do all sorts of stuff, like with adding 2 nums, we can use that, and we can use that over and over and over and over again for all sorts of different additions. We don't have to change the code itself, we just change the parameters that are passed into it. Isn't that handy? Yes, it is. Getting the definition for parameters and getting your own example, and screenshot mine, please, because there's one keyword here that you didn't know about, and that is arguments. Arguments. The parameters would be like num1 and num2, but the arguments are what actually... I love working in a school. Parameters. Getting that definition, getting your own examples, and go, go, go. If there was a bit of a glitch there, I'm really sorry. My software just went... Oh man, it's still going crazy. Yeah, really sorry about that. My computer went crazy. I just had to close PowerPoint. I think OBS and PowerPoint were having a big fight. But we're back now. So, yeah, getting the notes for parameters. Pretty please go.
Captain, I can see a pile of doubloons on the horizon. I don't know why all pirates are Scottish. I can see a pile of doubloons on the horizon, Captain. How can you see it? Through me
telescope.
Scope is what you can see. 360 no scope. Didn't use the scope, didn't see. Pow! Telescope. Pow! Other kinds of scope that they use in medical settings, not going to say the name of that one. But yeah, scope is what we can see. And in our program, there are two main scopes. There's global, which is nice and wide. Global, got the wide shot for that. Or much more personal, much more intimate. Local. You got global, and you got local. See what I mean? So here, I've got the function we made a little while ago. And I'd like to show you what I mean by scope. So inside here, inside this function, x and y are local variables to that function. They exist there, they're in there, and if I try and use them outside, because x and y exist, right? They're there. If I try and do print x, just trying to show it, you know what I mean? What's going to happen? It's going to say, x is not defined. Very, very sad indeed, because it's inside this scope. This is local scope. This is global scope. And in the same way, if I up here define x as something like 555, right? Let's make it something even, let's do 67, lol. And we run this. Now, it's still timesing 5 by 5. You can see that. It's still doing 5 by 5, and it's still giving us 25. Now, why would that be if x has been defined as 67? Shouldn't it be 67 times 5? Well, no, because local variables always take precedent over their global friends. Whatever's local, think about it this way: if you've got a shop near you and it's local, you're not going to go down to London to get your eggs. If the shop on the corner, your local shop, has got the eggs that you need. That's silly. Local comes first. If there is no local, then yes, it will use a global instead. Like if I take away the x from here, right, just take it away completely, and I try and do my multiplication now, I run that and I get 335 because there's no local there. But while there is a local there, it will always prefer the local variable. Get this in your notes, everybody. A global variable is defined in the main program. Local variable is defined in the procedure or the function. And bonus marks, and this is what I was talking about earlier, if it doesn't assign its own variable, it will use the global one. But the local one takes precedence. Get it in, go, and get in your own example of global and local scope, please. I've done a little example for you to follow down here. Go. Why, Delilah? My name's not Delilah. Why? Why are we doing this? Why are we doing functions? Why are we doing procedures? What are the benefits, Mr. Singer? I'm so glad you asked. And these are the benefits. They're easier to maintain, as code is easier to understand and read, as you can see from before, like with the add two nums. Dead easy to read, dead nice. We can break down big problems into small ones. Remember decomposition from 2.1. Each subroutine, remember subroutine's posh with function and procedure, that's just the same thing. Both of those are a type of subroutine, can be tested separately. If you're working on a game and somebody's done the subroutine for the jumping and somebody's done the subroutine for the shooting, you can test them separately, which makes it a lot easier to test. We can also reuse the code in other programs. Do you really think when Rockstar made GTA 6, which might even be out by the time this video is out, lol, but I guess we'll see. When they made, do you think they remade all of the physics and stuff from GTA 5? No, they've got the physics. It's all there. The jumping, the cars, the rolling, the shooting, all that sort of stuff. It's all there. And in the same way, when you go from like Mario Galaxy 1 to Galaxy 2, you're not going to remake all of that lovely gravity physics. You're going to use some of the code again, aren't you? Yes, you are. It's quicker to develop new programs. Making a sequel to a game is much quicker than making the first one because you've got that code already in place. It avoids repetition, so we don't have to keep repeating it. With that add two numbers code, I didn't have to keep repeating the bulk of the code. I didn't have to keep keeping the plus symbol. I could just call it over and over and over again. And finally, just like Mr. Singer, it's shorter. Get those in your notes. Go. By the way, the stupid thing that I used to remember this is make badgers try reading quickly, really speed run. Yeah, maintain, breaks down, tested separately, reuse, quick to develop, repetition, and shorter. If you want to use that, you're welcome to. Give yourself about 6 minutes. Go. If you want to steal my stupid picture, you're more than welcome to. Make badgers try reading quickly, really speed run. Get it in, go, go, go. Cheeky exam question for you to make sure you know. Give me 2 benefits of a programmer using sub-programs. 4 marks, 4 minutes, pause the video, go. You could have had any of the following. Breaks down, reuse, repetition, easier to maintain, debug, to test, split it up. There's loads of examples here. Any of those, give yourself a mark out of 4. Pretty please do it. Screenshot the mark scheme if you got it wrong. Honestly, I have never seen a turnip so massive in all my life. And it started speaking to me about the price of chickpeas and crude oil. What was that all about? That was just insane. Mr. Singer, you're being a little bit random. Random number generation. Random number generation. Delicious. Let's do it. First thing we got to do, we got to import some goods from abroad. We're going to import my good friend, not Randolph, not Randy, but Random. And what we're going to do is, check this out, so let me show you how it works. For once you do it, I can do print, and I can do random dot rand int. That's going to give us a random integer between 2 numbers. Now I can say what lowest one's going to be and what highest one. So if I said between 0 and 3, it's going to give us a number between 0 and 3. Look, 0, 3, 2, 1. We can make that as big as we like though. We could go all the way up to 10 if we wanted. Let's do that. 10, 4, 3, 9, 8, 10, 1, 10. 10s. Oh, 10 comes up a lot, doesn't it? Maybe it's all the way up to 10,000, doesn't it? All the way down to minus 44. Beautiful. You see what I mean? It gives us random numbers. Now, you say, Mr. Singer, why do I need that? Well, have you ever played a game that has a bit of a chance element to it? Like a loot box? Or maybe you're pulling cards out of a pack in like a card-based game. Or I know FIFA's got that pathetic, evil Ultimate Team mode that is just gambling for children. All of these will use random number generation to decide what you win. That's where the randomness comes from. What I want from you is the definition of random number generation right there and some code that you have made. Do your best. Do your best. Be a guest. Be a guest. Just kidding, we're not going to do Beauty and the Beast. Go, 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 go. Last section for this, we're going to do databases. Come here, let's have a chat. Now, seriously, one of the last jobs I had before I came into teaching was a database reporting developer for quite a large company. And I love databases, I really do. I find them very interesting and genuinely really easy to program. So I hope you will too. These are your titles for the database section. This is SQL. And get them in. Go, go, go. 3 minutes. Bippity bappity bippity boo. Before we start actually programming some databases, I need to go over some key terminology with you. This is a table. A table. If you've seen a table before in maths, geography, history, whatever, raise your hand. You don't have to do it. You're in your bedroom probably, but you've probably seen a table before. Now, this is a table of students in a school. So, for example, down here, you've got the student's ID,
So you've got to have a unique ID because some kids have got the same name, haven't they? So we can't just rely on that for the ID. We got a student ID, we got first name, surname, group, and age. The key terminology you need to know, though, is this whole thing is called a table, a table. Everything going horizontal. Well, to be honest, I did throw that can of beans at that dog. And I got quite a serious criminal record. A record? Did we bug out then? Are we all right? What's going on? Sorry if we bugged out then, folks. My laptop, we've been recording for like 5 hours straight today, so my laptop's really, really struggling. Basically, a table is the full table. A record is horizontal. So, for example, this one for Sam Sampson, 9AB, age 14, student 001. That is a single record in that table. A field is a unique piece of data about an entity. So again, the entity in this case would be student. The table represents the entity. The table represents the entity. So for example, maybe if it's a movie table, the movies table would be the table, but the thing inside, the entity that it's representing would be a movie. It could be a movie, could be a student, could be video games on Steam, could be albums on Spotify, whatever it might be, okay? So, and then the field name is the identifier for the column. So you can think of records as horizontal, field names as vertical. Fields are the individual ones. So for example, the field of student 004 for first name is Megan. See what I mean? Get all that in your notes, please, and screenshot my example down here because it's got those lovely annotations and I think it really, really helps. Now, I need to teach you this. So we can't use our Python IDEs really for this. We need to use Programmers SQL. If you type in Programmers SQL, that'll bring up a nice little editor. Obviously, it might not be available when you do this, but it's been available for a few years, and I really enjoy it. So the first keyword I'm going to introduce you to in SQL is select, select, select. All select does is it tells us what fields to bring back. So I've got a few tables we can play around with over here. Let's do customers first because it's definitely the easiest to understand. I want to select, let's say, first underscore name from, and again, there's your next keyword, from. That's going to choose the table. What's the name of this table? It's customers. That's right, from customers. Okay. There we go. And then if I run that, look at that. I get all the first names of all the customers. Beautiful. What if I wanted the first name and the last name as well? Well, I could then use a comma to separate them. And I could do last underscore name and give that a run. And look at that. I get everybody's first name and everybody's last name too. All is well. Beautiful. Very, very nice. See what I mean? So that is the select statement. Okay. What I want from you is the definition there for select and getting your own example of a select statement from Programmers. I'd like you to select something from one of those tables, screenshot it in, show me you can do a select statement in SQL, preferably mix and match it with some commas as well. Do me some multiple columns. Go. PowerPoint is being super weird at the moment, kids. I don't know what's going on. It's like a graphics glitch. So I'm just going to run it out of full screen. So sorry about the less than pretty visuals. From is next, and we've already done it. So just get the definition in for that. It literally chooses the table that you get the data from. So from students would bring back data from the table students. Get that in for me. A go, go, go. Okay, to make sure you understand that, I'm going to just give you some mini SQL challenges. There are two sets of these. These are the basic ones, and then I'll give you the hard ones after we do the where keyword. So I want you to select all customer names, period, first names and last names, and then select all customer addresses, then select all fields from the customers, and then finally, I want customer names, addresses, and their country from the customer table. All four of those, screenshot them in, do your best. Oh! Where are you? Where did you go? Where did you go? The where statement is basically the if statement in Python, but in SQL. Okay, that's the best way to think about it, to be quite honest. So we've got our select and from here, and we got all these customers over here. We got John Doe, Robert Luna, etc. And if we look, in fact, we'll bring back their country as well. We'll bring back their country and their age as well, just so we've got everything. Now we can see we got some different customers here. We got a couple of customers in the UK, and we got a couple of customers in the USA, and one customer in the UA. So what if we want to just focus on our UK customers? Maybe we're doing some sort of promotion in the UK, or maybe our US customers or our United Arab Emirates customers, and we want to do a promotion just on one of those places. Well, what I could do is bring back everyone where, stupid caps lock, where country single equals, remember, in SQL, you don't have to do double equals, it's just single equals. Single quotes, UK. Let's see what we get. Run it. Woo! 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 Woo, it worked. Look at that. What if we want to just bring back everybody from the USA? Boom! Look at that. It worked to treat single equals whether from the USA. What if we only want people from the USA who are under the age of 25? What if it's a young person's promotion? Let's do and age, and it's the crocodiles, just same as Python, less than, I'll zoom in for you, and age is less than 25. Let's give that a shot. Boom, it's just you, Mr. Robert Luna. Look at that. This is where statement. Wheres are so powerful. In the exam, that's where most of the marks usually live. Here is your definition for a where. Get in the definition, and I want you to do me an example as well in program is. Give yourself about 6 minutes. Go. I'd like you to go back to the select statement because of that weird glitch with the laptop. I missed this. One of the most important tools is something called the wildcard. So if you don't want to type out every single field every single time when you want to just get all the fields, you can just do a star. Your star is your wildcard, and it just brings back every single field in a table, and it's beautiful. That's called the wildcard. It is a star. The wildcard is a star. Get that in for me in your selection and do an example as well, please. Go. All right, before we do any exam questions, these are your challenges for SQL. Now, I've tried to make it as hard as possible, going from easy to difficult. If you can do all of those without help, I think you're going to be in a very good place for this, because SQL can be worth quite a few marks on the exam. So do your best for me. Get them all in. Let's go. I'd give yourself 15 minutes for this. Go for it. Okay, first exam question. This is a ticky boxy one, so screenshot this in. OCR Tech is an online shop that sells electronics such as TVs and games consoles. In fact, I'll zoom in so you can see it a little bit easier. Items for sale. Oh, it's bugging again. Nah. Stupid PowerPoint. Items for sale are stored in the database TBL stock. Look at that. I'll zoom in so you can see. Stupid PowerPoint. I can't zoom in. PowerPoint's being a pooket. You're just going to have to up the res on YouTube. An extract of this table is shown below. The GSC 5, the Game Station 5, that very AliExpress, all that sort of stuff, 4K television, whatever. Tick one box to identify the correct statement to select the item code and item name for all items that have a price of £60 or over. So what are you going to do for your select? What are you going to do for your from? What are you going to do for your where? In fact, go for it. Do your best. Screenshot it in. Go for it. And your answer is as follows. Select item code, comma, item name, And is a Boolean operator. It's used for wheres and ifs, not for select. You know this? You know it was comma. From TBL stock, that was the name of the table, where price is greater than or equal to 80 or 60 or whatever it says there. I can tell it's such low res, I can't tell. This is a harder question, but easier to read. The database table results stores the results for each student in each of their chosen subjects. There's your table. Complete the SQL query to return all of the fields for the students who take art. All fields, don't forget your wildcard, all fields for the students who take art. So again, the name of the table is results. Don't miss that. 3 marks, 3 minutes. Go. That woke you up, didn't it? Hi. Select student name, subject, and grade. Well, the comma grade, shouldn't say and, silly boy. From results, where subject equals art. Beautiful. Also, you could have had select star, like it says at the bottom there. We have come to the end of 2.2. Get out your metagogy. If you haven't got Mr. Singer's metagogy, get it. Become one of my students in the description below. It's the best way to revise objectively, and the kids who use it absolutely love it. Get metagogy. If you don't have metagogy and you're not one of my students, I would expect a minimum of 52 flashcards made for this. It's an enormous unit. We've done 150 slides. This is just massive. Ready for the next lesson where we will do our cheeky little exam. Get your flashcards ready. If you're not a Mr. Singer student, but if you are, get on metagogy and revise 2.2, and I will see you lot in the next unit. Good. Oh goodness me. Ah! Now, son, you've got to be brave.
But Daddy, I'm scared of the injection.
Authentication! No, mate, no. You've got trainers on. Get out! You are fat. Oh, come with me. Boo! Take me home!
Oh, gross. I don't want to catch a disease.
Of course! You're not even wearing a shirt, and you've got a tattoo that says, I am Big Dave.
Get it? Yeah!
Comments, for goodness. Ah! What bananas are you on about? This is a car dealership. No. Money! What is it? What is it? Of course! Manus! Don't call it beans, that would be stupid. We're not allowed spaces in your variable! Stop pooing. Ah! Cheeky crisps. It's all breaking down! What am I supposed to do? Does that make sense? I sure hope so! You are fat and ugly and disgusting. How dare you say about that about me? I thought we were friends. Well, now that you mention it, your beans taste like banana bread. Oi, there's no need to get defensive. Defensive design! We're doing defensive design. Before we begin, quick reminder about Mr. Singer's metagogy. The best way to revise. Use it, get it, links in description. Here are your titles for this section. Get them in, you got 5 minutes. Go! Do your best. 5 minutes. Go.
Oh, my hands are a little bit dirty. Oh, gross. I don't want to catch a disease. I better
sanitize them. Input sanitization.
Story time. But 15 years ago, there was a database at a university near to me. It might have been a university I attended. I will not
Disclose that information.
But that university didn't sanitize the inputs on their database. And somebody managed to delete all their
Records.
by simply typing in the password box, delete from students. It deleted the entire database. We just did SQL in the 2.2 unit. It's basically the idea of shoving SQL into a text box instead of shoving in what you expect, like a username or a password or an address, shoving code in there instead. And that has got to get to the database, right? Because the username and password's got to get stored in the database. So instead of storing that, you shove some database code in there, some SQL, you can destroy it. If we don't sanitize our inputs, we are
Totally stuffed.
Those are your notes for input sanitization. Get them in.
Go.
Cheeky little exam question!
Cheeky little exam question.
Above, you've got some definitions, and below, you've got to match them to the words that define them. So, do that. 4 marks. You don't even need 4 minutes. 1 minute.
Go.
Screenshot it in your notes and do it. Yeah.
Of course!
Of course, decomposition is D, breaking a complex problem down into smaller problems. Abstraction is the removal of unnecessary detail, so I believe that is B. We just did input sanitization, clearing up data by removing non-standard characters on the input. That's input sanitization. And converting one data type into another is, of course...
Cathy!
Now, son, you've got to be brave.
But Daddy, I'm scared of the injection. I'm so scared. Please help me.
You've a right to be scared, son. This isn't your normal injection. This is a nasty injection. This is an SQL injection.
We discussed this a lot in the last section. Input sanitization prevents SQL injection. I mean, I just gave you the story about it. So you've got an example down here with SQL, shoving it in, sneaking it in inside the username or the password. You can use it to delete data, modify data, and worse, steal data from a database by shoving SQL in somewhere not expected. Getting those definitions for SQL injection and the example as well. Give yourself 4 minutes.
Go.
Pause the video.
Now, those of you who know me know that I am a massive, big, tiny Pokemon fan. I actually had a living dex all the way up to Gen 6. 721 Pokemon? Yeah, it was pretty crazy, right? I was a big shiny hunter too. Good fun. I love Pokemon. But when I was a child, the 2 new Pokemon games, when I was about 12, were Pokemon Diamond and Pokemon Pearl. And the console that had just come out at the time was called the Nintendo DS. I'm sure you've heard of the 3DS, or this was the one before it. And the DS had a piece of hardware that no Nintendo console had before. That was a microphone. Oh, exciting. So on your games, you could blow into it, you could talk to your creatures, whatever, right? And the Pokemon company decided they would use it for a custom Pokemon. That Pokemon's name was Chatot. There's a picture of one on the screen right now. Beautiful little bird with a music note on its head. And Chatot's gimmick, Chatot's special thing was it didn't have a cry. Chatot could be programmed to whatever you wanted to say. So you could literally say whatever you want into the microphone, and that would be the sound Chatot makes when he comes out for battle. Nintendo, bless them, were very naive in this decision, because you can imagine what teenage kids do when they have the opportunity to say whatever they want on a children's game while battling online. Let's just say these Chatots were extremely offensive and often quite racist. So not good at all. Nintendo did not do input validation. Input validation means we validate the input before it goes into our database. Nintendo didn't validate that there weren't dodgy words going into chat art, but we can validate what's going into our emails. Okay. The basic definition of input validation is checking that an input meets a certain criteria to make sure it's in an acceptable form. But there is a much bigger definition, and in fact, we'll get this one in first, and then we'll get in the big five. But we'll do the basic one first. Go. 1 minute.
Get it checked.
Get it checked. The big five validation types are on your screen now. First, we've got length check. Hands up if you've ever tried to do a username or a password and it said, "This is too long." That happened to you. It's definitely happened to me many a time. So yeah, I'm sure it's happened to you. We can't have a username or password that is too long or too short. The next one's really simple. It's called a presence check. A presence check just checks that a field is not blank. Have you ever filled something in, like when you're buying something on the internet and you forget to fill in like your PIN number or your address, and it brings you straight back up and it's like, "Is it there? Did you forget your..." That's a presence check. Got to make sure that it's present. Format check, to be honest, is a little bit funky. The only one I can think of is, like in America, how they have the month before the day in their date. We have our date before our month, so it's the correct format for the data. Type check, though, is way easier to understand. 5 data types are string, char, int, float, and bool. And basically, a type check just checks that the data type for this situation is correct. So if you're entering your age, it's not going to accept a string or a Boolean, is it? If you're entering your shoe size, it's not going to accept a character. And if you're inputting whether you are alive or not, I don't know how it could possibly be not. That would be a Boolean, wouldn't it? So it's just a type check for different data types. Finally, range check. That basically means that it's got to be within a specific range. Easy example would be like a banking app. So if you're trying to pay somebody, you can't send them 0. So the range would cut off at the start at 0, and then it would go up to the amount of funds that you have. So say you've got 20 quid in your account. You can't put in more than 20 or less than 0. The range would be between 20 and 0. Does that make sense? Does that make sense? I sure hope so! Those are your 5 big validation types. Get them in your notes. Give yourself 6 minutes and go! Cheeky little check on your knowledge. Input sanitization prevents what? Write it down on your whiteboard, your piece of paper, whatever you're using for these. Define the term variable. A for a that while the program is running. State and explain 3 of the validation types we just did. Give yourself 1 minute. Input sanitization prevents SQL injection. That's right. Define term variable name or identifier for a memory location that can be changed while the program is running. Through the validation types, you could have had length check, range check, presence check, type check, or format check, and explain them in any of those ways that you can see on screen now. Ooh, nice.
I am a bouncer, and I make sure only people who are approved get through this door. Oh, well, my neck is locked.
Come on in. You're on the list. You can come in. You're on the guest list. You can come in. You can come in. You can come in.
That would be a white list, allowing certain people into the club who are approved.
No, mate, no. You've got trainers on.
Get out!
You're not even wearing a shirt, and you've got a tattoo that says, I am Big Dave, on your beer belly. No, get out. No, no, no. Get out. No.
A blacklist, on the other hand, has a set of criteria, and it says you cannot come in if you hit any of these. These are both ways of making sure that your program, your computer, is safe, but they work in different ways. Whitelist, approved list of things or people, in this case, that are allowed in. And a blacklist is like criteria that says, if you are this, you are not allowed in.
Whitelist and blacklist. These are how they work. So whitelist, list of data that program being created should accept. Whitelists are very effective and very secure. Blacklist is a list of data that the program should reject. And basically it's like inputs that are not allowed. Virus checkers use blacklists to make sure, so it gets a list of all the dodgy viruses. It says you're not allowed in my computer. Get these in your notes, please. And go, go, go. Boosh. 3 minutes. Oh.
3 minutes.
Come with me. I'm going to go hack someone's computer.
Oh, right. I'm just going to enter the username and the password. I don't know it. I can't get in.
I don't know the username and password. I can't get in. I can't authenticate.
Authentication.
Making sure your account, your computer is safe is one of the most important things in modern cybersecurity.
And there are many ways of doing it. Classic, username and password. The advanced, Touch ID. The more Apple-focused, Face ID. And 2FA, two-factor authentication, when you have to get an email or a text to make sure you're safe to log in. All of these are authentication. Get those in your notes. Go, 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 go!
Boo! Take me home!
Country road. A car dealership uses a computer system to record details of cars that it has for sale. Each car has a make, model, age, and number of miles driven. Each car is given a star rating of 1 to 5 based on the age of the car and the number of miles it has driven. This rating is recorded in the computer system. This is the meat of the question. Explain how authentication could be used as part of the defensive design considerations for this computer system. So how can we use authentication in this system? 2 marks, screenshot, answer the question, 2 minutes, go!
Do it.
I'm not going to do it again. Ensuring that only certain users can access the system. That's your basic definition for authentication. Remember, don't just talk about 2FA and usernames and passwords and stuff. It's making sure that only certain users can access the system. And secondly, any other example of authentication. So you could have had passwords, 2FA, Touch ID, anything that you like. Bill, that code you're making looks amazing. Straight fire, in fact. That's so good. Do you mind if I come along and have a code?
No. But why? Like, it's clearly some really good code. Like, why would I not be able to use it?
Because, Derek, I haven't used any comments. I haven't done any indentation. I haven't named my variables well. I haven't modularized, putting stuff into functions and procedures, and I haven't used any constants. My code is not maintainable. Code maintainability. How do we make our code maintainable? That is the question that you are asking. The answer is what did I name him? Dave. Coding Dave was doing over there. So first, use comments. If you don't use comments, when other people come to see your code, they will not know what the flip is going on. Indentation. Space your code out properly. Always do good indentation. Space it out. Make it nice and readable. Naming variables sensibly. If your variable stores the amount of money that a player has got in a game, do not call it banana. Call it something sensible like, I don't know, money! Modularize your code. This one's a big one. This is the M. So this is like using functions and procedures in your code. It makes it easy to read, kind of like we talked about the benefits of subprograms in an earlier lesson. And finally, using constants. So numbers can be updated nice and easily, like having pi as a constant in maths, or in like some banking apps, maybe they use tax as a constant and then they only change it whenever they need to, that kind of thing. So comments, indentation, naming variables correctly, modularization, and using constants. You need to know all 5 of those off by heart, get them in your notes and go! What is it? It's a cheeky exam question. Cheeky little exam question for you. The algorithm for one section of a vending machine program is shown below. If money is greater than or equal to price, then vend the item. That's calling a function, as you can see by the bracket. Give change, money minus price. Else, print error, you ain't got enough money. End if. Don't worry about the end if. That's just an OCRism for their pseudocode. You don't need that in real code. Give the identifier of one variable used in the algorithm. Give me the name of a variable in there. If you can't do that, you are stuffed! And then tell me how many parameters are passed into the give change subroutine. This is a trick question. Be really, really careful with it. Lots of people get it wrong. 2 marks, 2 minutes, then go! Of course! You could have had money, you could have had price, and then the answer for the parameters passed is 1, because it were money minus change. Silly goose. Porridge, whey protein, berries, like mixed berries, a bit of honey. Absolutely delicious. By the way, I don't know if you know this, but I film these at I get in work for 6:30 and I start filming them at 7 in the morning. So this is breakfast. Delicious. Next exam question. We've got some code up here, same one as before. I haven't got porridge in my beard, that would be very upsetting. When writing the program for the vending machine, maintainability was considered. Identify 2 ways that the program has been made more maintainable. 2 ways it's been made more maintainable. Give 1 additional way that it could be made more maintainable. Now, you've learned 5 of those, so this should be very easy for you. 3 marks, 3 minutes, go. I'm just going to eat my porridge while you answer that. You don't have to pause the video. I'm going to eat my porridge while you do it. Oh. 50 grams of protein. Straight away in the morning. I'll put the camera in and then you can watch me. Absolutely delicious. It's that tablespoon of honey. It just makes such. I hope your question's going well. Shrek's watching me eat just a bit of sauce.
Oh. Oh. You should be on third question by now. Oh, delicious. Life hack as well for the berries. Get the wonky ones. You get them from Tesco or whatever. It's like wonky berries. You get like a kilogram for like £3. So good. You get them frozen. Warm them up in your porridge. Just top tier. Top tier. 2 ways that this has been made maintainable. I would definitely say indentation, for one. Easy. Modularization, because you can see that a function has been used there. And of course, appropriate variable names. Money is an appropriate variable name for money. One additional way it could be improved, that's easy. Comments, for goodness. Comments and the use of constants, of course. Comments and the use of constants would have been great. Give yourself mark out of 3. Yes, sir, I'd very much like to buy these bananas, please. Mate, what bananas are you on about? This is a car dealership. We don't sell fruit. Yeah, well, sir, I call what you call a Fiat Panda a big banana. So, like, excuse me, is that name not appropriate for you? I don't get paid enough for this. That naming convention is wrong. Now get out of my dealership! Variable naming conventions. When you name stuff, I'm still eating the porridge. When you name stuff, it's got to make sense. If you've got a variable that stores money, don't call it beans. Don't call it beans. That would be stupid. But there are more things that you need to consider. Now, I don't know if you knew this. Some of you will have noticed when you try programming. You cannot start a variable name with a number. It has to start with letters. It can contain numbers, but it must start with letters. It can't start with numbers. Second, it must have at least one letter. Obviously, goes without saying. It must not contain special characters. You can't have exclamation marks, you can't have at symbols, you can't have pound symbols. You can have underscores if you want to. Some programmers use that. I prefer camel case, which is where you start off with lowercase for your first word, and if you've got any extra words, you just use capitals afterwards, so it looks like a camel, with the head down here and then the humps. It should contain lowercase letters. However, uppercase letters can be used if variable name compromises more than one word joined together. That is camel case. The name should be meaningful and it should represent the value that it's holding. So that's what we were on about with the BMW dealership earlier, BMW Fiat dealership earlier. So an accept file identifier would be score, not score with a capital. I wouldn't ever start with capitals. That just looks cringe. High score. It would be great if you've got camel case, but high space score. You are not allowed spaces in your variable name! You're not allowed spaces in your variable names. You can use an underscore, though. You're not allowed to do 1, 2, 3 score, because it's got a number at the start. And high score, 1, 2, 3 would also be acceptable. Those are your notes. Give yourself 5 minutes. Go, 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 go. Ooh. What I want you to do as well for this one, not just writing the notes, is make me these examples in Python, please. So do me like an acceptable next to an unacceptable. Try it. Like try making a variable name with numbers at the start and show the error message that happens when you do. Don't make a mistake. Give yourself 7 minutes for that. It's quite a big one. Go, 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 go. Why did you call me short again? You knew I would get defensive. When you see a defensive design question in the exam, it's going to look like this. And that key couple of words, I've got berries in my mouth. That key couple of words, defensive design, means trigger this in your head. Trigger all the authentication, all the input sanitization, all the stuff that we've done to this point. That should trigger because you've got to talk about it. Elliot plays for OCR FC. He wants to create a program to store the results of each football match and the names of the goal scorers.
and the names of the goal scorers. Elliot wants individual players from the team to be able to submit this information. Describe 2 examples of DD that should be considered when developing this program. Now, you can have any of the DD that we've talked about so far, and I want you to give me your best shot. 4 marks, 4 minutes. Do your best. I blinking hate football. But OCR don't. So let's talk about the examples that they talked about for defensive design. They said you could have had input sanitization with an appropriate definition, couldn't update it, etc. Validation, like the 5 validation types. Verification, that's like checking whether the data has been entered correctly. We'll do that in a sec. Authentication, ensuring that only allowed or authorized users can gain access. A maintainable code. We just talked about that with indentation, meaningful variable names, etc. Give yourself a mark out of 4 and screenshot the mark scheme if you need to. Revision is boring, hard and lonely, but I've made it fun, addictive and social. Welcome to Metagogy. Every topic that you need for your entire computer science course is here. Oh my goodness. Daily quizzes customized for you. Earn coins for every correct answer you get and boost multipliers that increase with your streak. Wow. Earn daily rewards for keeping your streaks. Metagogy will send you twice daily notifications straight through to your phone. Super convenient. Building you up on the topics that normally break you down. Mr. Singer's Metagogy has fully customized flashcards for the entire course, made by me. Beautiful, saves you lots of time. Oh, what a relief! Spend your coins on all sorts of goodies and show off to your friends in the student plaza. Look at me! See your friends who are online glow green in the student plaza. Maybe challenge them to a game in the play hard zone.
We work hard, we play hard.
Mass destruction, where correct answers destroy your opponent's pieces.
That's so violent.
Or Singer Speed Chess, where only the person who gets the answer correct first gets to move their piece. Many friendships have been lost.
Oh no, Travis, why did you do this to me?
If you have no friends or like being alone, you can play against my AI, or you can play Singer Blast. Singer Blast. Every 4 pieces you answer a question. If you get it right, you get to choose the next piece. But if you get it wrong, the speed of the game doubles.
Anxiety!
Bounty hunters.
Oh, scary!
Hunt down coin bounties for your toughest quizzes and earn bonus coins and crush the quizzes that have crushed you. Collect your own aquatic creatures in the Singer Snap micro game. Will you be the first in your class to collect all the Icthoi, even the shiny and the arcane ones too?
Oh, so rare!
Show off your tank to your classmates and maybe you'll be chosen for Tank of the Day. Not to mention Knockout Mode, the programming gauntlet, and so much more that I don't have time to discuss in this short video. Not to mention, I'm adding new updates and features all the time. All this and more await you in Mr. Singer's Metagogy. Note, only Mr. Singer's students can access Mr. Singer's Metagogy. Click the link in the description or check out metagogy.co.uk to see how to become one of Mr. Singer's students. Limited slots are available
Because server costs are expensive!
Sorry
for doing this out of order. Input verification is, have you ever been on a website and it's like re-enter your password and you end up just copying and pasting it and breaking the point of it? Yeah, that's input verification. It's like here on the side you can see we've got an Amazon box where you type in your password and then it's like re-enter it. It's verifying whether or not you entered it correctly in the first place. Like, for example, you might have had caps lock on by accident. You might have mistyped, mistyped. Checking whether data has been entered correctly is your definition. And for example, double typing info, like re-entering a password twice. Get that in your notes for verification, and please put a title in there for me as well. Sorry, I didn't do it right because I'm a moron. Go. We're gonna get started now. So yeah, those are your starter questions right there. Do your best. Don't let me down. And go, go, go. The three types of secondary storage are, of course, optical, magnetic, and solid state. FTE stands for fetch, decode, and execute. The six properties of secondary storage are portability, durability, capacity, reliability. I won't wrap this actually. Durability, capacity, reliability, speed, and cost per gigabyte. A router sends packets and receives packets and connects a LAN to a WAN. A URL is sent to the DNS and the DNS looks up the IP, do you now, address. And if it can't find it, it goes to higher level DNS, higher level DNS, higher level DNS. Quick reminder about Mr. Singer's Metagogy and my tutoring. If you wish to be tutored by me, if you're not one of my students, check the link in the description. Have a look. Metagogy is the best way to revise objectively in the world. It's absolutely tremendous. Get on it. You will do 10 times better with it than without it. Stop pooing on my lawn. I'm getting tired of this. You are really testing my patience. The lesson headings for this section is mostly testing. So this is testing. Don't test me. Don't test me. Get them in. You got 5 minutes and go. Why? Why do we test? What is the purpose of it? Well, I'll tell you for why. We got to find logic and syntax errors and we got to fix them. We got to find what's wrong and we got to fix it. Find what's wrong and we got to fix it. Logic and syntax errors, find them and fix them. Check the program meets the user requirements. If a program works and there's no errors, but it doesn't do what it's supposed to, is it any use? It's no use at all. And finally, we've got to check the program works as intended. Make sure it's doing what those requirements say it should do. Get those in your notes, everybody. Purpose of testing, do your best. Go, 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 go.
Graham, you keep making the same mistakes over and over and over again. How many times are you going to reiterate
your mistakes? Iterative testing. The two main types of testing are iterative and final. Iterative, to do something over and over again. Final, when it's done, when Singer is dead. Iterative is during development. So like when you're making a game, when Mojang were making Minecraft, Notch would test it as he went through development. He'd be like, right, is this working here? Is this working here? Is this working here? Like he'd make the inventory system and give it a test, make sure that he could craft stuff. He'd do the texture system, make sure that different textures work for different things while he was developing it. Iterative testing is where we test it during development repeatedly and while making changes over and over again. Final testing is different though. It's when development is complete or almost complete. We do one big test before we give it to the customer. This is why it's called final. It's what happens at the end. Those are your notes. Get them in. 4 minutes. Go. Cheeky exam.
Question!
A vending machine has the following options available: crisps, salted bacon, chocolate bar, apple pieces, raisins. Users insert coins into the vending machine and then enter two characters. And enter the 2-character item code. So, for example, A1 for the crisps there. If the user has inserted enough money, the vending machine will release the chosen item and output any change required, just like a normal vending machine. If the user enters an invalid item code, then a suitable error message is displayed. The vending machine is tested before it is released. Explain the purpose of testing it. We've just done the purpose of testing, so that should be easy for you. And below that, we've got describe the difference between iterative testing and final testing. And then below that, you've got to finish the testing plan for the system itself. Now, all it's asking you to do there, if you look here, the expected result down here is raisins served but no change given for 85p. So we can see that raisins were 85p. So what it's asking for there in code enters is the code that you would use for raisins. Down here it's saying error, not enough money inserted. So what would be an appropriate example for money inserted not being enough? And for this last one, for C3, what's the expected result? Do your best. This is a big one. Let's give 6 minutes. Go. So, check the program meets user requirements, detect logic, syntax errors, etc. Check the program does not crash so it actually works, and those errors can be fixed, and any suitable example related to the vending machine, for example, giving the correct change. Iterative is done during development repeatedly. We just did this, so this should be easy for you. And final is when the development is almost complete or done after iterative. Now, for your examples down here, C2 for this one right here, 49p or anything less than 50 because the expected result was not enough money, and then invalid selection or any suitable error message saying, C3 doesn't exist, that kind of thing. Give yourself a mark out of 6 and screenshot the mark scheme if you got anything wrong. Bippity boppity.
It's all breaking down! What am I supposed to do?
When an error occurs, we can become scared and afraid. But if we can categorize these errors, maybe we can deal with them a little bit better. The 3 types of error are syntax, logic, and runtime. Not that kind of runtime. Let's do syntax first. Detective time. Tell me what is wrong with this code. Give you 8 seconds. If you said the assignment is the incorrect way around, you would be correct. If we run this, it's not going to work. Cannot assign. We've got an assignment issue, a literal here. What we wanted instead was actually num1 equals 2. It was the wrong way around. This is a syntax error. The code is right, but it didn't meet the grammar expected. Let's do another one. Easier one this time. Go. 5 seconds. What's wrong with it? That's right, num1 is missing its closing bracket. Because if we run this, it's not going to, it might even say expected. Yep, bracket was never closed. Always read the errors, it will really help you to understand what's wrong. Let's do another one. What about now? 6, 5, 4, 3, 2, 1. What's wrong with it? Capital P on the print. Capital P on the print. Look, print is not defined. Did you mean print with a lowercase p? These are all syntax errors. What about this one? That's right. Missing. What about this one? That's right. Missing quotation mark at the end of Skyrim. On 2-minute string literal detected at line 1, we can see there Skyrim is missing its quote. Good. Here's another one. What about this bad boy? Have a look at this. What's wrong with it?
Plus!
That's right. Plus is missing between here and here. We aren't concatenating. Perhaps you forgot a comma. Well, a comma would work, but a plus would be better. Plus best game. The best game is Skyrim. This is true. A syntax error is an error where the code written doesn't meet the rules of the grammar of the programming language. Here are some examples. Incorrect assignment, just like we did. Missing punctuation or brackets, just like we did. Another one that we didn't do was not enough arguments for a function. Like say you've got adding two numbers together and you only pass in one, or you try and pass in three. This would be a syntax error too. Misspelling an identifier, I'm sure we've all done that, accidentally putting a capital or spelling it wrong. I want you, this is an important one because syntax errors will come up a lot in paper 2. Don't miss it. For each of these, I want you to write them down, and next to them, I want you to screenshot an example that you have made for those mistakes. Do me an incorrect assignment of statement. Do me not enough arguments for a function. Do me misspelling an identifier. Screenshot it with the error and put it next to it. You must remember this for your exam. It's so important. Get it in. Let's go. 5, no, longer than that because you've got to do the examples. 8 minutes for this one. 3, 2, 1, go.
Recap time!
Recap time. Name 2 examples of syntax errors. What are the 2 types of subroutine or subprogram and what makes them different? And give me the definition for the term variable. Go. 1 minute. Write it on your whiteboards. Go. Or your paper, whatever you're using. Go.
So examples of syntax errors could be
Incorrect assignment, missing punctuation, incorrectly spelled variable names, whatever it might be. What are the 2 types of subroutine or subprogram? Procedure! Are you ready to pay for your procedure? And function, what's the difference? A function returns data where a procedure does not. Define the term variable. A name or identifier for a memory location. Brain teaser time. I've got some code here for you. I want you to tell me what's wrong with it. There are no syntax errors. Nothing is red. Nothing is underlined. What's wrong with it? I'm going to give you 15 seconds. Read it slowly. No, it's not because it says 6, 7. Did you catch it? It's supposed to add 2 numbers together, which it passes in X and Y, and that's great. Does it add them? No. It minuses, returns the answer 6. The answer should have been 6 add 7. That should have been 13. I think my math sucks. But what we end up with when we run it is -1 because it's actually doing 6 minus 7. Logic errors. A logic error is when the code when the code that you've written works, when it runs and it translates, but it produces an unexpected result. For example, adding 2 numbers together actually minuses it. The code works and it runs, but does it do what it's supposed to? Absolutely not. Get in your definitions, let's go. 4 minutes. Do me an example of a logic error in your code as well. Go, go, go. Here's another cheeky brain teaser. What's wrong with that? This is a harder one. Mathsy people, you'll get it straight away. What's wrong with it? 10 seconds. Did you catch it? We are trying to divide by 0, and that doesn't make any mathematical sense. 0 division error, division by 0. It didn't work because you can't divide a pi by no people. It doesn't make sense. You can divide it by 1 billion, you can divide it by 3, but you cannot divide it by 0. Now, I got no red lines, so it's not a syntax error, and I asked it to divide by 0. That's what I wanted. So it's not a logic error. This kind of error is what's known as a runtime error. This is an issue that happens only when the program is running itself. There are not many of these, but they do exist, and I want to show you another one as well. Here's another cheeky example. So we've got a program, dead simple, that should add a couple of numbers together that the user's inputted, right? Here's an example of a runtime error. So if I type in 5 for the first one, all is well. And if I type in 7, all is well. So all good. 12, right? 5 add 7. But if I put 5 add banana, what are we going to get? Let's see. It's dead. And that is a runtime error because we tried to shove a string into an integer and it could not cast it because banana is not a number. Here are all the official examples of runtime errors that OCR talk about: dividing by 0, overflow error, stack overflow error. So like an overflow error is when you try and put a number that's too big for it, very, very big. An integer can only hold 2 bytes. So if we go above that, we're going to get a glitch or an error. Stack overflow is when we run out of memory space. So I'm sure this has happened to some of you when you're trying to run too much on your computer at once and it just bugs out and dies. Stack overflow error. And finally, a library error. We've done random numbers in this course. If you were to try and import random, but you couldn't get random for whatever reason, you couldn't import that library, that would be a runtime error as well. Get it in? Let's go. 5 minutes. The only one I want you to do an example of, by the way, is the divide by 0 one. The others are quite difficult to do on your own for like examples. So I'm happy with just the one. Go.
Time to cheat.
Not cheating really, but it helps. This is a beautiful summary sheet of the 3 main error types. 3 across by 3 down I want your table to be, and I want you to make this. Syntax errors are the grammar of the code, missing speech marks. Logic error is the code runs but it doesn't do what it should. And runtime is when the code works unless something is done to break it when it's running, for example dividing by 0 or using the wrong data type. Go, 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 go. 3 across by 2 down. 4 minutes. Go.
Ugh. Linking accents shouldn't have had all of that. Oh, Magnus, my goodness, that was good stuff.
Excuse me, sir, you are inebriated. You need to get out of my pub. Bouncer Singer is back. Welcome to the Pub Del Singer. Don't know why we're going for a continental spice here, but anyway. Is the pub of Sing. You can see that we've got age gets input. In fact, you read it for a second, and then I'm gonna test you on something. Just read it, understand what the program does. Okay. Age is inputted as an integer. If it's equal to or greater than 18, you can have some beer, mate. Otherwise, get out my pub. Everybody happy with that? I sure hope so. So, Basically, what we're going to learn about now are the 3 types of test data. We'll do the first together. The first would be what is considered normal. Normal data would be anything in the expected range. So, for example, like 55, you can have some beer, mate, that's expected. Or 31, something like that. You know, somebody at a pub, normal is normal. Big brain! Normal is normal. Okay. Beer, etc. Right. The second one is called boundary. Now, boundary is how we test the bounds of our program. Now, let's say I'd accidentally forgotten my equals there, and I popped an 18 in here. So we're right on the boundary of what's acceptable or not. Let's take a look. So give it a shot. Sorry, like that. If age is greater than 18, you can have some beer, mate. Here we go. 18. Get out me pub. Now you can see that on the boundary there was an issue. You see what I mean? So that's like boundary test. It'd be like 18 and maybe like 120 would be the other scale of the boundary because no one lives longer than that anymore. Now, if you've got the third type of error, we've got something called
Erroneous.
And erroneous data is where just flat out an error. Now, my favorite example for this is like the wrong data type. So instead of putting a number in there, if I put the word beans, if I put beans in there, that would be erroneous. So we've got normal, which is normal data. We got boundary, which is on the bounds, like 18 for this or like 120. And then you've got erroneous, which would just cause an error, like putting the wrong data type in the wrong place. There's also 1/4 one that OCR popped into an exam question quite recently called invalid, which isn't, it's a bit weird. They've never used it before, but I thought I'd teach it you anyway. It's data that's not suitable for a given situation. So, for example, if you were asked to put in your, I don't know, like entering your last name where your first name should go. It's acceptable, it will go in, it won't cause an error, but it's not suitable, it's invalid for this situation. Those are your 4 types of test data, and get them in your notes. You've got 4 minutes, go!
If you fail to plan, you will plan to fail.
That wasn't part of the bit or anything. I genuinely fell off my chair.
Stupid Chingy.
If you don't... if you fail to plan, you're planning to fail. A test plan is made of normal, erroneous, and boundary data, and now invalid. Thanks, OCR. You've got the expected outcome and the actual result. Now, an example from theirs, you've got right here, you've got test data, normal, boundary, and erroneous for like a certain situation. You've got the test data that will be put in. You can't see the context of the question, but this is what you'd see, and the expected output. So you've got test data, the actual result, and the expected output. And also, of course, the type of test data. Get it in your notes for me. Go, go, go. I'll give you 3 minutes. Yowie! The exam question time. OCR drone. That's flipping terrifying. OCR drones flies goods around the country using drones. Mega sus. A pilot's flying experience is validated and an algorithm checks that the experience is between 10 and 20 years. Here's the code for it. Experience is input number of years. If the experience is greater than or equal to 0 and the experience is less than or equal to 20, then print true, otherwise print false. And if complete the test plan for the algorithm. What would be an example? Look at that. Look at them cows. Look at them trees. Absolutely gorgeous. You know what's more special? When you like, comment, subscribe, turn on notifications.
of normal test data for this algorithm, then what would be the expected output for putting 20 in there? What symbols have they used? Are they correct? Then you've got the experience in years being 32. What are we expecting to come out, and what type of test is this? Do your best. You've got 4 marks, 4 minutes, go. Bippity boppity boo. Of course, we were expecting the experience in years could be any value between 0 and 20, for example. 4. The expected output for the second one is, of course, true. And finally, erroneous or invalid. They kind of put those two together. And false for the expected output. Go, 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 go. Get it in your notes. If you got it wrong, screenshot the mark scheme. Go, go, go. On Mr. Singer's Metagogy, take a look at section 2.3. Make sure you're getting over 80% on all of those before you start your actual test. Best way to revise Mr. Singer's Metagogy, Mr. Singer's Metagogy, Mr. Singer's Metagogy. Get on it. It's so... I'm not just saying it because it's mine. It is like objectively the best way to revise. All the kids that use it say the same. It's fun, it's engaging, and it really makes the stuff stick in your brain. Goes through it systematically. It's everything that my teaching is here in an app, in a learning platform that you can use on your computer, on your phone, whatever device you like. And it's social as well. So the more of you that use it, the better. If you're not going to do that, you could spend an hour making at least 32 flashcards for this section on Quizlet or a flashcard maker like Anki of your choosing. So, yeah, get on it, get revising, and then we will do your exam. And be sure to mark it with the attached mark scheme as well. You'll only have access to those if you are one of my students, remember. Link in description. That is the end of 2.3. His hair may be receding, but his knowledge is not. Give me the Big Mac. A 0 comes out.
It doesn't cost anything to buy my face.
All it costs is friendship. Woo!
Bibbidi bobbidi boo.
So I go up to him and I say, "Oi, what is the price of your face in chickpeas?" And he says, get this. He says,
It doesn't cost anything to buy my face.
all it costs is friendship. That conversation wasn't very logical. Boolean Logic. Now, quick warning. Every other unit on this course is massive, but this one is absolutely teeny. It's very, very small. We're going to finish it in like 10 minutes. I'm not even joking. This is Boolean Logic. Let's begin. These are your titles and your only titles. Get them in 1 minute. Go, 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 go. Stretching the sheen. This beautiful man is George Boole. His hair may be receding, but his knowledge is not. George was a mathematician from the 1800s, and he believed that human thought could be mastered by laws described by maths. Basically, he thought we could make computers behave like people. This is known as Boolean Logic, which is also where we get the term Boolean from. From this man, the data type itself comes from him. So, the 3 Boolean logic gates are and, which is a big D, or, which is like a crab claw or a crescent moon, a not, which is like a toddler at a party who ate too much birthday cake and fell over on his side. Now, with the AND gate, we do it like this. This is how I like to do it. Let's do an example. Let's say A is it's a school day, and B is it's snowing heavily. Okay? So if it's not a school day and it's not snowing heavily, and by the way, C is a snow day, like you're getting a snow day off. Would we get a snow day if it's not a school day and it's not snowing? No, we wouldn't get a snow day. What if it's not a school day, so it's the holidays, and it's snowing really heavy?
We don't get a snow day off either. We got the day off anyway. What if it's snowing really heavily? What if it's a school day but it's not snowing at all? No snow day. Finally, what if it's a school day and it's snowing really heavily? We're going to get a 1. If both inputs are true, the output is true. Okay, that's the AND gate. And it's so hard to draw with a trackpad. Or is even easier. Draw the same thing again. Your table looks very, very similar. A, B, and C. And what we'll do, pop our A in there, B in there. So let's say it's not windy and not rainy. Is it bad weather? So we'll have wind, rain, the weather is bad. Okay, ignore other conditions like typhoons and stuff, but wind and rain. So if it's not windy and it's not rainy, the weather is not bad. But if it's not windy but it is rainy, is the weather bad? This or this? Yes. What if it's windy but not rainy? It's still bad weather. And what if it's windy and rainy as well? It's bad weather. If this or this is true, then this is true. That's why this is called the OR gate. If A or B is true, we get a true output. Okay? Finally, this is the NOT gate. Now, I'll be real with you. I've been teaching computer science for over half a decade now, and a lot of kids really, really struggle with this. So just relax, breathe, and be calm, because this gets really hard. In an AND gate, when we put a 0 in, a 1 comes out. And when we put a 1 in, a 0 comes out. It really is that easy. A NOT gate just reverses whatever goes inside it. I want you to draw me all of those truth tables in Paint or in Word. I want you to draw in the exam. You will have to draw them. You need to know their shapes. And I want you to write me those truth tables in for every single one. For the AND, the OR, and the NOT. This will take you at least 11 minutes. Take your time. Do your best. This is so important. Go. Revision is boring, hard, and lonely. But I've made it fun, addictive, and social. Welcome to Metagogy. Every topic that you need for your entire computer science course is here. Oh my goodness. Daily quizzes customized for you. Earn coins for every correct answer you get and boost multipliers that increase with your streak. Wow. Earn daily rewards for keeping your streaks. Metagogy will send you twice daily notifications straight through to your phone. Super convenient. Building you up on the topics that normally break you down. Mr. Singer's Metagogy has fully customized flashcards for the entire course, made by me. Beautiful, saves you lots of time. Oh, what a relief! Spend your coins on all sorts of goodies and show off to your friends in the student plaza. Look at me! See your friends who are online glow green in the student plaza. Maybe challenge them to a game in the play hard zone.
We work hard, we play hard.
Mass destruction, where correct answers destroy your opponent's piece.
That's so violent.
Or Singer speed chess, where only the person who gets the answer correct first gets to move their piece. Many friendships have been lost.
Oh no, Travis, why did you do this to me?
If you have no friends or like being alone, you can play against my AI, or you can play Singer Blast. Singer Blast. Every 4 pieces you answer a question. If you get it right, you get to choose the next piece. But if you get it wrong, the speed of the game doubles.
My anxiety!
Bounty hunters. Oh, scary! Hunt down coin bounties for your toughest quizzes and earn bonus coins and crush the quizzes that have crushed you. Collect your own aquatic creatures in the Singer Snap micro game. Will you be the first in your class to collect all the Icthoi, even the shiny and the arcane ones too? Oh, so rare! Show off your tank to your classmates and maybe you'll be chosen for Tank of the Day. Not to mention Knockout Mode, the programming gauntlet, and so much more that I don't have time to discuss in this short video. Not to mention, I'm adding new updates and features all the time. All this and more await you in Mr. Singer's Metagogy. Note, only Mr. Singer's students can access Mr. Singer's Metagogy. Click the link in the description or check out metagogy.co.uk to see how to become one of Mr. Singer's students. Limited slots are available because server costs are expensive. Why use a truth table? Well, they have asked this before, so I'm going to teach it to you. The purpose of it is to show all possible inputs with the associated output. And here's an interesting one. The number of rows in a truth table is equal to 2 to the power of the different number of inputs. So for example, if you've got A and B, you're going to get 4 rows. 2 to the power of 2, 4. If you've got A, B, and C, you will have 8 rows, etc. Get that in. 2 minutes go. Don't forget your highlights. Exam question time. You need to tell me what logic gate each of these is representing. Do your best. 3, pause the video, screenshot it in. Give yourself 2 minutes. 3, 2, 1, go. The first one is, of course, an OR, because we've got 1, 1, 1 here, this or this. And here we've got a 1 when it's both true, so that is an and OR, and an and if you got it wrong, screenshot the mark scheme. Go, 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 go. This one wants you to finish the truth table for A and B or C. Now notice A and B are in brackets, so when A and B are true, or C is true. So I'll do a couple of lines with you just to get you started. 0, 0, 0, none of those are true, are they? Because is A and B true? No. Is C true? No. But on this one, we've got A and B is 0, so this is not true. But is C true? Because it says or C. So yeah, that would be true. Okay, finish it. Pause the video, go. Your final mark is as follows. It's out of 4, so for every 2 rows, do your best and give yourself a mark out of 4. If you got it wrong, screenshot the mark scheme in. Go. Here's a drawing question for you. Drawing. You've got to draw the logic circuit for not A and B or C. So not A. So we've got A going in here. What's A going to go into? Say not A. So what's it going to go into? And, so that's connecting. There's going to be an and in here. B or C. So B and C are connecting with an or, and that not A is connecting to that with an and they're all going to link up to P. 3 marks. Do your best. Go. And of course, we were expecting A to go into a not because it was not A, B and C going into an or because it's B or C, then both connecting with an AND gate, just like this, going out to P. Screenshot the mark scheme in and give yourself a mark out of 3. A computer game uses a controller with 3 inputs, A, B, and C. An action P is carried out if the player presses A with either B or C at the same time. Complete the truth table. B equals not A or B and C. So we're looking for whenever A is 0, because it's not A, or B and C are. So when B and C are 1, we're going to get a 1. As well as when A is 0, because it's an or. Okay. So that first one, that's going to be a 1, isn't it? Because A is a 0. Doesn't matter that B and C aren't. That first one's going to be a 1. Finish it. Go. Do it. This was the answer we were looking for. So, yeah, give yourself a mark out of 3, 1 per highlighted section. If you got it wrong, screenshot the mark scheme in. If you got it right, give yourself a mark out of 3. Go. Here is a fill in the blank sort of question, and I'm actually, now I'll read through it with you.
A fast food restaurant,
Give me the Big Mac.
offers half-price meals if the customer is a student or has a discount card. Okay, so or student or. The offer is not valid on Saturdays. So those are our three conditions: student, discount card, and it's not a Saturday. Okay. A computer system is used to identify whether the customer can have a half-price meal. The table identifies the three inputs to the computer system. A represents is a student. B represents that they have a discount card. And C, the current day is Saturday. Okay. Now, the logic system is as follows: A or B and not C. Okay. Complete the following diagram for A or B and not C by drawing the logic gates in. So you've got to know your drawings off by heart. Go for it. Do your best. 3 minutes. We were, of course, looking for an or between A and B, a not after C, and an and connecting them together. Give yourself a mark out of 3 and screenshot the mark scheme. Pretty please. Do you remember how to work out how many rows would be required in a truth table for the following expression? Remember, it's 2 to the power of what? Mark out of 1. 1 minute. Go. Of course, there were 3 variables, so it was 2 to the power of 3, which is 8. Give yourself a mark out of 1. Don't forget Metagogy for this. Don't forget Metagogy to practice this. There's only a couple on Metagogy because it's so small, but there's lots of little practice questions you can do on there. Yeah, this unit is absolutely tiny, just like me. Like the slide says, yeah, I'm only 5 foot. I say I'm 5'4" just for a joke. I'm technically 5'5", but I like saying I'm 5'4" because smaller is better. So yeah, time for our exam. Revise it. If you're doing flashcards, you only need about 10 max, 1 for each of the shapes, 1 for each of the truth tables, and then some practice questions. Yeah, do your best. And again, if you're not one of my students, check the description to become one so you can access your exams. And yeah, do your best. Woo!
Bibbidi bobbidi boo.
Where is that question go? There it is. No!
So, it's nice to meet you. However, do computers understand the word bacon? Bang, bang, bang. Man, I miss the 90s so much.
Delicious!
It's code for the CPU.
It's not for you!
You are done, it's over, there's nothing left! So, it's nice to meet you. What's your name?
As well, you see, I had to turn the hill just up to my. What do I say? I had to turn the hill up to my foot there. Just.
I'm really sorry, I didn't get a word of that. I'm gonna need somebody to translate. Yes, this section is on translators, IDEs, and everything you need to program well. But before we get into that, a little bit of a recap from paper 1. Here's your do now activity. Get in those and we will mark them in just a second. Nice easy one from section 1.1. Go! The amount of fetch, decode, execute cycles per second that a CPU can perform is commonly measured in hertz. Oh, it hurts! Hertz, that's right. The previous measurement is more commonly written in giga hertz. That's right. How many is a giga, by the way? Oh, yeah, it's a billion, don't forget. A billion hertz. Give me 3 things that happened during the FDE cycle. You could have had any of the following. An instruction is fetched from memory.
The fetched instruction is then decoded, or the instruction is then decoded. The decoded instruction is then executed, so the CPU performs continuously. The program counter is incremented. Any of those that you've remembered. These are your titles for this section. Get them in. Go. So in this unit, you've been doing a lot of programming. Now, when you were writing Python, were you writing it in ones and zeros? No, you were writing it in English. What a treat! Nice and easy for you and for me. However, do computers understand the word bacon? No! Do computers understand the word print even? Do computers understand English at all? Absolutely not. They only understand ones and, you guessed it, zeros. So the question then intuitively becomes, when I'm typing my Python out in English, how does the computer understand it at all? And the answer is very, very simple. It's getting converted from what's called a high-level language that you and me can understand, we're high-level, like English, down to a low-level language or machine code that the computer can understand. Is a cheeky little visual of what's going on. You can see on the left there, we've got Python, Java, C#, all these languages that human beings can understand, going through to assembly all the way down to machine code. What does that actually look like? Don't stress, it looks like this. Ones and zeros, or occasionally hexadecimal. You can't understand it, only the CPU can. And that is your definition for machine code. Code that only the computer or the machine can understand, not written in English. Getting everything in that red circle and the example, please. You may screenshot the picture of Craig and Dave there. Go. So the next question naturally becomes, how do we get our code from English into machine code? Have we got someone in the corner of the office going through piece by piece? 1, 0, 1, 0, 1, 0. No, that's ridiculous! The truth is, there are two types of translator that we can use. One is called a compiler. The other is called a interpreter. And they both have advantages and disadvantages. If we take the example from earlier, when me and Shrek were having a cheeky chat in two different languages, a compiler would be like taking the entire sentence or the entire paragraph, translating it in one big go and giving it to him. This would have the benefit of being really, really fast because we can just crack on with the translation, pass it over, but the issue is it can take a long time to do that initial translation, to write it out in one go. An interpreter, on the other hand, just like the ones you see on telly, is going to go line by line. Compiler, all at once. Interpreter, line by line. This is fantastic for checking errors because you can go through piece by piece and see what needs fixing. In fact, let me show you. So let's say I'm coding away at my program. There's no errors at the moment, but take a look, take a watch. The second that we get an error, we start to see some issues. In fact, apologies for that. The other IDE didn't really visualize this well, so I've switched to a different one. If ever you want to use a different IDE, just Google online Python IDE. There's tons to choose from. Take a look at this with me. At the top there, we've got num1 equals 5, and we can see that there's no errors, no issues with that. But on number 3, I haven't even had to run it yet, and we can see the big X. We can see that undefined variable because I've put num2 instead of num1. It's gone through line by line. However, if I go over here and run it, you're going to see what the compiler does. Run. Boom. There we go. Num2 is not defined. Interpreter, line by line. Compiler, all at once, one big file. Interpreter, slow. Compiler, fast. Interpreter, great for spotting errors. Compiler, great for speed. In your notes, I want this beautiful table created. And you can do 2 tables of 2, or you can do 1 of 2 by 2. And I want all that in with your beautiful highlighting. This will be on your exam. Give yourself about 7 minutes for this. Go. I'm going to try now and show you a lovely little video from, I believe, the 90s or the 80s on compilers and interpreters. I think it's so charming and so sweet. Hopefully, it'll work.
When you land in the world of computers with their strange, convoluted machine language, it's a bit like landing on another planet, whose inhabitants speak an equally strange, convoluted alien language. Getting a mechanic on planet Gobbledygook to repair your spaceship would present the same sort of problem that you have when you want to get a computer to do something. Everything you say has to be translated. And you have a choice between 2 different sorts of translator. One of them is called an interpreter, and the other is called...
Interpreter, line by line, slow, great for checking errors. Compiler, fast, produces 1 file, not so good for checking errors.
...called a compiler. Let's suppose that you've previously written out your list of instructions for the repair of your spaceship. And suppose that you choose the interpreter to do the translating. He reads your first instruction, open lid of rocket engine, translates this into gobbledygook, and immediately passes it on to the mechanic, who executes the instruction. Then the interpreter reads your second instruction, remove spark plug, translates this into gobbledygook, and passes it on to the mechanic, who executes it. And so on and so forth. Now, notice how the interpreter works. He stays with you all the time, and he translates each of your instructions immediately, one by one. This is a rather slow process, because the mechanic has to wait while each instruction is being translated. But, on the other hand, it does give you a chance to correct your mistakes as you go along.
You can hear in the video there, he's saying, it's slower, but we can fix our mistakes as we go. Interpreters are great for checking errors.
If the mechanic removes the wrong spark plug, for instance, you'll see this happen right away, and you'll be able to change your instruction accordingly. Compare this with the way the second sort of translator, the compiler, goes about his work. He takes your complete list of instructions, and without further ado, translates the whole lot straight into gobbledygook. He then hands them back to you and goes away, leaving you all on your own. All this has taken some time, but from now on, things will go very fast. You hand the complete list of gobbledygook to the mechanic, and he executes them all in one go. Bang, bang, bang.
Bang, bang, bang.
There's no waiting about this time. But there's one disadvantage to this, of course. If there was a mistake in your instructions, it's too late now. This analogy comes very close to the way the interpreter and compiler translator programs actually work with computers. An interpreter runs slowly, starts right away, and lets you see how things are going. Whereas a compiler takes extra preparation time before your program can run, but then lets it run very quickly and efficiently. To help you remember the difference between an interpreter and a compiler, look at the words themselves. Inter means between. The interpreter is always between your program and the computer, and it translates line by line. Means to pile together. A compiler piles together your entire program and translates the whole thing all at once. Which one you use on planet Gobbledygook is entirely up to you.
Man, I miss the 90s so much. Let's do a little bit of recap. Pause. We've done compilers and interpreters. Here's a little bit of recap for you. So on a piece of paper, on your whiteboard, maybe in your document if you prefer. Here are you fill in the blanks. I'll give you 2 minutes, a little bit of refresh. Remember, these build up your long-term memory. They break the forgetting curve. Doing these will make your exam so much easier. You got to trust me. Go for it. Give you 2 minutes.
Okay, the first one. A compiler is fast. We just did this. An interpreter is slow. The compiler converts the whole code into one file. The interpreter converts the code line by line. Two examples of solid-state storage are an SD card and a solid-state drive. I'll never forget, my cousin goes to me one day, she goes, oi, 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 my laptop's running really slow. Can you help me out? And I said to her, I texted her back and she goes, can I put in a solid state drive? And she goes, that sounds like a posh estate where I'd want to live. Magnetic is slower, but solid state is more expensive. And again, clock speed, number of FTE cycles per second, measured in hertz, usually gigahertz, and a giga is a billion. So at the start of this, I alluded to something called a high-level language and a low-level language. High-level being what we understand, human-oriented code. So let's do a little comparison. If we do print, hello, fam. That is a high-level piece of code. It's understandable in English. I mean, don't get me wrong, my nan might struggle with print not being something to do with paper, but it's pretty self-explanatory. It's in English, right? However, what you're about to see is the same code in low-level language. Yeah, not good, right? If we look at this, we can see very clearly which one is more understandable to humans. It's, of course, the high-level code. Which one is written in English? Of course, it's the high-level code. Here's one other benefit as well. Because it's high level, above the CPU level, it is portable between different systems, meaning that if you wrote something in Python, it can work on different CPUs, like one on a Mac, one on a PC, etc. It's not built for that low-level hardware. A disadvantage, though, of high level, because obviously there've got to be some disadvantages for us to be having this conversation. A huge disadvantage is it needs to be translated. Of course, because it's not in machine code already, is it? The CPU can't understand the word bacon, can't understand the word print, doesn't get it, doesn't understand. Here's one that a lot of people forget in the exam. One high-level command equates to lots of low-level machine code. You saw over there on the board that there was way more machine code than there was high-level code, and that's because one high-level command, like a print, might involve lots and lots of different things at the machine level. And your examples are, of course, C#, Python, etc. Get this in your notes. Let's go. 5 minutes, don't forget your highlights and steal my pretty pictures. Go. The advantages we kind of touched on but just for your notes, so you've got them for the exam. It's easier and quicker for us to write. Which one of those took me more time to write? This one. Which one was easier for me to write? This one. Obviously. That also means it's quicker to understand and to read, so you're less likely to make mistakes. Or as the exam board put it, it's easier to spot errors. Because the code is closer to English. Another benefit, like we talked about before, there's less code to write because one high-level instruction represents many machine code or assembly instructions. And again, just like we said before, it's portable between different processors. So it'll work on lots of different machines. Get it in your notes, pause the video, do your highlighting, go. Is your first cheeky exam question on this. Graham, spelt in a funky way, is a freelance programmer. He's written a program for a client and gives the client both the high level and the machine code. Describe what is meant by high level code. I think this one's 3 marks. I think the formatting's cut it off a bit. Go for it. 3 marks, 3 minutes. Pause the video, screenshot it in, give it your best shot. Go. Time for the answer.
It's human oriented. It's written by programmers. It may have words for commands, like it's close to English, like print, for, and while, etc. It's portable to different systems, needs to be translated, and I don't know why, problem-based, interesting. And one high-level command equals many machine code instructions. Delicious! Well, Mr. Singer, then, what is the definition for low-level code? I'm so glad you asked! It's code for the CPU. It's not for you! It's for the CPU, it's not for you. It's ready to execute on the CPU. It's not easily understandable by humans. These are binary instructions and it does not need to be translated. You can see it right there, and we've just gone over many, many examples. What do you think, Shrek?
I think you've been talking to a cardboard cutout for far too long, boy. Now get on with the work.
Get those in your notes. Don't forget your highlighting. 3 minutes. Go. This is a beautiful, beautiful pair of exam questions that I would love you to do. Let's take a look at them together. On the left, nice simple tick box question, so you can screenshot that in and just do the tick boxes. Which one is for high level, which is for low? And on the right, we've got a nice big question. I'll talk over that before we do it. Victoria is writing a program using a high level language to display the meaning of computer science acronyms that are entered, for example, LAN and WAN. The code for a first attempt at this program is shown below. There's the code. Complete the code above to print an unknown message if any other acronym is entered by the user. So we can see there we've got selection, of course, because we've got our ifs. How do we do something that isn't one of the predefined options with an if? What's that keyword that we use at the end? Don't forget. And then at the bottom, tell me what is meant by high-level language. That is 8 marks. I'd give yourself, although a lot of them are tick boxes, so I'd give yourself about 5 minutes. Go for it. Screenshot it in. Go for it. I said, go for it. Go for it. You got this. I know you're tempted to just skim past it, but don't do that. Go for it. 3, 2, 1. For the check boxes, we were looking for the following on the left. We've got high level for English-like keywords, of course. We've got must be translated before it can be executed, of course. And it's portable between different processors. And a low-level language requires the programmer to understand the registers and structure because it's about that CPU. You've got to understand the registers or you don't understand the CPU. Do you? For the chunkier question on the right, we've got else. That's your keyword, obviously, for when none of the above have been met. And print unknown. And then at the bottom, just like we did before, it's understandable by humans, English-like structure, must be translated, and allows, if you want to do with like a problem-based, hardware-independent, portable, we're looking for. There's the keyword at the bottom, portable, beautiful, delicious. Last set of titles for this section, I believe. This is the IDE portion of the video. Do your best, get in your titles for your IDE. Go. Yeah, there's only one title. Lol. 30 seconds. This entire unit is one slide. That doesn't mean that it's easy though. The IDE that you use is going to totally depend on when you watch this video. I know, for example, Trinket is dying in 2027, sometime like that, 2026. So you might be on Trinket, you might be on a different one. You might be on PyCharm, you might be on REPL. Whatever IDE you're on, you're still using an IDE. And you say, naturally, Mr. Singer, what's an IDE? I'll tell you, an IDE is simply what we code in. So Python's the language, right? The IDE is the program or the tool, the window that we code in. And it gives us lots of amazing features, like the text editor that lets us write the code. It gives us autocomplete. Like, you know, when you start typing the pr, it's going to think you're going to do print. Stuff like syntax highlighting. So you know how, like, when you type in certain words, they go certain colours and stuff like that. It lets you identify features nice and quick and helps you to program better. When I first started coding at my first software house, we had an IDE that had no colours. Well, apart from yellow and black, and that was it. It was very miserable, so my IDE wasn't as good as the ones that you're using. Yet stepping. Features like stepping, letting you run the code one line at a time. Breakpoints. that let you stop the code at certain points to see what's wrong, a variable watch window that lets you check the values of variables as you go, error diagnostics, like telling you what errors that you've made, and it gives you a runtime environment, a translator, either a compiler, interpreter, or both. Now, I'm going to show you these features before you write them down because I think that's going to make it so much easier for you to remember. So I'm going to go through each of these now. I'm going to show them to you. And what you're going to do as well is when you've made this table, underneath, I want you to do a screenshot of you using each of these features. I can assure you that will make it go into your memory so much better than if you just write it down. So just so you know, at the moment I'm using onlinepython.com, online-python.com. If you Google online Python IDE, it's like the first one that comes up, and I'm using it because it actually has a debugger. It's got a lot of the features that we're using in the IDE today. I know Trinket, for example, doesn't have a few of these features. So you can see here, I've done some very basic code, and this code actually works, which is great, okay? So that lets me show you the first feature, which is a text editor. This lets us type. You know, I can type all as well. It is a text editor, text editor, text editor. The next feature is autocomplete. This one is nice and easy too. If I start typing it's going to assume that I want to type print. That's a win. That's easy. That saves us time and it reduces the risk of mistakes. The next one is syntax highlighting. Now, if you're astute and if you've been paying attention, you can see that that's been happening already. The fives there are blue, the if is blue, the print is blue. We're seeing keywords that are highlighted in blue. Delicious. This is what we're talking about. You know what I'm saying? So syntax highlighting. For this next one, I'd like to make a mistake on purpose so that you can see the error diagnostic sort of stuff. We'll do breakpoints first because stepping kind of comes after breakpoints. I'm going to make a mistake here. I'm going to change where it says num2 here to num3 so that we know there's an issue. And what I'm going to do is I'm going to run the code. Let's run the code like this. And we can see we've got an error at line 5. So what I can do, I can pop a breakpoint anywhere I like. Pop one there, pop one there. And if I run my debug over here, it's going to download the environment here, and boom, we can see this little yellow line that's appeared here. That means the code has stopped on the breakpoint. A breakpoint is a point where the code just takes a break, takes a rest, doesn't break it, but it takes a rest. So it's stopped right here. And we can see, I can teach you a few more features while we're here actually. We're stopped on a breakpoint and it's paused the code right there. If I go down here, I can even see the variable watch window that we were talking about earlier. And we can see all the variables that currently exist. On line 3, it hasn't run yet because it's paused there. So the only variable that exists is num1. We can see num1 there is 5 and in there it's 5. So that's your variable watch window. The next feature I want to show you is the stepping. By the way, the watch window, before we do the stepping, is super handy because if you've got like 27, 28 variables, maybe some arrays, you can see what's going on with them at any time and see what mistakes you may have made. This next one is called stepping. You see these arrows here? We can step over, step into, or step out. So if I step over, that's going to take us to our next piece of code. I can even remove this breakpoint if I like. Step over, it's going to move us here, you can see, to this line right here. Look at our watch window, that's updated now, so we've got num1 and num2 in there, which is delicious. You can see that right there. And I can step, and I can see right here, I'm paused on this line. If I step over again, the code dies. So straight away, I can see that I got up to line 5 without any issues. Error diagnostics, you've seen there when we ran our compiler. It's given us a full breakdown of the error, and we can even see there, name error, num3 is not defined. So if ever you get stuck on your coding, kids, I know it's the end of the course now, but if you ever get stuck on your coding, always read the last thing at the end of the error diagnostic. It'll pretty much always tell you what's going on. Finally, the compiler or interpreter and runtime environment. So you see we've got our text here, we've got our output window here. How did we make it appear? We click the big button that begins with R. What is it? It's the run button. Runtime environment. You can see that when we run it, it runs over here. And if I fix the issue that I had before, let's change that to a 2, and I run it, Bish bash bosh, we got a 5. We got a runtime environment. We've compiled it. The interpreter was checking issues as we went. You can even see trailing white space there as a little warning. Compiler, interpreter, and runtime environment. Now, as I said before, I want you to make this beautiful table. I want you to get in all the highlighting and all the notes perfectly. But I also want you, maybe inside the table or just below, to do screenshots of examples of you using it. This will make it go so much deeper into your brain. Give yourself 15 minutes for this. It's a big, big section. Take your time. We're going 2 across by 3, 4, 5 down, I think, and then merge the top cell. 2 across by 5 down. Get it in. 15 minutes and do those examples, please. This is the last bit of note-taking you're ever going to do for your GCSE, so make it count. Do a cheeky bit of revision for your end of unit exam. Do a Quizlet for 1 hour. Minimum 32 flashcards for this, I'd say. Yeah, I'd say so. Because you've got low level, high level, all the compiler stuff, all the interpreter stuff, all the IDE stuff. That's at least 32 cards. Go for it. Make me some nice flashcards. These will really help you in the exam. Make your flashcards. Give yourself an hour. Go. Time for the end of unit exam. Go for it. Yeah. If you're one of my students, you'll have access to this. If you're not, check the link in the description. Then be sure to mark the exam with the attached mark scheme. We are done! You are done! It's over! There's nothing left! All done. Fantastic. Could you be happier? I don't think so. Now, listen to me. This is the most important part. You now have your armor, your sword, and you are ready to fight the enemy. But you must sharpen your blades. You must revise. Use your flashcards. Do practice papers. Do your practice exams. You can get a grade 7 easily with just memory work. It's been an absolute pleasure. Don't forget, Metagogy. Sign up for Mr. Singer. Have a look at the link in the description if you want to become part of Metagogy. And yeah, Metagogy. Use it. It's a godsend. In fact, flashcards are good. Metagogy is even better. Go for it. If you want to get in touch, just below. I'll miss you very, very much. It's been a pleasure, and you'll smash it. See you soon.